We put drywall on the walls. Well, we want to make sure the drywall isn't dusty. If it's painted, you want to make sure there's no paint splatter where it should not be. And then again, if it's something like that where there's paint on other paint, that's really not a final cleaning kind of thing, because the painter overspilled the paint, and it's not your job to get paint off of anything other than tile, windows, toilets, stuff it's not supposed, mirrors, stuff it's not supposed to be on. But if you happen to notice that during your construction cleaning, and I would emphasize that if you're a construction cleaning company, because if you are taught by me, you have a very extensive knowledge of the construction field, and you will be able to identify defects in the paint looks wrong, the tiles not laid right. You'll be able to identify that and let somebody know, even though that should already be done prior to you even cleaning, because somebody should have checked that prior to your cleaning. But just keep in mind, those things are things to think about. If you're a good construction cleaning person, you're going to note all those things and let whoever hired you know. Okay, so when we're looking at the construction set, let's look at the construction set. Let me connect that now, and boom, let's go up. There we go. And now, all right, so here is, we're going to look at a Levi's. It's a remodel somewhere in America. And the first thing you want to do is look at the set, the full set, and what is comprised within the set, all the sheets that are comprised within the set. And remember, you're construction cleaning, so you just need to look at a few of the sheets, and here are the ones you want to look at. Well, you always want to have the cover sheet, right? Because the cover sheet's going to give you all the sheets comprised within the set. But then we want to look at, as a cleaning person, the first thing I notice is door and hardware schedule. That tells you all the doors. So if you have to clean the doors, you'll go there and see how many doors you have to clean. And if the doors have glass on them, you want to make sure you take that out. Okay, now glass is different. How are we going to price it? And that's the third class. Once you have the measurements, how you price each of the items, and preparing a professional estimate with each line item, meaning how many, if you have to mop, how many square feet of floor you have to mop. If you clean and carpet, how many cubic yards, and that's usually carpeting in square yards. Carpet is in square yards, tile, everything else is in square feet. If you have to clean windows, right, you have to measure the square feet of the windows times 2, right, because windows have 2 sides. So you want to make sure you're able to measure areas, and if you have to clean railing or anything that has a linear amount, a linear measure, you want to make sure you can measure lines. And so in this video, I'm just going to discuss what I'm going to measure, and then I'm going to come back after I measure and show you everything that's been measured and what it looks like. All right, so when we're doing the final cleaning, you want to look at the door schedule and hardware. You know, is it copper? Do they want you to shine the hardware? That'd be great, because that's extra man hours, right? That takes time to do that stuff. And another thing that takes time is if they have, in this case, this is a Levi's outlet, and they have a lot of specialty fixtures that they hang the pants and stuff on, and shirts and whatever. Well, if you have to clean those, that's extra man hours too that you need to take account of. And again, your specifications should detail that out. Anything with a surface, anything that could have a smudge on it when they put it together or whatever, or you need to exclude it specifically in the estimate, meaning this price I'm giving you doesn't cover that. And if they want you to cover that, and the one that we're doing, we're not going to cover that because we're kind of late getting it done. So if they want it, we can add that later. But we're going to do the main things in the building. Okay, so doors, that's definitely a main thing. Now, we're going to look at the finish schedule, page A0.A80. Finish schedule is all of the finishes in the project. Finish is anything that goes in and on the building once the building is being constructed. So a finish is the drywall, the flooring, the paint, basically all of the things that have a surface that you may have to clean. So let's go to, first we talked about the doors. So here are the doors. This is a door schedule. And it shows us how many doors we have. 10 doors, restroom doors, corridor door, BOH is back of house storage door. Tells you the size of the door. So if you're cleaning the door per door, $10, $15, whatever, $5. Or you can measure how many square feet. And remember, a door really has 6 sides, but we're just talking front and back because each of the corners is technically a small 1 inch or whatever. That's considered a side, top and bottom in the sides and whatever. All right. So here we go. So those are the doors, and then we'll have a sample of each of the doors. So like I said, if you can see that a door has glass, which is not used, in this case, not used, the glass doors, you don't have to worry about separating costs to clean glass, which is cool. All right. So finishes. Okay, so this is the finish schedule. Right? The finish schedule is going to give us all of the finishes that are in the full project. And all of the X'd out ones basically means it's not a part of this project. Okay, and so ACT acoustical ceiling tile, that's on the ceiling. I'm not certain that we would have to clean that because when they install it, they kind of protect it. But in the event we have to clean the railings or the grid, that you can always enter a price for that. And again, it should say in the specifications. There's nothing wrong with that. And how do we do that? Well, the ceiling, we have to be able to measure how many square feet of ceiling that is. And so that tells us how many square feet of that we have to measure. And we're going to look at the ceiling, the reflective ceiling plan that shows all the ceiling finishes. That's next. All right, so wall bases, that's a linear amount. So yeah, you probably wipe that down. Again, it all depends on the finish schedule, but we're going to assume that we're going to clean all of that. We have to wipe it down. We have to mop the floors. We have to do all of that. The wood base, now the wood base is painted. So I'm assuming when they paint, it'll be done. It'll be perfect. They should be protecting it. So when we do clean the floor, it isn't affected because if it's painted, that should be the very last thing. But you want to make sure you charge them an amount for an initial check. That you're going to check all of these items, and that costs them something. And if in the event you find that additional stuff needs to be cleaned, this is how much it costs. And so you'll see that in the second last video, second to the last video. Okay. So the finish schedule tells us all the finishes, cork floor, planks. Supplied, okay, by vendor. Let's see. It doesn't say that they're stained, does it? No. So this is kind of something you probably would have to mop or wipe down, okay, because it doesn't say it's stained. Because if it's stained, of course, it's going to be stained and left and covered and perfect, so nobody steps on it. But if it's not, then you probably got to mop it. Metal, we have to see with storefront metal. So yeah, you might have to wipe down the storefront, which is the front of the building where the front door is, and then all of the walls. We always going to assume that we're going to wipe down the walls just with a light, water, rag, whatever. Okay, we're always going to assume that. Okay, so, and floor tile, we definitely will assume we have to wipe that down. Okay, so however many square feet that is, and then we will take a look at all of the wood, wherever that is, plywood, veneer, the sheathing. Let's see where that is. Oh, at the storefront. So we probably have to wipe that down. Okay, so this is the finish schedule. So you want to look at the finish schedule because those are the things that you're going to have to wipe off, clean down, whatever, mop. Now, next. Now we have also accessories, right? So accessories for the, in the break room. So the hand sink, yeah, we're gonna wipe down the sinks. We're gonna clean the sinks. We're gonna wipe down the hand dryer. We're gonna wipe down all of this stuff. So yeah, we're gonna give them a cost for all of this stuff in the bathrooms. We're gonna wipe down the microwave. We're going to wipe down the stools, the break table, all of this accessories, we're going to wipe all of those down. And see, it tells us how many of them we have. One in one case, and then we have 3 stools, and then we have the lockers. We're going to wipe those down, sanitize them now with COVID. Yeah, everything includes a clean, sanitize and da-da-da. So they can tell that it's been sanitized. Okay, so manager's chair, fixed storage unit. Okay, and within the set of plans, to help you further price it, you'll be able to look at it. It'll give dimensions, and this will take me however amount of time. But if you have a good cost book, it should give you some good basics on how long something takes to clean, wipe down, mop, all that good stuff. So you'll want to look through for stuff like this, depending on the type of project it is. Right, this is a Levi's outlet, so yeah, every commercial building's gonna have a bathroom. But if it's like a bar or like an Applebee's or even a grocery store or something like that, you're gonna have a way more equipment to wipe down. Okay, so keep that in mind. All right, finished plan. So here in the finished plan, right, this tells the people that are installing the floor, the base, the wall, the trim, the ceiling. These are the finishes. Okay, and we'll have a basic plan reading for people that do this, so you'll know what you're looking at when you're looking at each of these sheets. Okay, so this plan helps us determine how many square feet, linear feet, right? Because if we have paint on, so this is telling us the floor is whatever CO2-1, and there's a list. The finished schedule gave us the list of what all of these things are, but we know it's wall paint. Okay, so we have to be able to measure from this plan, and if it's wall base, right, it's going around the base of the wall. So we measure how many linear feet, all the way in each room. If it's wall base, then it's wall paint. Right, because it's the same. These are walls, so we have the base at the bottom of the wall, but then we're measuring the length of the wall too. So that'll help us measure if we have to wipe down walls, how many square feet of wall we have to wipe down. Okay, so I'm going to come back with all of the measurements, but you use the finished plan, right, as the measuring tool or as the sheet you use to make your actual measurements. If this is what's on the floor, CT5, okay, CT5, I'll assume it's carpet. Well, I know I got to vacuum that carpet, and so I'm going to measure how many square feet in this room of carpet or vinyl flooring. I know I got to wipe it down, so I'm going to measure how many square feet in each of the rooms. That plank flooring is probably this stuff, and so I'm going to measure how many square feet, because in my cost book it tells me the cost per square foot to clean. And boom, I have an estimate once it looks real nice. Okay, so fixture plan. So these are all the additional fixtures, right, that are going in each of the rooms. And these are tags. Okay, this is basically what they're calling them and where it's going. Back of the house, 19 is something. There's a list of all of the fixtures, right? And so these are shelving, whatever. That looks like a safe. Water fountains, right? Got to wipe those down. Okay, so the finishes and the fixtures all have to be cleaned and wiped down. And then the RCP, you're going to look at that for the ceiling, right? Because not everything in the ceiling needs to be wiped down. So you have to determine what kind of ceiling it is. If it's paint, P1. And this tells you, these boxes are the ceiling tags, right? So it tells you that's gypsum, which is drywall. Says it's new, right? So it's new drywall. So if it looks dusty, if it's like a glossy whatever, I doubt you got to wipe it down. But you never know. You might have to dust it off. But still, you're going to give them a price for that. And they can determine if that's something that needs to be done. But because your final cleaning, that's going to be part of something that you review to see if something on the ceiling needs to be wiped down. That's just how it goes. And this tells you the height of the ceiling. So the height of the ceiling is 11 feet, 4 inches. So anything over 6 feet, that gives you a clue. You're going to need protective gear and you're going to need a ladder. Okay? Or anything over 6 feet. You're going to need a ladder anyway, but protective gear over 6 feet. If you're climbing ladders, make sure everybody has the proper way to climb ladders, and we'll do that in a different video. Okay, so these are the rooms, what's on the ceiling. So if it is our ACT, it's not painted. So yeah, does the acoustical ceiling tile need to be wiped down? Okay, ceiling, the reflective ceiling plan is something you need to look at as well. And then we have our elevations, right? Just to help you out. So these are those little fixtures, that we're going to delete. But this is an elevation view. So if you're standing in the Levi's store, this is what it looks like. So you want to say, you want to wipe down the walls, and then it looks like this is some kind of trim that may need a special kind of wipe down, or maybe they want you to shine it up. Who knows? It depends on the specifications. But at the least, we're going to give them a charge for just lightly wiping down all of the walls. And these are little stools in the, believe that's what these are, stools in a perimeter fixture, freestanding, and in the set of plans it's going to tell you exactly what everything is, so you won't have to guess like I'm trying to do. Fitting room. So yeah, do I have to wipe down the stuff in the fitting room? They broke it down. This is what the fitting room looks like. So yeah, you'll have to wipe down, but we have all of the doors already covered. Here are the walls, and whatever this is, is this a carpet you might have to vacuum, or a special kind of flooring you got to wipe down, as opposed to this flooring. But all the flooring you got to wipe down, so it really doesn't make a difference. Okay, benches, whatever. Mirrors in there? Are there mirrors in there? Yeah, let's see. So in the fitting rooms, we have, we have the tile. That's the fixture, finish list of all the flooring, tile, whatever. And in the fitting rooms, we have the doors, three-way mirrors. So yeah, we got to wipe down those mirrors. So we got to get in there and figure out, and it will say how many square feet of mirror, because mirror is only one side, right? We only charge one side for mirror, but it's still a charge per square foot of mirror to clean. Rear view mirror, clean it. Lounge bench, yeah, you got to wipe it down. Stools, yeah, you wipe it down. All the benches, we're wiping down everything, the hooks and everything. And you see how many you have, and you get price for one, times it by 5. Okay, so final cleaning is not easy. Okay, so this one has a lot of different things for us to, the lounge elevation. So what's in the lounge? A little bench, we got to wipe it down. Okay, so in a nutshell, for your final cleaning, you basically are going to, and here's what the Levi's outlet looks like, right, when it's finished. So as the final cleaning, what do I have to do? I have to make sure all of these shelves and everything are wiped down. Everything, all the flooring is mopped or vacuumed. The bathroom fixtures are clean. Is there anything in the ceiling I need to wipe down? And then the storefront, the very front of the store, do I need to wipe that down? And sanitize everything. There's a specific charge, an additional charge for that now that it's COVID. And that's pretty much what you need to prepare the takeoff, right? So this is just what sheets I need to look at to prepare the measurements, to get all the measurements. And you look at, again, we looked at the door schedule, right, to tell us how many doors we have. And in a set of construction documents, you have no more than what's on your list. So they're not going to say, we have 2 D01s. These are all of the doors in the project, even if they're the same type of door. Okay, so you have 10 doors, period. Then we went to the finishes. Well, finishes tell us, is it tile, is it carpet, wood, whatever, the flooring, and what we need to prepare as far as to clean it, what we need to have. So we need to see what kind of finishes we have on the ceiling, on the walls, and on the floor. Okay, so we looked at that, and then to do our measurements, we go to the finish schedule. It's pretty much the easiest way to do it because we know where all the finishes are from the finish schedule, and every set has a finish schedule. So you use this plan to make your measurements, and this box tells us what's on the floor, the wall base, the walls themselves. Is there trim in the room? Some say NA, not applicable, but some probably do. I think some of the rooms did have trim. Trim was P3, or meaning they trim the room and they painted the trim P3. Okay, because P1, P2, P3, that's a paint. Okay, so we looked at the finishes. That helps us to make our main measurements. And then what other accessories do we have to account for? The things in the bathrooms, extra things in the sales room, all of the fixtures there. Are we responsible for wiping those down once those have been set in place by the accessory contractor, the fixture contractor? Are we responsible for wiping them down? Most likely not. The fixture contractor probably is. That's part of the cost of him installing the fixtures, is to wipe them down as well. But that's something you got to get clear, because in some cases it's a lot of stuff. Okay, and ceiling, we looked at the reflective ceiling plan, because we have to at least look at the ceiling to see if there's spider webs or dust or dirt or gouges or imperfections or something that we know that shouldn't be there. Okay, and then all the little details, fitting rooms, the interior portion, all of that kind of stuff. So in a nutshell, that's what you look at in order to create your takeoff or your measurements. Fancy word for measurements, takeoffs for a construction cleaning project. Any further questions, reach out to me, Stacey Johnson at sfjohnsonconsulting.com. Have a wonderful day, and I will see you at the next class.
Alrighty, everyone. Thanks for joining again. And we are here to discuss our another section, a real quick snippet for your self-study on our electrical estimating class, pricing, and the Excel spreadsheet. Okay, so the way we win is because we use industry standard in order to price all of our labor, pretty much. I mean, we get our material prices, our material costs from our supplier, which we should, to get the most accurate pricing. But when it comes to labor, that's just as important. Okay, so the industry, much like the medical field, much like the auto industry, there are set standards for how long it takes to do something. Okay, so they know how long it takes to install linear foot of conduit or wire, or how long it takes to install a 2x6 stud. And so the way that you're successful as an estimator and successful as a company, we do believe, because we've been practicing this way for some time, is to use the industry standard for the labor portion in our Excel spreadsheet. So we know, and we're giving accurate amounts of how long it's going to take to do something. And we know how long our job is going to take, because we know how much of something we're going to do. So we know how many outlets we're installing. We know how many junction boxes we're installing. And the industry tells us, because there's an industry standard for how long it takes to do those things, the industry standard tells us it takes so much amount of time. And so that's what we use, instead of, I've been doing this for 20 years and that's never worked. Okay, so what we're looking at right here is our cost book that we use. Okay, so I just put in here wire. Okay, so the building wire, copper building wire, gives us all the different sizes, right? But here is the interesting part, and this is the industry standard part, and this is a cost book that's updated daily if necessary. And now, through what we've gone through in the past year, everything is higher, so it's really good to make sure you have a cost book or supplier that does, they update you daily. But I find that with my clients is that we have a cost book, and the cost book's not going to add overhead and, profit for selling it and all of that like a supplier would. And so I always recommend to my clients, take a look at the cost book, see what the actual price is, and compare that to what your supplier is charging. Because, depending on where the project is, we put in a zip code, and it gives us accurate prices within 5%. So it doesn't give us overhead and profit. You know what I'm saying? So having a good, accurate cost book of your own is a good policy to have, because you can see what your supplier, how much more they're charging you than the actual price. So just want to be smart on that, and maybe you can negotiate down a price if you're getting a whole lot of something. So we always want to show you how to be more efficient at what you're doing and be smarter at it because you'll tend to win. All right, so our cost book tells us all the different wires. Now, it has its own internal whatever, because you can use the cost book to create an estimate, but we don't, because we've created all of our own Excel spreadsheets based on this cost book. Okay, so first column here is the electrician. They have their own coding and then the @ sign. But this is the number that's most important. That is the industry standard number that we're very interested in and that we use on our Excel spreadsheet. The number after the @ sign is the cost unit. And what does that mean? That means that this is the amount of time it takes to install one unit. A unit in this case is a linear foot. So it takes 0.006 or 6 tenths, 100 thousandths of an hour. So 6 thousandths of 1 hour, whatever that is, right? To install one linear foot of 14 gauge solid wire based on 1,000 real totals. Okay. And so we always want to have something like this from somewhere when you're creating your estimate. So all you have to do, our clients just ask us, because it's very important to make sure you're on point, especially in competitive bidding. You don't want to guess. You want to go with the industry standard, which means your estimate is going to be tight, and your cost, when you do it our way, you'll see your bottom line is going to be pretty much your cost. So you know, this is my cost, and now I can go add a certain percentage of overhead and profit, see what I want to make, what I feel comfortable making, so you can stay competitive, because there's no sense in bidding if you're not going to be competitive. That's the whole point. All right, so that tells us that's really the important part. And then, of course, our material cost per linear foot, and we don't use this labor because we create our own labor by using the cost unit. Okay, so really for our purpose, we only use the cost book to get what the actual cost unit in terms of how long does it take you to install whatever, and then the material cost. Okay, so now we're going to go to the Excel spreadsheet. Okay, so I kind of tried to blow it up, right? So these are the quantities, right, that we got off of, and this is just in there, this is a school or whatever, so this isn't the Popeyes, okay, or the Scoops or whatever. This is the amount, so how many linear feet we measured when we did all of the runs for the wire, and you see that's just the wire, so we try to break it down and be very specific. So just the wire of all the different sizes, how many linear feet. We got the cost from the cost book, or my client actually has their own. That's why I was mentioning you want to get a cost book that doesn't add an overhead and profit because they're selling it to you. Because theirs was like a lot, which is understandable. The company has to make money, but you just want to be aware of what their cost is. So it's the cost. The Excel spreadsheet does the math for the total material, right? So it'll do this, so you never want to put anything in that square, you'll mess up the Excel spreadsheet. So what does it do? It just takes the quantity, times it by the cost, and then that's the total material. Okay, and then labor rate, whatever you choose it to be. And then this is the cost unit. So that's what you get from the cost book, that after the @ sign number. Okay, so that tells us what for MC cable, it takes 11 thousandths of a man hour to install one linear foot. So for all of that, for 4,635 linear feet, it's going to take them just under 51 man hours. Okay, so you can add everything all the way down. You'll know how many man hours in total your job is going to take. And then you can determine, okay, I want the job to take, and let me try to pan into the man hour. Okay. So imagine, this is your man hours, 580. Well, depending on how many men or women, right, you have on the job, you can knock off 40 hours a week, right? So if you have one person doing all this, which we doubt, you'll knock off 40 hours a week because typically we work 40 hours. But if you have a 3-man crew, right? It's 120 hours a week or person crew you're knocking off, right? So you can determine, right, 40 hours per person times 3, that's 120 hours. So you can determine how long your job's going to take. If you want to hurry and do it faster, then you put more people on it sooner, that kind of thing. So that's another wonderful aspect of the Excel spreadsheet, is that we can use it to determine a lot for our project. All right, that's too little. There you go. That's too big. Somewhere like that. Okay. So all of the wire, all of the conduit, same thing, same thing. And then all of our wiring devices that we counted with our counting tool. And make sure, you break them all up. If you have duplex above the counter, duplex below the counter, duplex in the ceiling, you want to, waterproof, quads in the ceiling, whatever. Junction boxes for okay, well, I needed a junction box for this because, all of the data and phone, our high voltage electrician supplies the junction boxes. I'm sure you're probably an electrician taking this class. So you want to break it down for you and for your client so they can see, okay, and, or for the GC so they can really see you're doing a good job, that everything is here. So I think that's it. I mean, as far as pricing is concerned, you want to make sure you have a good cost book for the regular stuff like the outlets, but you always, always, always want to send your single line diagram and, for your switch gear to the supplier, for your breakers, for all that stuff, because you always want the latest to date from the date of bidding, right? You want what was the price on the date that I bid the project, because this stuff goes up and down so fast and so crazy. Okay, so I think that's it as far as the pricing in the Excel spreadsheet. Just make sure you have your labor information. The number after the @ sign is the number that goes in our Excel spreadsheet, man-hour unit. Helps us determine how many hours the job is going to take. You're very accurate when you use the ones from the industry standard. Therefore, your estimate will be tighter, more concise, and you'll probably be like 1 or 2. My clients are typically 1 or 2 out of all of them. And this is the reason why. Very accurate takeoffs using a very accurate digitized software. You can't mess up your counts unless you're being lazy. And then pricing comes from the construction industry in terms of your labor. So you're doing things the way you're supposed to do. All right, so if you have any questions, please sign on a morning through evening office hours. You can go to our website homepage, bottom right, and sign in for that. And now through, I don't know how long, if you're in Sacramento, we will have a representative and have you enjoy at morning or afternoon of Topgolf, which is a lot of fun, trust me. Any questions at all, please let us know. But again, sign up for office hours. And our last little snippet, I think, on this one is what? I don't know. Maybe we're finished. I'm not quite sure. Oh, specifications. So we're going to go backwards and look at the specifications and where you need to go in the specs, why it's important, and all that good stuff. All right. Thanks for joining me. Here we did it again because we're so smart. It's your teacher, Stacey Johnson, and SF Johnson Consulting and Construction Services, where we love you. Talk to you later. All right, everyone. Thank you for joining and coming back to our electrical estimating class. In this little snippet, we're going to go over the details on what's important on determining our wire and conduit runs and how we approach it. Okay, so first we're going to begin with the the lighting plan. And so depending on the architect or whatever, the electrical engineer, the amount of branch circuit runs that they show you will be there or they may not be there. But it's just kind of like a rule of thumb. uh, when approaching this. Okay, so we know that our lights are controlled two different ways, either directly by a toggle switch or they're controlled by lighting control. And so the way that we know that they're controlled by lighting control, the subscript on top of the or somewhere near the light will tell you which lighting control the sets of lights are attached. Okay, so in terms of running our conduit, we basically just have to say, okay, which lights are run together. So all of these LL1s are going to the lighting control they call D. So we run them all together where, excuse me, these lights, I don't know why my throat always needs to be cleared once we start. Um, and then these LL4s are controlled by A. Okay, and so what we are trying to do is, every electrician, every estimator is going to have a different way of running it because there is no set way. But you want to just do a good enough job or a well enough job in order to say that you've covered everything. Okay, and so on this set, they're showing us some branch circuits and then they're giving us lights that have no connection. So we pretty much have to use our imagination on how to run them. Okay, and I have a lot of clients that are electricians, and I mentioned the way that I do it, and I've never got kickback, and we've won a lot. So again, if you have 10 electricians, there'll be 10 different amounts for the electrical estimate. But the one thing you can guarantee yourself, if you have a methodical way of doing it, that you're going to be on point pretty much all of the time. Okay, so again, it really depends on how much information they give you on the plan itself. Okay, and so the way that we do it here is two ways. We have the branch circuits that are shown. So we'll just measure those. How many linear feet exactly, right? Because the plans are to scale. So if that's 12 feet, 10 feet, well, your actual amount of linear feet for that conduit stretch is 10, 12 feet. And so normally for branch circuits, they'll use MC cable. And then for all of the home runs, they will use the wire configurations, number 12s. All right, so for your lighting plan, in order to do the runs, you just first make the measurements of what you see. And then, as we do here, kind of just connect all of the ones that have the same subscript, maybe not more than 6 at a time. Really, and more than 6 or 10 at a time, and cut it off there, because at that point we're going to run it to the lighting control, which is represented right here. Okay, so that's just the switching lighting control. Okay, for LC1, LC through LC2, LC3 lighting control, lighting contactors. Okay, so again, it really depends on the plan. It really depends on what's given. And so we will run all of our branch circuits, MC cable that we would normally in real life run with MC cable, run that all together. That would be this was shown and this what we had to make up. Okay, so we would have to continue through. All the A lights, we'll run them all together. And then all of the night lights, right, are all run together separately. So this would be run with any one of them, even the emergency lights, they're all run separately. They wouldn't be run with our regular lights. And so, in this case, with this type of configuration, it's pretty much a crapshoot. But as long as you are covering everything, as long as everything is covered and you're running everything to the lighting contactors, so you can imagine by the time you finish, it's going to be a spaghetti mess. All of something like this is going to be everywhere. But that's what it's supposed to be, because that's what it would be in real life. And so, you want to make sure, and what I typically do, now the panels, the one thing for the lighting plan, okay, because it only shows you all the lights and how they're controlled, it will not show you in great detail where the power panels are. But this one does show you, it gives you the A, B, and C, because you have to run the home runs here and the distribution panel, okay? And so, for instance, like these lights, all the A's, looks like they're running to lighting control C. And so, yeah, we would run these all together and then crisscross them. And then usually no more than these would run together. And then we would run, every 6 or 8 lights together, depending on the lighting control. And then the night lights, the NLs would all run separately together. Okay, so the whole point here is if you have 10 people, it's going to be 10 different things, but you want to make sure you just cover everything as best you can. Where it should be a branch circuit similar to this. We run it here, and then we've got to run a home run because, this is going to position number 7 on panel B. So, we've got to run it there. Okay, so we've got to account for the conduit in the best way we know how, in a methodical way. So we're accounting for everything. Okay, so that's the lighting plan. The power plan is going to be even crazier. Okay, because in the power plan, okay, so you see that some of these are run together. So this means that the outlets are going to position 10, panel B, similar to the lighting configuration. So we can run branch circuits, all of that together. Stop there. And then we can connect this up to 6 circuits. So we connect that and then run it to the home run. Connect these and run it to the home run. Okay, so in the instance of these are going to panel A, position 6, so we can connect these. So anytime you see they're going to the same position in the panel, the imaginary conduit can be used to connect it. And a lot of times on the power plan, everything is its individual home run, like this one. Junction box, home run to, panel C. Positions 1 and 3. And a neutral. Okay? So 42, 42, we can run these together. 42. That's why this takes a little time, because you have to have an eagle eye. Make sure you're running everything together. And then running the home run to the panel. So you can imagine by the time you're finished with this, it's going to be spaghetti too. So normally you will start, got to read note 4 to see if there's something else. It's a waterproof switch of some kind. All right, so like here, home run, going to the distribution panel. 4 number 4s, 1 number 8, ground in a 1 1/4 inch conduit. So this is to scale, right? So physically this on the roof. So you want to give it an extra 10 or 15 feet to go up to the roof and additional to go through the roof. But our job here is to get pretty close, pretty close and accurate to a nice representation of the conduit and wire for the power. Okay, so, we could physically run it from the breaker to right here. So however many feet that is, that would be however many linear feet for this, plus about 10, 15 feet because it is on the roof. Okay, so in the same way, branch circuits can be run with MC cable, but home runs always have to be either what it tells us it is, or typically number 12s. And everything's running to panel B, A, or C. And so our job as estimators is to do our best to see in real life how many linear feet of any wire that's associated in conduit, associated with this project, how many linear feet do we need? And this is a very tedious job when you're talking about the power plant, because you have to take into account everything. Okay, so we have a home run from the condensing unit, and that's again on the roof. And so we have to home run this configuration to the distribution panel. So it's however many feet here, over. And that's typically, we try to keep some uniformity about it. We're not just going to say here and then there. No, we just try to keep uniformity when you're running everything. because that's what you would really do in real life. You wouldn't just run it all over the place. So you try to be uniform in the way that you lay down the linear feet. So in the same manner you would have to do it, okay, if you did in real life, okay? So now we're always going to need how many linear feet from the distribution panel. And in this exercise, we have a transformer, and I believe the transformer is on the site, right? It's on the site plan. So, we'd have to go get the site plan, figure out where it is here, and then bring that underground feeder to the breaker. It doesn't even show that here, I don't believe. Just the distribution panel. Okay, but there is a transformer, a meter, and all of that associated with this that we would see on the site plan. And we'd have to go and figure out the physical distance from the site plan transformer to the distribution panel, right? But we can use this, and I kind of already did it, because in our single line, right, we have to have a certain linear feet of power feeder that's going from the distribution to all the other panels. So I was like, okay, let me measure the length of from one end of the distribution to the other end of the beads to see what our maximum length away in real life these panels are. So as we can see, they're very close to each other. They're, not far at all. So when I have to go to the single line and determine, and let's just do that real quick. Go to the single line, right? And now determine, let's go here, because the single line is just going to show us everything in a line. It's not going to say how many linear feet these things are apart. That's why we have to go to the actual plans, right? The actual sheets, figure out where is this physically on the sheet? Where is that physically on the sheet, and measure the distance, because we have to what? Determine how many linear feet of number 440, to connect these two. Same thing with here, right? For this connection, and this connection, and this connection. And then we have to, the lighting contactors, we got to figure out where they were. It did show on the plan where they were. Well, the switches, it showed where they were. So we're just going to assume, well, you can't assume, but it really didn't show on the plans where the physical location of these were, but you have to do something when you're doing an estimate. So yeah, I'm going to assume that they are above, just like this, and I would give these lengths to maximum 10 feet each. And as you can see, they're not marked like these are, right? It tells you what they need that to be. So to me, that would tell me it's just number 12. Or if I look at the lighting contactor configuration, it probably tells me what that is. Okay, so single line diagram is not going to give you any information about the physical distance between the distribution panels and anything here. That's why you always have to go back to the power plan and say, okay, where's the distribution panel in real life? Oh, okay, they're right next to each other, so they're not more than 5 feet apart. So I would say 5 feet from there, and then 10 feet just to be generous, and then 15 feet. So you can determine all of your, let me go back. Now you can determine all of your power feeder lengths. Because yes, all of the individual panels are fed from the distribution panel. So yeah, you need to know the length of this to determine this, the length of that to determine how many linear feet of that, and the length of this to determine how many linear feet of that. So you have to go to the physical plan. This is simply for information purposes, for you to send to the supplier and you to get information about the panels, but no distance, length, anything like that information about the length of the feeders. All right. Now let's go back to, okay, so for the lighting plan, okay, the imaginary links, because we know that the light to control by lighting contact or directly by switch. And the subscript on each one tells us which lighting control each one is controlled by. Therefore, we can connect these in tandem, right? Like these are. And I would say, just for simplicity and safety's sake, don't connect any more than 6 or 8. And then those 6 or 8 are going to be run to the lighting contactors. Just run to here for simplicity's sake. Okay, so you got imaginary connect to all of these, just like these, then get your total. And you go to the power plan, very much more difficult. And so the subscript, uppercase subscript, if I see uppercase subscript are the same, then that tells me I can do like I did tandem with the lighting. But if they're not, then each one of these has its own home run directly to that position on that panel. Like these are same position 25, connect in tandem, run to the home run. These same position 10, run in tandem, go to the home run. 27, go to the home run. Okay, so that part's a little more difficult, and start at one end and then work your way out. That way, as you're working all of your links to the panel, you can see. You can see. Okay, because once you start here, you can't see. So you can't start here. Okay, don't start here and go boom, because this will be all messy by the time you're trying to determine the lengths of these. So start at the nearest one, closest to the panel. So I'm going to run it to DP. Here's DP. I'm going to run it real nice, boom. Then I'm going to look and see what 4 is telling me to do. Then I'm going to run that to what A, boom. And then what's next? Let me run this one, closest to the farthest out. A22, I'm going to come in the building. A, boom. Okay, here's another one. Distribution, da-da-da-da-da. Right here and up and here. Got to make sure I mark this so I know it's a different wire than number 12s. Okay, so wire and conduit runs are last because it is the most challenging and it takes the most attention and but as long as you are accounting for everything you see, you're going to be fine. Add 10%, you're going to be even better. Okay, so that completes the electrical estimating wire and conduit run little snippet to go along with our classes. Does it make a difference? The set of construction documents, the set of plans you receive, we're going to measure branch circuits we can see first. So we're going to measure those first. Then we're going to start to tackle the ones that we know. We're going to connect the ones that we know are all on the same lighting control. And then we're going to run the home runs. And we run the home runs. Okay, so any questions or concerns, please sign up at our homepage at sfjohnsonconsulting.com. Lower right, you can get online office hours to fit your time and your availability because we do want you to learn this and to be totally awesome. Meet us for the next class, which is pricing and programming the Excel, or formatting, I should say, the Excel spreadsheet. Thanks a lot, guys, and I will see you in our next class so we can just stay so awesome. Have a good everything. I'll talk to you and see you guys soon. All right, everyone. Thank you for joining us again on this little online education snippet. And this time we're going to be talking about the electrical specifications, right? So the specifications are the written words that go with the construction documents. And everything in the project will be represented, if it is a part of the project, will be represented within the specifications. And so it is wise to make sure that you read the specifications with respect to your scope of work. So for the electrician in the current format of specifications, the electrician should be looking for his information under 26000000. And so and remember what we have here, what you've been given in class is the master format. So that master is everything in the construction industry, right? So every project's not going to have every scope of work in the, that's in the master format. And so, of course, there'll be pieces and portions of your electrical specifications that will be missing, right? And that's okay, because that just means that that is not a part of your project. So your specifications will only give you what is specific to your project. All right. So again, for the electrician, we're going to go all the way down to 260000. Almost made it. All right. Integrated automation network. So the low voltage electrician would probably be looking at a lot of the 25, 00, and maybe you too. It may point you to some of the 25. Okay, and the plumber may get pointed to some of the 25 and vice versa, back and forth. All right, so your 260000. Everything is here, so this is the master format, remember. Okay, so schedules for electrical, so all of your schedules, if it applies, you would look here, 260600, okay? And just, whatever applies to your project will be there. Okay, so all your low voltage requirements, wiring devices, what we need for that, real easy. So just make sure you look over the 260000. And for your quiz, I'll say that you are doing a particular thing within the electrical scope of work. And saying, hey, you're doing this and that and whatever. And you have to give me the exact spec number. Okay. So just keep that in mind. It's real easy. Okay. Communications. So, yours pretty much starts at 250000 all the way through to 270000. All right. Remember, if you have any questions with respect to anything in the electrical estimating class or any class, you can sign up online office hours. Go to our website, sfjohnsonconsulting.com. Lower right, you can fill out the form and tell us what time is good for you, and we will set a time for me to meet you. All right. Thank you very much, everyone, and make sure you get your homework done. That's what good kids do. Talk to you later. All right. Thank you, everyone, for joining us today. This is your teacher, Stacey Johnson with SF Johnson Consulting and Construction Services. And we are going over electrical estimating and the power plan and what we need to look at and review for our electrical estimates. Now, the power plan is a little more difficult because we need to focus in on everything on the power plan to make sure we are really paying attention to detail, and also that we are looking at every one of the keynotes marked here 2, 8, 18, 6, 7, to make sure we understand what we need to supply the electrician in terms of everything that's on this power plan. So the power plan is going to tell us everything that needs power. So all of the outlets and how they are connected to each of the power panels. And remember, this class, we're not going to go over how we are doing the wire runs. Okay, that's going to be a separate class. But yeah, each of the duplex outlets are going to need to go to, or going to need conduit and wire that goes to a particular panel at a particular position. And when we get into that, we'll know that we can run some of the panels in tandem because they are all going to the same position on the same panel. Okay. But as far as our estimate, we just have to be very accurate in counting everything that's on here. So in this instance, these are symbols for black is for a telephone or voice. White can be for data, but here it's saying a telephone outlet. There's a notation of C, so that could mean it's probably in the ceiling. Okay, so it's really important to look at all of your symbols. Make sure you understand everything when you're doing your counts. And again, all we have to do is make sure we have an accurate counting tool So we can click on a thing, click on something, and know that we have counted it. Okay. And two, you got to make sure you pay attention to all of the keynotes. Okay. Integrated ground in the ceiling. Okay. So, with the electrical trade, there's little quirks here and there. But the main thing you have to understand is when you're looking at symbols, say for instance, this one and this one, they look the same, but they're not, right? Because both have the prongs, right, coming out the right. This one has prongs coming out the right, but this one has prongs coming out the left, where this one does not. And so the biggest issue, because what you're trying to do is count all of the individual wiring devices. That's what we're looking at, all of the outlets, all of the everything, switches, if they apply to our power components, like this switch. Okay, so we have switches that are on our lighting plan to turn on our lights, but we have motor controlled switches on our power plan to turn on our mechanical equipment, such as fans, and this is probably a fan in the office. Okay, so it's very important, until you get the hang of it, you need to make sure you print all of your symbols, because you'll have to count a switch, a motor rated switch. That's what that is. And read note 22 to make sure you understand if there's anything that goes with that you need to supply. Our whole point in doing a takeoff, right, is to make sure we count everything accurately that the electrician needs to produce his estimate. Okay, so these are symbols for special receptacles. Okay, and it's telling you the kind, NEMA 1530. Okay, so that's different from the regular duplex receptacles. Okay, so for the electrical plan, and this is a restaurant, different equipment requires, of course, as we did in the basic class, different equipment may require different wire configuration, right? And so it's important for you to find what that is when it comes time to run the wires, okay? Because as we know in commercial, most of the wire configurations are number 12, right? 2 number 12s and 1 number 12 ground. That's what we'll run for the typical outlets. But anytime we see a special outlet or any of the mechanical equipment, or if we look at the breaker, the panels, and we see that any of the breakers require a 3-pole breaker, chances are it's going to be a different wire configuration to run our wire. But again, wire is later. Okay, so for your power plan, for our takeoff, just start counting. It's really important that you have a good counting tool. So when you've counted this one, it's counted, there's a mark on it, you're not going to overcount. When you've counted each one. And it's very important to, where are our keynotes? Okay, so, you don't have to read them all crazy, but you do need to make sure you note for anything you need to add to our takeoff, right? Okay, 3-pole, 30 amp NEMA, disconnect. Okay, so the disconnects are different than the breakers. Okay, so we need to make sure we note that. So anywhere we see the number 3, that's what we have to provide. So it's really important to make sure we look through everything for what we as the electrician have to provide. Okay, NEMA 4X stainless steel enclosure mounted on the face of the hood. Provided by the hood manufacturer. Okay, so what does that mean for us? That in this case, we just need to determine the labor to install that. That's why it's very important that you go through the keynotes and make a list of the things you need to include based on your keynotes, the things you need to include that are not specifically on your plan. Okay, so here for a restaurant or anything is going to tell us all of the equipment, right? But then it's also going to tell us the wire configuration, right? Because most of it is number 12. But then we need to know if we need more. See, here's some number 10s for the microwave. It's going to be hardwired, right? So that's a number 10 wire. And so we'll know when we do our wire runs, wherever D20 is on the plan, D20 notes that it is the microwave. Okay, D20 is right here. Okay, so we have to do the physical run to panel A, position 3941, because we have we've got whatever 4 number 10s or something. Okay, so that's up to the electrician. Okay, how you connect it to the panel. All I know is I know from my panel schedule that I need number 10s for that. So I'm going to do an accurate physical measurement that I need, 4 number 10s for the microwave in a 3/4 inch conduit. Okay, so our goal for our takeoff is count, 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 count. Okay, count accurately. Make sure you know the differences between integrated ground. I always let my clients know, okay, we have some dupes that are duplex outlets that are normal, whatever. And then we have some that they note as integrated ground. So they'll know, okay, well, I have to, for their expertise, they need to know that, right? I don't need to know it, but my job as the estimator is to, break down this with precision. So they'll know, okay, I need 8 of these, 6 of these, 12 of these, whatever. Okay, and yeah, so that's the power plan. That's part 2 of our takeoff, okay? And again, if you need help, if you're in our estimating class, you get the 5-week, 6-week one-on-one class, but you also get a year of shadowing where I will review your stuff with you to make sure you're doing this stuff correctly for a full year. Because, a year of doing this one-on-one and the way your companies work you, okay, you're doing a lot of big work. Okay, so we're going to make sure you know what you're doing. All right, so thanks a lot. This is part 2. The next part, we're going to go over probably the single line diagram, what to look for. We're going to leave the wire and the conduit stuff for last. And one thing I want to make sure we know, and we'll note that on the data and telecommunications plan, is that we're the high voltage electrician, right? So we only are concerned with high voltage. We're concerned with powering up everything and providing lights. Okay, we're not concerned about data, phone, but as the high voltage electrician, we do have to provide the junction boxes, okay, that the phone, computer, Comcast, all those people, they provide their outlets, but we do have to provide the junction box, okay? So we make sure we have to count that, and usually it's a 3/4 inch conduit connected to the junction box to the right above the ceiling. So that's a little rule of thumb. You always got to make sure you account for that. All right, so that's going to be it. I wanted to make sure I added that. Look for the next class. Remember office hours. And again, your awesome teacher, Stacey Johnson, owner-operator of SF Johnson Consulting and Construction Services. Don't it sound like we have fun? We do. Talk to you guys later. Hi, everyone. Thanks for joining for this class today. In this electrical estimating class, we're just going to go over a brief overview of the lighting plan and what you should be thinking about when you are preparing your estimate for and in terms of looking at your lighting plan. Of course, the lighting plan is going to show us all of the lights in the project, where they're located. May give us some information about the branch circuits, the wire configuration for the branch circuits. It may already be there, but as you see, a number of the lights, the fixtures, there is no wire configuration, so you don't really know how the wire is going to run. So you really need to be thinking about, when we go over how to run the wire, because there'll be a separate little class for that. Okay, so we'll be going over that separately. But in this class, we'll really be going over, what do I need in terms of the lighting plan, in terms of the items that are there. And we'll do, again, the conduit runs separately. Okay, so what do we need to look at, or how do we approach the lighting plan when we're doing the estimate? Well, really, the only thing we need to do is to make sure we have a proper way of identifying between the different types of lighting fixtures. Okay, so these lighting fixtures, they are called LL4. Okay, and it's really important that when you're counting your fixtures, some are NLs, night lights. So you want to make sure you distinguish between, in this case, the LL4s that are regular and then the LL4s which are night lights, because in terms of the electrician, they will have to get special adapters for the night lights and run them, different. And just a brief overview on why do we have the lowercase alphabet on some of the light fixtures, okay, as opposed to, in this case, having them connected to an uppercase slash number. Well, that's how the wires are configured, or how the lights are configured, or how they are powered. And remember, when we directly connect a fixture to the switch, that is a direct connection. So that's a representation of a toggle switch. So that light is directly connected to the switch, meaning when the switch is on, the light is on. When the switch is off, the light's off. And that's how those are represented. As opposed to when we have the lights that have the lowercase alphabet, so some are A lights. In this case, we see one has a D light. So those are controlled by lighting controls, right? And so when it comes to running the conduit between the fixtures, because we don't see it here, so we're going to have to use our imagination on how the electrician would run the conduit. Well, all of the D fixtures are all run together because they're all controlled by the D lighting control. All of the A fixtures are run together because they are controlled by the A lighting control, and so on and so forth. Okay, and the C lighting control, see, that should not have been connected to that because that's an A. And oh no, these are A's. These are light C, light we call C. So uppercase is how we identify the fixture. Lowercase, in the terms of the lighting plan, tells us how we are going to, what lighting control circuit the lights are going to run. LL2 right here is going to be controlled by the E lighting control, A lighting control, and so on and so forth. So when we're doing our estimate for our lighting plan, we just have to make sure we have a simple way of counting all of the individual lights. We don't care ABC, but how many LL1s, how many LL4s, how many LL2s, and so on and so forth, and make sure you always signify between the night lights and the regular lights. Okay, so you want to make sure you look at the keynotes in the event there's something you need to add in terms of your lighting. And in this case, emergency exit light doesn't have a notation, meaning it doesn't tell you what type of light it is. So in this case, there are two scenarios. In this case, it may already be existing, but if it is, it should be it should be gray, not black. So I have to think in terms of, okay, sometimes these lights, they don't give a notation to, but they are on the lighting schedule. Okay, so you just have to name it. Where this one, see, this is different from that. It has the EM, so you have to make sure when you're doing your counts, you count these two would not be counted together. And it's very important on all of this stuff. If the note or if the fixture isn't exactly the same, then it's not the same light, so you would not add it in the same. And that's where most estimators make the mistake. They'll count this one along with this one, but they're not the same. That's an EM, that's an emergency light, where that's just, it's not wired in a different way, so you wouldn't add them or say that they're the same fixture. So for the lighting plan, the only thing we're doing is trying to count all of the different types of fixtures, how many of each. We're going to count, do we have junction boxes? Okay, and pretty much that's all you have on the lighting plan. How many switches do we have? And so the key to, this is to make sure you have some type of tool to accurately count so you don't miss something or that you don't overcount. Okay, so that's the lighting plan. And the only thing we're going to cover here is the fixtures themselves, because we're going to have a separate video for how we determine the wire runs. Okay, so again, lighting plan shows us all the lights within the project. The one thing we have to make sure we do is get an accurate counting tool so we can make sure we don't miss anything, and also make sure if a light, in this case, excuse me, this is a night light, so we're going to count these separately because it does make a difference. So not too difficult. Just make sure you have an accurate counting tool. You pay close attention to detail. Okay, if the fixtures are not exactly the same, then you don't count them together. Okay, so pretty simple. So we start with the lighting plan because that's the easiest thing. And our next class is going to go over the basics of what we need for our takeoff for our power plant. And we shoot. If you have any questions on anything, remember that we have online office hours every day, Monday through Saturday, from 7 a.m. Well, really, the online office hours we like to have from 7 a.m. to 10 a.m. But we will schedule those at your convenience. So you just go to our homepage at S as in Sam, F as in Frank, JohnsonConsulting.com. On the lower right, you'll have a tab where you can sign up for online office hours. Give me your availability, and we will definitely set a time to give you some extra time, okay? So look out for the next class. It's going to be our details, what we need to look for when we do our takeoff for our electrical power plant. Hello, everybody, and thank you for joining me. What we are going to discuss today is in our electrical estimating class, a little snippet on the single line diagram, what we need to be concerned about, what we need to look at, and then the panel schedules as well and what's important. Okay, so this is another part of our electrical estimating class. And two, remember, if you need additional help, sign up on our homepage. Let us know with the online office hours and just pick your day and time, and then we'll make sure to give you additional time. But for now, let's get into the single line, or we also call it the one line diagram. And the purpose of the one line diagram is to show us all of the power components in one line. Okay, so it's not to scale, so it's not a actual physical representation of where the physical locations of each of the items listed on the single line or one line is located. It's just a representation of all of the power components, what will be required, all the power feeders. So you can look at this and basically make a checklist of everything you need as far as your switch gear is concerned. Okay, so we start over here. It goes from right to left, and it gives us our information on our transformer, right? Our power comes in from the utility, hits the transformer, right? So it's going to tell us the power of the transformer, so we know basically what we need to order from our suppliers in terms of the switch gear. It's going to also tell us all about our power runs and our feeders, right? So from the transformer to the main breaker, this is the power feeder configuration. Okay, and so what you have to do is go to the physical plan, go to the site plan. Okay, so the site plan is going to tell you where the transformer is, and it may also tell you the approximate location of the breaker box or the main breaker, and then you can do a physical measurement of this actual length. Okay. All right, so we go from the main breaker, the meter, the main breaker, and again, it's going to tell us all about our power feeders from the main breaker to the distribution panel. Okay, so, we can look here and assume that, of course, from the transformer, this is probably PVC, right, underground. So we have to adjust our material type accordingly. Okay, so once it comes up, we're going to change here. Maybe it's rigid steel at this point, so that's things to take into account. All right, so we make it to our main distribution panel. And then from the main distribution panel, it's going to tell us it's the mama panel and all of the babies, right? And then lighting contactors. So our single line diagram really just tells us all of our switch gear and gives it to us in a nice picture, right? So we can make our list. We can actually, know what we're gonna require, what we have to order in terms of our switch gear, and most importantly, the power feeders. Okay, and again, not to scale. So you have to go to the physical location on the power plan. Where is the distribution panel physically located? Where is panel B physically located? And I'm sorry about that. Where is it physically located? And then we need to take the physical measurement so we'll know the exact amount of conduit and wire that we need for each of the runs. Okay, now the panels, right? So we have panel A, B, and C, and the distribution panel. So here we need to always make sure we look at our panels to determine the circuit breakers. Okay, so we have to look at each one and use a counting tool of some kind, okay, because that is very important that we don't leave out the breakers for each one. And the good thing about our panels, some of the panels will show us the different wire configurations for the different types of equipment. In our power snippet on our power plan, where there was a schedule, right? There was a schedule telling us if the wire required for the pieces of equipment for each of the items was something other than number 12s, right? Because the typical, and doing this for so long, whatever. Usually if we have a 20/1, 20 amp, 1 pole breaker, this is usually a number 12 circuit, right? It's only when our breakers are something other than that. Okay, so this panel B, primarily it's a 42 position panel. And then we have to make sure, it alternates. 1's over here, 2's over here, 3, 4, and all the way down. So we have to make sure we count, go to each of the panels, go to the panel schedule, count each of the different types of breakers. So that's panel B. So distribution panel, that's where all of our the distribution panel is the mama panel, right? That feeds all of the other ones. So of course, the breakers for these panels are going to be a 3-pole breaker, right? So we know that that's 225 amp, 3-pole. 225 amp for the B, 3-pole. Okay, so we have to make sure we go to each of the panels and count all the individual types of, so the Chubb warmer requires a 60 amp 2-pole breaker. And so I know that the Chubb warmer also is going to require a different kind of wire configuration. Okay, anything other than the 12-1, okay, anything other than the 21, right, 20 amp 1 pole, it's probably a different wire configuration. And when you're doing your takeoff, right, you got to make sure that you have the correct wire configurations and links and conduits for everything. So all of these, right, will most likely not be, 2 number 12s and 1 number 12 ground. Okay, but again, we have a equipment schedule that's going to tell us what the wire configuration for each of these pieces of equipment need to be. And so what do we need to do again? We have to go to the physical power plan and determine the physical location of the walk-in freezer as opposed to the panel it's being connected to, which is the distribution panel. So how much is the physical link between these items and the distribution panel? And that's how we determine the physical length of all of our conduit and wire. Okay, so the single line diagram, in this case for our study set, okay, is good because it has all of the panels and then all of the panel schedules. So I can line them up, determine my switch gear, and then go to each of the panels and determine how many of the different types of circuit breakers do I also need to order when I order all the panels. Okay, so this is a brief discussion of the single line diagram. Again, It gives us all of the switch gear, the power components in one line, single line, one line diagram, either way, however you want to refer to it. And this one, in this case, is a 600 amp system. Okay, so transformer with the size, conduit, main breakers, meter, so we can determine how much power we're using. So from there, we feed into the distribution panel, or basically the mama panel that feeds all of the other panels. And this is where our main HVAC, our distribution panel runs probably our HVAC equipment, all of the big, heavy power requirement items. And where our panel A, B, and C will run all the lights, all the outlets, all the equipment with the wire configurations based on our equipment schedule and what each of these pieces of equipment need. So when we're doing a restaurant, it's time consuming because, yeah, the restaurant has a lot of equipment and the equipment isn't all number 12s. So you got to go in there and make sure very accurately that you're measuring and each of the pieces of equipment to determine your accurate wire and conduit lengths. Okay, so that's a single line diagram. If you need additional help, please sign on at our website, www.S as in Sam, F as in Frank, Johnson Consulting.com. Lower right, you'll have the online help, and we will definitely set a time at your convenience to help you in any way we can, because we want you to be as awesome as we are. All right, so the next set will probably involve our wire runs, or yes, and then after we finish that one, we'll go into how we do the Excel spreadsheet, how we do the pricing, and all that good stuff. All right, thanks for joining, and I will see your awesome self in class very soon.
Hello, and thank you for joining me. This is Stacey with SF Johnson Consulting and Construction Services, and in this small video, we are going to discuss the 7 steps to making a scope management plan. This is part of our 6 or 8 part series on the full scope management course that we hope you will join us any day of the week, Monday through Friday. Feel free to visit our website at S as in Sam, F as in Frank, JohnsonConsulting.com. And today, let's talk about the 7 steps to making a scope management plan. Now, if you haven't been to any of the other classes in general, a scope management plan is the plan you put in place to complete every aspect of the project, from the planning process all the way to closing. And so the scope management plan gives us all of the steps that we need to encompass or think about when we put that plan together. So the first thing to do is to think about the project requirements from the stakeholders. Okay, so the stakeholders are anyone who has an interest in the successful outcome of the project. So that can be the owner, that can be insurance companies, that can be investors. You know, they may have things like cost restrictions, time restrictions, restrictions related to the actual construction standards, where the project is located, a number of different things. So it's important to first and foremost to get all of the project requirements from all of the stakeholders. Number 2, identify objectives and goals of the project in a detailed scope statement. So your scope statement should include a few things, such as the project goals and objectives, project requirements, project scope description, project exclusions, project constraints, project assumptions, and project deliverables. Okay. Number 3, create a work breakdown structure, or a WBS, to list the tasks needed to complete the project. So the WBS, or the work breakdown schedule, takes the whole project and breaks it up in phases. So we may have the planning phase, and that may have a few parts to it, right? And then we have the construction phase and the closeout phase and all of the different phases. So the WBS, the work breakdown structure, helps us to break the project down in its component parts so we can further break it down into its individual scopes of work. And so we would think for maybe because we teach this class for individual trades. And so, for a concrete contractor, which I was just teaching today, they would want to break or get the WBS for a concrete project. So, groundbreaking is one task that would be performed. The footings have to be dug. That's another task. The formwork needs to be placed. That's another task. Rebar set. Then we have to inspect it after that's completed. So we're going to be able to take our project and break it down into its component parts. Next, let's get the right mouse. We got 5 monitors and 2 computers working here. Now we need to determine how the work breakdown will be maintained and approved, okay, by determining the milestones. So that's part of the controlling aspect of project management, is that we have to be able to manage it and verify that the work is being completed on time and in the proper manner, and in the results, we're getting the results that we should be getting. Okay, that's 4. 5, let's list all the roles and responsibilities of the project team. Okay, so part of the project team would be our C-level executive, CEO, CFO, COOs, and we have our project executives, our senior project managers, our construction project managers, construction superintendents, assistant project manager, project administrators, general foreman, engineers, clerks, trade foremen, tradesmen and women. And so we have to list the roles and responsibilities of each of those individuals with respect to the project. And again, this is all steps that we need to take to make a scope management plan. So list the roles and the responsibilities of the teams. We have a management team, we have a construction team, we have all of supervisory teams, we have teams of contractors actually doing the work, we have financial teams, right, making sure the money's coming in on time and going out and being paid. So it's a lot of teamwork. 6, establish formal processes for formal acceptance and project deliverables. I'm thinking in terms of, if you want to have a check, right, you got to get everything notarized, right? And that part of a contract we read somewhere. So that's an established process for formal acceptance of the project deliverables. Meaning I accept that you've done the work when you give me the notary information, and because that confirms that you've done a certain thing, so we've put that process in place. Okay, and last but not least, develop how to control documents and control change requests. Okay, that's important. So usually some online system, right, where construction online or some of the online services that you're able to use to upload the plans, upload addendums, verify, upload pictures, input change orders, everything. So you must have a form of document control and change control. Okay, you can't just go out there add new stuff without a formal process, a change order process for approval and review, approval, and to get the work done. So the 7 steps in making a scope management plan. Get the project requirements from stakeholders, identify objectives and goals, create a work breakdown schedule or structure, determine how the work breakdown will be maintained and approved, list the roles and responsibilities of the team, establish processes for formal acceptance of the project deliverables, and develop how to control the documents and change requests. And this is maybe about part 4 of our 6, 8, 12 part project scope management plan. Join us any day of the week. This is Stacey again with SF Johnson Consulting and Construction Services, and I will see you at the next class. And so, what this class is all about, we call it program management for electricians. And basically, what we do is we go over a couple of things. We review the electrical set with you, so you'll have a good idea of when we produce an estimate, what we look at, and we'll go over that very quickly. Now, if you want to have some basic plan reading classes in more detail, just let me know. So we'll go over the electrical set. We'll go over pricing, and then we'll also go over a actual professional estimate, electrical estimate, how it's formatted, and what you should be looking for when you get that estimate from another maybe sub that works for you, or when you present one to a GC. So they are assured that everything on the estimate is based on the scope of work, and it's very clear. And the GCs look at a lot of estimates, as you know, and so you want to make sure yours looks professional. It has everything that they may, if they have any kind of knowledge of electrical, which a lot of them don't, but some do. If they have any knowledge of the electrical scope, they'll know what to look for when they're looking at your estimate. And so that's what this class is all about. First of all, to review a set of plans, and then to review the estimate and go over each part of the estimate, and also to help you understand that there is, when it comes to pricing, there's a standardized way as far as how long something's going to take you to do any scope of work in construction. There's a standardized way based on construction standards. How long it should take you to run a linear foot of conduit. How long it should take you to install a switch. How long it takes for a 42 positional panel to be installed. How long it takes you to install a breaker. All of that stuff is standardized. And if you could make sure when you do your estimate that you base your labor on that standard, then you'll always, at least my clients have always been guaranteed to be like within one or two or three of the winning estimates. And that's really what you want, right? When you spend so much time on an electrical estimate, you want to make sure that it's at least in the running, because it takes you a long time if you do it right. So that's what this class is all about. So we're going to start by looking at the set, and this is just a set of, I'm not even sure what this is. Oh, this is a chase bank. Well, we're going to look at the different sheets and kind of make sure you have, or you're familiar with the different sheets. So tell me, I'm assuming you work for the electrical company, because I saw your email. What exactly do you do? And tell me why you're taking the class and what you hope to get out of it.
Okay. I work at an electric company right now. I am basically the president of project. It was, and he's awesome. He's been in our town since '84, and it's the biggest well-known electrical company here. So he's so knowledgeable and very informative, and so myself just like to ask and fully understand questions, and I just wanted to get a better understanding how I can use different programs, and like as I guess a step by step of what section I should move on from. Like after I'm doing myself, I should know. Okay, then when I should go from.
Mm-hmm.
So that's kind of what I'm hopefully.
Oh, okay. So you do, you help, you assist in the estimates yourself?
Yes, ma'am.
Okay, good.
Right now to do my takeoff and quantity count.
Uh-huh.
That's
So just know you're kind of cutting in and out, so I don't know am I cutting in and out for on your end?
no.
Okay.
Better?
Yeah, well, we'll see. Let me see, because I want to make sure when you get the recording, you hear yourself completely. So I'll let you know if it's cutting in and out. Okay, so you do estimates. Now, do you just do the counts, or do you also help them? You have a linear tool where you do the linear measurements as well?
Yeah, I've got the wheel tool, and also on Procore
Uh-huh.
Kind of different also, but I always double check with the real set of plans and paper.
Okay, okay.
And then I send out quote requests to vendors and put the pricing together on estimate scale.
Okay, good. So this class is perfect for you. Okay, so a couple of things. Yes, a couple of things to save you time. Now, I would recommend if you guys are the biggest, if you've got a lot of resources behind you, I would recommend and write this down that you, and this is what I've used since, and this is my 13th, 14th year now in doing it, and it makes doing the linear measurements a breeze. Okay, so the name of the software is Plan Swift, and that's what you're looking at right now on the screen. It's called Plan Swift Professional, PLANSWIFT, Plan Swift. And I'm not affiliated with him at all, but I know it's made my life so easy because we do all estimates and all trades, but it's just so easy to use. And as far as the counts and forget the wheels and forget ordering the sets of plans until you actually start the work, which you need them, right, when you do the work. But to do the estimate, all you'll need is the PDF like you see here. You upload it. I'll show you by what I'm doing, how I'm teaching you right here. And then, again, you'll have the video to review. But, yeah, you can knock out an estimate in a day. So that means you can knock out 5 in a week if you have. And then, again, if you need assistance in estimating, we teach that as well. And I'll be more than happy to show you. But a lot of the videos now on that study page, it's all about estimating. All 5 of the videos for the electrical is estimating pretty much. What to look for in the lighting plan, what to look for, or how to review the power plan, the single line diagram, how to match them up. So make sure before tomorrow at 5 o'clock that you review that stuff again. And if you find that you want to take an estimating class, just let me know, and then I'll give you a good price on the estimating class. Because, yeah, between using a good software like this and you already having a basic knowledge, you'll be able to make the company a lot of money because you'll be able to knock this stuff out for them, or at least be able to review the ones that you get from other people or whatever. And yeah, so let's get down to it right here. All right. So now what we're looking at, of course, is the cover sheet. And so when you're doing your electrical, it really depends on the architect and the engineers on the symbols. You'll get a symbol in one set that you'll know what it means. Okay, that's a duplex outlet. That's a switch. That's a a single pole switch or whatever. But then you'll get another set of plans, and because of the style of the electrician, the style of the electrical engineer, the style of the architect, it'll be the same symbol, but it'll be something different. Okay, so just make sure you always review all of your symbols ahead of time. When it comes to the lighting plan, you have a lighting schedule, and the lights are all A, B, C, or P1, P2. I mean, that's easy. And when I do the estimates, I pretty much do the electrical set first. The power plan, the power plan first, because that's the most difficult. The lighting plan is easy because all you're doing is naming a light, click, 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 click. But when it comes to the power plan, you gotta you will have to read the keynotes, right, which slows you down. You will have to. There'll be a lot of different special outlets, right? The special receptacles as opposed to just the duplex, as opposed to just the GFCIs. Some may be in the ceiling, some may be in a counter, right? So you want to be able to detail all of that. So that's why you pretty much, I do just to save myself time because you'll be doing a lot of them once you get good. Trust me, they'll have you doing a lot. To do the electrical set, the power plan in the electrical set first because that takes you the most time. And we'll go through all of it. All right, so all of the symbols, so just make sure you always, especially when it comes to the telecommunication devices, right, and the fire devices, they're going to have this T1, T2, T3, what is that? But when it comes to your electrical set, when it comes to the communication devices, right, when it comes to the fire, when it comes to telephone, when it comes to computers, the only thing that the electrician provides is the conduit and the junction box. They don't provide. So we have low voltage electrician and a high voltage electrician. These sets of plans, what we're going through is for the high voltage electrician, which is the electrician that provides the power to the building, power to the lights, power, all of that. Then the low voltage electrician does the power for the HVAC wiring and the telephone and the computers. Okay, so that's the difference where the electrician, high voltage electrician, they'll provide all the conduit and junction boxes those other low voltage electricians need. And so when we do the estimate, we always have to say, yeah, all the J boxes and all the conduit for telephone, for the alarm, if there's speakers, if there's, all of that is low voltage. Speakers, telephone, computer, alarm system, security system, yeah, all of that. Okay, and two, if it's like what have I done? A couple of Chick-fil-A I've done, right? Where they have the loop for now we're talking about site work, right? So the loop, like the loop detectors when they drive through, well, you have to have the conduit. An underground conduit is always PVC, right? So we always say when we see site work, even if it's the lighting site or whatever, it's always PVC or underground. And so again, if it's stuff like that, like drive through all of the wiring for even a gas station, which is a nightmare to do a gas station like a 7-Eleven that has also gas. Well, yeah, you got to do all of the PVC for all of the controls for the pumps, all of the controls for all of that. So when it comes to electrical set, if it's from the ground up, give yourself 2, 3, 4 days because you want to be able to look at it first, go through the hardest parts first, and then be able to put it all together. Okay, so electrical is a different beast because when we talk about the wiring, we have wire assemblies, right? So we have a wire assembly for the feeder. Could be number 300 plus a number 8, all in a 2.5-inch conduit. Well, if you're doing the takeoff for that, you have to do the actual takeoff from the scaled plans. And so it's a lot. But then again, that's why electricians make a lot of money because this is a lot. All right, so let's go to, now this is I think it's also demo, but we're not going to go over the demo part. Yeah, this is a demo. All right, so here is the power plan of this bank. And so you always want to make sure you know what your symbols are looking like. But then I know that, okay, this is regular duplex outlet. So I would just start counting. But when you review it, I always start at one end of the building and just work my way all the way around. So you know you don't miss anything. And so what I always do too is, now you have to do the counts, which are I already know that that's probably a GFCI, right? Because you're always going to have ground fault interrupter circuits, duplex outlets where there's water. So I'm from doing this forever. I know I don't have to look at the symbols list to know that that's a GFCI outlet. That's why they have the G there. Okay, as opposed to not having anything there, like right here. Well, I know that's just a regular duplex outlet. Okay, so the thing about the electrical, right, exactly. So, but then again, the symbol is supposed to tell you. You're supposed to be able to look at this, look at the symbols list, and get an explanation of what it is. And so when I do the takeoffs, I always do the counts first. Okay, so I'm going to go through and do my counts because I have to do the counts, but then I also have to do the wire runs. Okay? And so that's why I start with the electrical set because it is such a more, I'm going to say a pain, but it's more complicated. Okay, so I'm going to quickly go through this because we do only have 2 hours. So the power plan, right, or these outlets are all the power that comes through the building. And so what this is telling the electrician is basically these numbers are telling the electrician what? Do you know?
Isn't that what
Right. That basically it tells you what position on the panel. that these are going to. Right. So when you see that all of these are going to the same position on the panel, 3333, that means they're all daisy chained together. But they're not going to show you the wire, right? Because if they showed you the wire, you wouldn't be able to see anything but the wire on the plan. That's why they don't show you the wire. But they give you the position. Hold on one second. All right. So they give you the position by the outlet, so you know when you have to do the wire runs. Okay, so let me just show you what I mean. First of all, you got to scale it. So we got to find the scale. And it's always somewhere. There we go. So what's that mean? For every 1/4 inch I measure is really 1 foot. And so I tell Plan Swift my scale right here, 1/4 equals 1. And so I agree. So again, I'm going through and I'm doing all the counts. Are they regular duplex outlets? See, now this is telling me what? What's this telling me? PP2, number 10. What's that one telling me?
That is to the panel.
No, go ahead. It's telling you 2 things, actually.
Okay.
One thing is telling you, well, PP2 must be a panel because this is power, so you know it's going to direct you to, right? So that's right. But number 10, it's telling you that's what's that arrow called?
That's the number of runs.
That's a home run. That home run means I'm going to go right from that outlet. What do we do when we hit a home run? We go from that position all the way to wherever it's telling me to go. So what this is telling the electrician is a number 10 wire is going to go to PP2. Now, where in PP2? That's where we might have a mistake, see? And we do sometimes have mistakes. Because this is telling me, now let's look and make sure PP2 is the panel. Hold on, because we're going to go a little farther down and find all the panels. Here are the panels. All right, yep, PP2 is a panel. But see, where that was missing is where on PP2 am I going to run that number 10 wire? So if that is the case, then maybe on the panel it gives me the wire configuration for something, but it doesn't. See, so that would be something I would tell my electrician. It's like, okay, let's go back. That was a good mistake to find early. If I can find where we were over here. Oh, Lord, I don't know where we were. Yeah. So this is the same thing. I don't know if this means PP2, because that can't mean number 1 wire. That can't mean that. That can't mean that. Because you wouldn't run a number 1 wire. That's a feeder wire. Number 1 wire is a feeder wire. You wouldn't run a number 1 from a GFCI outlet. So that's telling me we found a mistake, which is good. This is probably saying, yeah, right, that's saying that position number 1 in PP2 is where this is home run to. Because when you do wire, right, you have to actually do the physical links of this. You have to, and when I say that, now let's go back to, now that I have scale, now we have these notations above the outlet. So if they are all 3s, that means they're all daisy chained together, and I do something like this. I call it power wire. Because usually when it's daisy chained together, the electricians are allowed to use MC cable. So physically, right, they have to physically connect this. So that's telling me that physically all of these number 3 wires are connected. So if I'm doing the power wire, there's 2 different types of power wire you do in the power plant. The MC cable, which you're allowed to use in these situations, but not in the home runs. Home runs are either 9 times out of 10 is a number 12 wire, unless it tells you.
Right, close to.
Yeah, 3. Well, for lighting, it's usually 2 number 12s. But for power, right, it's 3. You have ground, hot, and neutral. Cold, hot, and neutral, right? So you're always, the wire configuration is always going to be 3 wire, unless it tells you otherwise. So when I do the home run, if I know the home run is 100 feet, right? If I know this home run to PP1 is 100 feet, actually it's not because PP1's right here. So whatever that distance is, I know it's, if I know that's 50 feet, then I know I have what? 50 times 3 of number 12 wire. Yep. Because home runs are always 3. Unless it tells you different. Now, when you have mechanical equipment, that's when it's not always a number 12. Okay? It's not always a number 12 when you have big equipment, a mechanical equipment, that, even the panels aren't number 12, right? It's usually just the regular power components where we have a number 12 wire. Okay, so let me stop right there. Because the only thing that we have coming in as far as power into every building, no matter where it is in America, we have 12208 alternating current, right? So we have 12208, that's what we have coming in every home. 12208, 60 hertz, 12208, 12208, that's the alternating current. Well, you can imagine everything will need a different power requirement. Think of it this way. You can't use your phone charger to work your microwave, right? Right, because those charging cords and the microwave cord is the wire configuration that is needed to convert that 12208, 12208 to the requirement to run a microwave, right? That boost it up to run the microwave, or boost it down, right, to power your phone. Imagine if you tried to power your phone with a microwave cable. It would blow it up, right? Because everything that in a building has a different power requirement. And so how we change the amount of power that comes to a piece of equipment is only through that adapter or the cable that we connect to the outlet. Okay? And so sometimes things are hardwired, which means like sometimes like in an apartment complex, they'll hardwire the refrigerator, which means it's not connected to a plug, but it's connected through whatever wire configuration directly to the panel. That's hardwired. Okay? So, when you're doing the takeoff for the power plant, you want to make sure, okay, you're doing all of your things that look alike. So these are all GFCIs. These are regular. That white is data, right, or computer, where telephone, voice would be black. And again, remember, it's not a standard thing. It really depends on the style of, I've had, it really depends. But generally, white means data, black means voice. So this would tell me that this is a communication, maybe a computer outlet. So for the electrician, right, the high voltage electrician, they would provide only what? The junction box and conduit to the ceiling. So when I do this takeoff for any of these, I just say J-box communication or J-box voice or J-box whatever. I know automatically that I have to have either a size, 3/4 inch or an inch conduit. And it's always just to the ceiling, okay? It's never, unless it says run it to the communications room or something. Okay, so as far as the takeoff for that, just know, anytime you see these, you want to look again in the symbols list, because in the symbols list, they may tell you this is a duplex, right, which is 2. So it could be 1 outlet, or it could be 2, it could be 4. Sometimes they'll put a 2, 4, 6 to tell you it's a computer outlet with 2 outlets in it. Okay, so be mindful of that too. And it really just go ahead.
So is it always smart to have a print off list of your symbols?
Oh yeah. Oh, every time. Every time. And what I do, and the good thing about this one is that I can, let's go back to, where is that? The symbols list. See, I can go to the symbols list right here, and then I can tell it to print screen. That way, I don't have to print the whole thing, until you get, or you could just look and see, okay, if I see that G, then it's a GFCI, That's a
And
good
then
thing. Go ahead.
the plan switch, you know how much is that like a one-time purchase you
Yeah,
have to pay, or
right.
is that
It's a one-time purchase. Now, look, the funny part, they know how good it is. When I bought it 12 years ago, 13 years ago, it was $800. Now it's about it's double that. It's 16. But you know what? You make that back in one project, right? I mean,
yeah,
really. If an electrician, you make that back one, two projects, and you'll have it for life. I still have the same one that I bought originally. The one we're watching is like I have like Plan Swift 9 point whatever. Now they have Plan Swift 10.15. Okay, and you know the revisions are like point 1.1, right? So they've had a lot of revisions, and I still have my original that I paid $800
it
for,
works. It still works
and it
good.
still
That's
works.
awesome.
It still works. And the thing about it, like I tell everybody, it's a ruler, right? It's a ruler. I mean,
It's a truth. Let's do
right?
it all for you.
It's like a hammer. How many times you got to replace a hammer? Never, if you treat it right, right? And two, if you lose it in your computer, like your computer dies, gets a virus, there's somewhere for you to go and download another. You know, in depth, you can download it forever. You know what I mean? Because how many computers I've lost over 12 years? I just go back and download another set. You know, the original, you can download it again, so you'll never lose it. You know, and
Okay, that'll make
yeah, and two, if you use it at work, you it's a license that you can only use on one computer at a time. But you can download it off your computer, and then like once you go home or the next employee working graveyard or whatever, they can use it too. So two people cannot use it at the same time, but you can download it off a computer and upload it to another one in a different location.
right. Alternate times. Okay.
Yep, yep. So you know, but yeah, I mean, it's worth its weight in gold for sure. Okay, so let's go back to. Okay, that's a demo. Okay, so we just want to make sure we know that that is underground conduit, and so we know that that's going to be PVC, right? And we're always going to look at the keynotes. And one thing is that I kind of look over before you get a set of construction documents, and you know you're going to bid on the set. Make sure you always review the specifications because
Right.
the specifications are the written words that go with this project that tell you the type of material, how they want you to install stuff, if they want submittals or whatever. But two, if there's things like temporary lighting that's required or things like that that aren't necessarily shown on a set of construction documents, it'll definitely be mentioned in the specifications, right? Or if you need a generator or something and you happen to miss it, in the
Right.
documents, it'll definitely be in
So,
the specs. And then that way you won't miss it. So I always recommend review the specifications in detail, take notes, then review the construction documents, take all of your counts, take your measurements, and you'll be ready to roll. So when I do a set, I do the power plan first, review all of the keynotes, make sure I understand what they're telling me is it's above county. 9 means something, so we look at 9 and recommended location. Are these the keynotes? Yeah. Recommended location of cellular antenna, roof penetration. So that's those kind of things that as an actual electrician, okay, you want to account for the roof penetration by how many of them do you have? Because I know, and I'm not an electrician, there's a special kind of connector to go through, to go through the roof. So you need something special for
yeah.
that. So you want to make sure that things like that you even account for, even though there's not something actually there to
Right.
1, 2, 3. In the process of doing what you have to do that there is a special connection, through wall connection.
Right.
You
So
know,
that will be $600 instead of $40.
right?
Which
Exactly. So that's why you want to make sure, especially on the electrical set, you review
yeah.
all of the keynotes. So two keynote number one is two number one conduits running slab, two floor box for power data, and then you got to run it up too. Now when I do my runs, I just do horizontal runs. I'll just run it here. But then when I finish, I'll add 10% because
Okay, 10% away.
of what I.
That's my thing, right? About when I do a measurement, I'm so nervous on like what way to run it. You know,
Right.
I'm like, okay, I clearly can go from, but I clearly can go from 830
Right.
over to number 33. I have to go up and around and
Right. Okay.
way,
So
way up.
yes. Now look, that'll drive you crazy. Okay.
Right.
So the one thing I do when I do the wire runs, I just do it in the most neatest way possible. Because you're not
Right.
trying to be exact, right? You're trying to give it an amount that is comparable to what would be there. You know what I mean? So when I do the wire run, so like this one I did, right? I'm gonna do it in the neatest way possible because I know you
Yeah.
as the electrician,
It is.
you're not gonna run it all crazy, right? You're gonna go from point to point, just like if you all of these are 35s, right? So you're gonna run the wire. Now, are you gonna run it like this as an electrician? I don't know. You might, but I do it as neat as possible, and it's so funny because my son now he's an electrician, and I taught him how to do.
Yeah.
I taught him how to do estimates for me like years, and I see his work now, and it's like immaculate. It's neat. It's like from point to point. Okay, so
Yeah.
if I'm gonna do, so you don't have to worry about, oh, should I go from here to there? Because what you want to do is just remember all these are 35, so I know I can use MC cable,
Yep.
and so I'm just gonna do that because even if my electrician is sloppy, well, I've covered all of that. And I mean, I'm going to do it in the neatest way possible. That way I'm not going to be short. See, and again, you're not on the wire and conduit runs, you're not trying to be exact. You're trying to get an amount that's comparable that will cover the job. And if you go from point to point, add 10%, okay, we know these are all sevens. And so all of that, and now I'm better reading, and I'm even going to go through the door, right, to connect to seven or wherever the next seven is. And so I know that all of these are sevens because now I know, now that I'm better at reading the set of plans, I know that this is telling me the home run to position number seven. Well, if that's seven, that's seven. Yeah, position number seven on the panel. So I know all of these with the seven, I can daisy chain together. But you see, this says
And then
number nine.
you said here, I have a question.
Uh huh.
With at home run, the little number over the symbol is the slot section, right, for the panel. But
Yeah.
then the arrow over the line, the amount of home runs. And you said you times that.
Okay, so once I do all of these, right, that I know are daisy chained together, I'm not finished. But assuming we're finished, right, this number seven needs to come down too. Just keep that in mind. So assuming that I'm finished, okay, so now I'm naming something home runs. And then I'll name them power home runs because I separated for the lighting home runs too when I do the lighting plan. So just so the electrician knows, because they don't know what I'm doing, right? And so I send them a copy of the takeoff recorded, right? I also give them, and you'll see when we go over the estimate, all the relevant measurements. So I say, yeah, this is a home run for panel PP2. Here's the total home run for panel whatever. Here's the lighting home run. So they can, because they do it for a living, right? They can visualize that and see if that makes sense based on the plans, right? Because they've done it a lot. They just need somebody that's going to accurately do their best to measure it as accurate as possible. Okay, so imagine I did all. Say it again.
They need us to do it. They aren't patient enough.
Right, and two, I'm really. I mean, seriously, they're really not. Considering they got to go do it too, it's like that's why I loved specializing in electrical because I know I can be very detailed and save them a lot of time, and to help win. I have a really good track record with my electricians. They get up there really close and they win. So it's like, yeah, this is how we get very detailed when it comes to the takeoff. We use good software. Then when it comes to the pricing, and that's what we'll go over after. So let me go back to assume I did all of the wire runs that we could daisy chain. Everything that's got the same position, we know we can daisy chain. Now, once it comes time to the home runs, I just go to all of where I know there's a home run, and I just go from that position to, now this is PP2, and right here. This one's PP2. I go from that position to PP2, same position. This one, this is going to, now this is a junction box for the power alarm. So I'm going to say, I've already counted that. J box fire. So I'll know it's a junction box for the fire alarm, but I'm still going to, because it's still a home run to PP2. Okay, so you do that all the way through. Everything's a home run to PP2 wherever you see it. And so by the time you finish, right, you'll have a total. Right, so right, because that, right, right, because that's the whole purpose of a home run, as opposed to nothing on it, right?
Everything else is connecting to that in the data chain.
Right, exactly. So it's telling the electrician this GFCI is connected to this one. But you see, okay, let me show you the difference between, you see this has a 7 GFCI and this doesn't, but it has a home run. So what this is telling me, this one outlet in itself is a direct home run to the outlet. Because I'm sorry, to the panel, from the outlet to the panel, because some equipment has to go directly to the panel for power. So some are daisy chained together, just like all of these, right? All of these, 17, 15, 37, 8, all of these are direct home runs to PP2 position 17, PP2 position 15, PP2 position 37, position 8.
And would that be different from labeling it quote hardwired, or is that fixing wired?
That's basically that's hardwired. Well, no. It would be hardwired if we would have something like the box, the junction box, like this one. That's a junction box for something.
Right.
And then it's directly, yeah, very good. That's a good question, because the outlet lets you know that it's plugged into something, right? Because that's a duplex outlet. That's a good question. All right, so know that the symbols, right? This connected to a wall, so I know that's a junction box connected to a wall. But this one, right? If it's in the middle of the room, right? We know that that is a junction box for a camera, CAM, or the power for the camera. I got to look at the symbols, right? But I'm assuming that's a camera. I'm assuming a lot because I've done a zillion of them, so I'm assuming that's a camera. But yes, but you know, when you assume, you know what happens sometimes. So, but yeah, in the final analysis, yeah, I'm gonna go through, because I'll say ceiling, J box, CAM. So when I go through it and I'm finished with my takeoff completely, I'll print it, and then I go through each step and fill in the estimate, like I'm going to show you shortly. All right, so the power plan, that's why we're spending so much time on it, because it's so much little stuff. If you see a symbol in the center of the room, right, you know it's in the ceiling. And so a junction box for the labor, right, is going to be more to put it in the ceiling than it would be to have it on the wall. So just be mindful of things that are in the ceiling, like that one, and like this, right? Right. Well, you know what? That's a good thing too. You said that, because all of my estimates have a standard place for lift, because they gotta have a lift. You know, I mean, they're gonna go higher than 6 feet anyway, right? So if they go higher than 6 feet, they gotta have some way to get up there. So that's kind of like a standard item on our estimates that you'll see. The lift is standard. Overhead profit is standard. We have a spot for the switch gear separate from the lighting package. Okay, and that's another thing that when you do the estimate, right, the first thing you need to do before you even try to put it all together is do all the counts for the lighting, and then you send that to your supplier, right, to your multiple suppliers, because it's going to take them a while to get back with you with the number. Because I've helped an electrician, and it's like we send it to 4 people, and it's like we never get them back on time, and we'll get one here or one there. So the first step in making sure you have everything you need is to get these counts done for the lighting, especially all the lighting and the lighting controls, and then send them the e-plans. Right. You don't have to send them for the outlets and stuff like that, because they'll give you a package for the switch gear and the breakers and the disconnect switch. That'll be one thing. And then you'll get one other price just for the lighting and the controls. Okay, so we need to get out of the power plant. But do you have any questions about the power plant?
The only other part that I noticed that I struggle with is after I get my counts and everything, and like for say the power plant, it's going through, and what I've done is I use the panel schedules to see what type of wires
Exactly.
that my little symbols need.
Yeah.
Is that correct to do that?
See,
Is that what you would use this power plant to do, or
there's multiple ways. So you know that, or just know that the regular outlets are all number 12s. Okay, and the daisy chain, and you have to ask in your state. All these daisy chains. It's usually MC cable, and it could be MC cable with 3 wires, 2 wires, 4 wires. It really depends on. And we usually just use 3-wire MC cable with 3 wires. The same as the home. Remember, everything is 3 wires because we have a hot, a cold, and a ground, and a neutral. Okay, so each of the components have to be connected to each of those 3, and then some components have to be connected to more than that. Okay, so just know that everything's going to be that 3-wire. Now, as far as and again, everything's going to be number 12. Now, some plans, if it's not number 12, say for instance your mechanical equipment, if it's not number 12, it may say in a couple of places. It may say on the keynotes, right? It may say directly in like I thought that one was a number 10 wire, right? When it was just telling me the panel. It may tell you at the home run. But yes, you're absolutely right. Now, it may also tell you, and it should tell you and it may not all the time, but it should tell you in the panel schedule. Okay, but sometimes it doesn't, because this is a lot of mechanical equipment. Another key to where the wire may or may not be number 12 is that if you have if it's more than 21, right? 20 amps, 1 pole, that's usually number 12 wire. If you have anything more than 2 poles, 3 poles, it's probably a number 10 wire, 2 number 10s, 1 number 8, and see, this set is sucky because it doesn't tell you. Okay, it does not tell you, and so what we'd have to do is give an allowance, okay, because all of these panels, now, again, anywhere you see 21, it's probably guaranteed that it's a number 12 wire. Okay, so like everything connected to PP2 is probably number 12 wire. Even the exhaust fans. Because again, if you see 20 amp, 1 pole, that's usually telling me the wire connected to all of the branch circuits and all of the home runs are number 12. The only thing to question is when you see 2 pole, 3 pole. And then sometimes it doesn't mean that it's not a number 12. But if it doesn't tell you, you just need to make it known that it doesn't tell you. And then, a lot of times your electrician actually does the work. Will know, okay, make that, 2 number 10s and 1 number 8. Or the other way around, 2 number 8s and 1 number 10. But the key to it, yes, The key to it is, yeah, you look on the panel schedule, and most will give it to you. If it doesn't, uh, you know, you have to ask.
Right.
Because it really should. Now, there'd be no reason why they didn't give it to us here. And again, just keep in mind, anytime you have more than one pole, it's probably a different wire configuration. And your electrician can probably figure out what it should be by these numbers because that's what they do for a living. You know what I mean? But for a estimator, yeah, it's supposed to be there. You're supposed to tell me. And in this case, I would tell my electrician, hey, I don't know the configuration for the mechanical equipment. It's not telling me, so I'm going to use this or this because I've done a million of them. You know what I mean? And don't.
Yeah,
Mm-hmm.
that's my hardest part too is with my boss, I guess, is wanting me to stay on that person and figure this out. I've been coordinating with the coach that we have.
Uh-huh.
It's been a little easier.
Yeah.
But
Well, yeah, that's another thing. If they're going to teach you how to do it, that's great. Yeah.
yeah, and it's use the panel schedule to figure out all the wires and stuff.
Yeah.
Do you think that's
Oh, yeah. Definitely. And again, if it's not stated, and I would look at the electrical keynotes very carefully and the keynotes for the rooftop equipment because it may tell you somewhere in there. It may or may not. You never know. But if it does, I would look very in detail for that. But existing, yeah. Extend. You cutting out again. You cut out.
Oh, sorry. Question on when you're doing the plan takeoff, right?
Uh-huh.
The different, I was told that I've read up on that you should, do your fixtures, lighting, and clean, and your wires change, and your this and that.
Oh.
Do you really have to have a symbol or
You know, my the Plan Swift, let me show you. Right? Because Plan Swift gave it a color. It just gives it a color. So you can give it a color. You don't have to. Our thing is, estimators, we just need to do the measurements. We don't care what the color is. You know what I mean? So, yeah.
Okay, I found my note. I read from a note that it said, create a color scheme for system, or scheme for lighting, pictures for flip.
Oh.
That's what I thought was ridiculous too, because I'm no.
Yeah, no.
But the one that I use, it doesn't automatically give a color. It's like you pick it.
Oh, well, yeah. I mean, but really, color to me is like if you name stuff, like if you have to name it what it needs to be named, and then go on.
Doodles, don't go by the color.
Yeah. Go by the name because we're naming stuff for a reason, so we can go through it once we're finished. Okay. So, any more questions on the electrical set?
No minute.
All right, and this part sucks. You see this cutout? Call out, basically, electrical call out. Okay, so it's called out. So we go to image number 2 on E 2.1, which is on the same page, which is right here. So, but keep in mind, you still have to do the home runs, right? But they've taken it out of the position where you could easily do the home runs. You see?
Yeah. And they changed the measurement.
And the scale is different. And so for something like this, actually, for something like this, is it 29? So you'd have to change your scale real quick because this one's 29 and this one looks like, now let's see what number 2 is. Keynote number 2. Outlet for building automated system and coordinate. Okay. Because it looks like it's in the ceiling. This one. And so 27, 29. So yeah, you would have to, because these 29s are daisy chain. And then home run. Okay. And then, but it looks like everything else is a home run. And so what you could do is guesstimate, right? So you go back here. You go back here and just run the home runs. You know, go back to the regular scale, the scale of this, and just run the home runs. You know, you're not going to be, and again, when you add your 10%, you're going to be good. And keep in mind, when it comes to the wire and the conduit, you're not trying to get it exact. You're trying to get enough, get your measurements in there enough to where it's comparable. Add 10%, and you'll, trust me, you'll be right on the mark. And don't forget to multiply by 3, right? The conduit is 1, so if I've got 1,000 feet, I've got 1,000 feet of 3/4 inch conduit. But what? I've got 3,000 feet of number 12. Okay, so now let's go to the lighting plan. All right, so that's the roof plan. So when we do the roof plan, what I do too, if I have to run the wire, see, we got a new outlet here. So, and it's waterproof. So you got to kind of guesstimate where the panels are, right? Because I think these are probably going together. Let's see, position 41. Yep. So what we got, all of these are going together. So when it comes to rooftop unit, what conduit are you going to use? Rigid steel? Is it going to be PVC? I don't know. We just want to get a good measurement, and your electrician can tell you the type of conduit we're going to use, but it's still going to be number 12 wires unless it says something different. And then we've got to get these all together, and then, we're going to assume, where was that panel? Somewhere at the end of the building over here. So we've got to just run it. And then when it's on the roof, I add 10 feet, right? Because we got to go down. So I automatically add 10 feet on anything that's on the roof. So if I had to connect all of these, I do the same thing. But I think these are already existing, or else they would tell us something. We had to do something with them, right? If they're already existing, then it's not telling us to do nothing. Or, we got to read the keynotes. It may tell us. But then the same thing here. If I have to run power, I'll just do it from right here to where I think the panel is and add 10 feet. Because again, you're not trying to be exact, right? You're trying to get something that's an allowance, that's comparable to where you're not under. Okay? Okay, so that's the roof plan. Yes.
What you said conduit by 3. So,
right.
You have 1,000 feet of conduit. You have 3,000 feet of wire.
Right. So, for instance, if let's just say it's the home runs, right? If you measure like we did, 1,000 feet of home run, which means, right, you've got 1,000 feet of home run, but you've got really 3,000 feet of number 12 inside that 1,000 feet of conduit, right? Because it's multiplied by 3. So you want to separate the conduit run from the wire run, right? Right, because the wire goes inside the conduit. Right? So the conduit is holding 3 number 12s.
Right. 3 of 2 different wires. 3 of the same wire connected to 1 and 1 thing.
Right, because remember when we do our home run, it's remember we got hot, cold, and neutral. Each one of those gets a wire connected to it. So we have 3 number 12 wires running through that one piece of conduit. Right, exactly. You see, visualize that, because that's really what it is. It's 3 wires that's running in that piece of conduit. So when we measured the home run as a entity, right, what we really meant is if it's 100 feet, even 1,000 feet, whatever. As an entity, what we really meant was 100 feet of the conduit, but inside that conduit, right, is 3 times that 100 feet, because that's how we run home runs. It's 3 of them, or 4 of them, or whatever it tells us.
However many triangles are on there.
Right. Well, exactly. Yes. Okay. So now we're to the lighting plan, which I always do last because really all we're doing is counting. We're looking at the lighting symbol. So make sure you are differentiating between what they call the light and this thing, right? That is just the zone, right? Because the lighting plan shows us all the lights and how they're controlled. So they're showing the electrician that certain lights are in zone 1, certain lights are in zone 2, you see? So when we want to cut on certain lights in the building, we can cut these on, those off. And so that's what all these symbols on the lighting plan telling the electrician. One thing is identifying. Right. Right. So it's telling the electrician two things. Well, really, it's telling them three things in this one little section. It's telling them the name of the light, L500. We know it's an emergency light because it's got that little black dot. That's how they differentiate between the regular lights and the emergency lights. Emergency lights are the ones that stay on at night, or in the event of something, they come on. So that's how they tell the electrician the difference between, because they have different lighting configuration, the batteries, something about the emergency lights are different. So they have to know that the difference between the emergency lights and the regular ones. So this is telling the type of light, and this is L500 EM. This is just L500. We've got all different ones. This is, I don't think that's a light. That's some kind of sensor. So yeah, we're going to look at the symbols list in our lighting plan to tell us what that is. Okay, that's some kind of directional sensor. But then again, it's all connected to zone 1. So this tell the electrician, all of these lights, it looks like, in this little area are zone 1 lights connected to, that 9 is actually a position probably in the lighting control panel. So just like the outlets, right? They all have the same number. Well, that's telling the electrician that these are all connected to the same lighting control. And we're going to call it number 9. Okay? Right now. Right. And see, now we have to do the wire runs for lighting. This is where it gets tricky, right? It's like, okay, how do I do that? So it's just like shotgun. So I would do like, I would, because they're all 9s, right? I would all connect, because they're all connected together. And I would go down here, and they're all connected together. And then I go over here, and then they're all connected. Okay? And at some point, they'll be connected to, this is where it takes your imagination on your wire runs, okay? And again, you're not trying to be exact. You're just trying to account for the lighting. You're trying to account for any wire that needs to be connected to these lights. These are all 13s, so these are all going to be connected together. Okay, all the 13s. And then look, the switch. Go ahead.
At this point, too, when you're doing those counts, one of them in the row or the Stacey chain has to go back to the main.
Right, yeah, right, exactly. It's got to go to wherever. And see, we haven't reviewed this in detail. Like, what is number 9? Well, it's probably one of the panels is probably a lighting control panel. You know, so just think everything is connected to power. It's just like, what is this telling the electrician? This little room right here is telling us a lot. These lights are called L8S, and this is an emergency light. They're connected to, their zone is Z20B. So what that Z20B is probably a position on a lighting control panel where they're all connected together. Right? At position 15. So all the 15s are connected together. And this is zone, you know, we got to read what all of this is. Okay, what Z20B, it's all in the schedule explaining everything that it is. So what is this? This is telling us what? These are the switches for this room. But, okay, as far as the conduit run, I mean, how do we do it? Well, probably like this and then that, okay? You see? I mean, how complicated could that be? From the switch to the light to the other light. And then, you know, my thing is, we got to know what all of these are. Probably some kind of, occupancy sensors kind of stuff. Or this is actually a light, Z17. Probably like a pendant light in between these two bar lights. Who knows? But that's the whole point.
So, and then it's the wire that has to, obviously, one of them that connects to the daisy chain, the conduit too,
Right. So look right here, right? So here we are right here. So switch Z1, switch Z10, switch da da da. All this is the whatever 3 is. This is the switch bank they're showing us right here. So yeah, all of these are going to be daisy chained together, and at some point they're all going to be connected to Z1, Z17. We probably got more than one switch bank. But yeah, I mean, this is where the imagination sets in because
Right.
it's like, okay, first thing you're going to do really, just count all the different lights. That's the first thing. Count all the occupancy sensors. Figure out what this is. This is some kind of occupancy sensor. Okay, so count all that stuff. And then, yeah, use your imagination because you know that, again, it's telling the electrician all of these are connected together. And then I'm going to go to the panel because one of these is the lighting control panel. So that's power.
And
That's power.
does this set plan also, does this set a transformer in that?
Here we go.
Integrate?
So this is existing. This is existing building, right? We did some demo. They got rid of those. So as far as your power, your single line diagram, the transformer, all of that is already existing. Existing, da 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 da, meter service. So what we need, go ahead.
Run the building, right?
No, because this is the extent of your single line diagram, right? Yep. This symbol right there, that means that there is more that we don't see. That little S that says, well, all you need to look at is what I'm showing you here. Because this is, and that's telling us, oh, it's already existing from the landlord. What we're doing when we moved in, we demoed the existing panels that were there. And then we broke into, because this is the existing service coming in, we just disconnected here and reconnected ours to the meter, our PP1, and then our PP2 and PP3. Now, here's the tricky part, right? To go from how many linear feet of this do I need? Right? How many linear feet of this do I need? How many linear feet of this kind? Well, then you have to go physically to the the power plant, and do the physical measurements, which when we saw the power plant, they're not, they're right there, right? The distance from, let me do a dimension tool. So remember, you're going to go across and down. So this is because the distance is so short, right? 5 feet between the panels in reality. So I would give it like, I would give it like 15 or, something good. Just so I'm padded on my estimate. Because you got to go up, across, and down, right? I'm just going across. So the full length from one panel to the other is less than 10 feet. In reality, right? Because this is supposed to be reality. That's why we scale. See, and then I would add like 6 feet for each time we got to go down or whatever. But, when it comes to those power feeders, we're talking what? Maybe 15 feet each, 20. Even very generously, I give him 20 feet. Yeah, right? Yeah, right. Right, exactly. So, that's not difficult at all. All right, so.
I just know on the plans that I've been seeing on my end, I have a lot of transformers, and it's really hard for me to understand how to get that perfect to connect to the building.
Okay, so let me see if let me
But you have this other side.
yeah, I do. I want to see if maybe this Dutch Brothers was from the ground up.
My favorite.
Oh, it was. Okay. Yeah, it was from the ground up. So let's see. He said your favorite. Where is mine? Was this from the? It is from the ground up. Okay, let's see. Oh, that's right. I did the final cleaning estimate. I didn't do the electrical. So hold on. That's right. This is from the ground up. So let's go back. Come on. All right, here we go. Here we go. Perfect. All right, so here's the building, right? There's the building. And then look, here's lighting because they got the big drive-through and everything, right? So let's see. Let's look at the schedule to see where the transformer is. Let's see. For utility transformer, location of utility, meter disconnect, let's see. Let's see, where does it say? Conduit, where do I see? Menu board. Okay, we'll find it. All right, so you say, well, let's just pretend let's probably, where is it? My goodness. Well, let's assume.
And you check that line right and the power plant?
No, I mean the utility transformer would be outside, right? Utility transformer is the one that comes from the utility company. That's out, usually like the green thing that's outside apartments or whatever. That green box. Okay, we're just gonna assume it's right here, because we don't care where it is, because we know that right here is the disconnect switch for the building. Okay, and this is the building itself. So if this is the transformer, you know that all of the power feeders are underground. So we would just do a measurement, scale this set, scale the site set, which is 1/32. So let's do that. 1/32 equals 1. We agree. So, again, remember, you're not trying to get exact. You're trying to give the electrician a good enough number to give a good allowance as to how much to charge. And we're always going to add more. So even if this is the transformer and we know that that's the disconnect, well, we're going to say feeder. And we know it's PVC. So if this is the transformer, as you know, it's all going to be underground until it gets to the building disconnect. Now, that's all underground. But then what you're going to do, so from the transformer, right, it goes underground for sure. It's not going to pop up. And then, so from the transformer, it goes down. It's all underground. Then when it comes to the building disconnect, it comes up, right? And so what you can do is all of this is PVC, and then you can allow another 10, 15 feet for EMT or rigid steel because you know it's going to come up. Right? And so when it comes up to the feeder, let's try to find the single line diagram now.
And then it should tell you in the signal or the what type of conduit.
Oh, yeah, definitely. Hold on. It's going to tell us right here. Let's see. That's the lighting control. See, it's a little building, but see, and that's all the little kitchen equipment. And here we go. Okay, so switchboard. Look, so here we go. That right there. Right, so that measurement we made would be 2 sets of 4 350 and a 3-inch conduit. Okay?
And it would be steel.
Oh, yeah. I mean, we already did it, right? We did it here. We already scaled it, right? When we did it here, We scaled it. So that's what. Oh, I didn't mark that sheet. Oh, Stacey. That's this. We already did that because it's coming to the disconnect switch, right? This is the disconnect switch.
Yeah.
And so now we need
But
to
you're
do it.
saying
Go ahead.
sometimes I'm gonna miss stuff on other pages, like
Yeah. Well, see now, if it's from the ground up, then yeah, you got to find the site plan because the site plan is going to show you. And don't use the civil set, right? The civil set has nothing to do, even though there's the electrical is shown on the civil set. The civil set has nothing to do with the specifics of electrical. So you're always going to look at the E plans. If it's from the ground up, just like this one, the Little Bitty Dutch Brothers, right? It's going to have a site plan. Now, because it's going to show us where the utility transformer is. We just don't have the time to go through it on this one. But I said, imagine it's right there. Well, if it is right there, we've already done the measurement, which accounts for this right here. So that's 132 feet to the disconnect switch. Okay? And then you say what? So 132 feet times 4. Oh, times 8. 8, right? Because you have 2 sets. So don't forget that because you have 2 sets, meaning it was 132 feet. It's really 260 feet, right? Because you have 2 sets. Okay? So if I have 2 sets, that means I have times 8 instead of times 4. And remember, if it's underground, it's going to be PVC. So it's 3-inch PVC. And then it looks like it's still underground until it gets into the disconnect. I don't know. That may be just for a picture, because if this is underground, well, this is showing it's still going underground up into the disconnect from underground. I don't know. That may be right. That may not be right. Okay. So as far as additional conduit beyond PVC for this run is what I mean. And then this run, of course, is showing. Go ahead. Yeah, right. This is PVC. All underground is PVC. All the way to the whatever bus duct or whatever they're going to use to connect that to this. And then here is telling you what it is. So now, yeah, you're going to go back to our power plan. And I think we did that distance, right? Oh, no, that's a different plan. So we go back to the power plan to measure that physical distance. And then 2 sets of whatever this tells us. And then, the power plan for all of these distances. Okay, so the purpose of the single line is just to show you how the power comes into the building and how it is broken between the main distribution panel and all of the service panels, pretty much. All of the panels that connect everything in the building that needs power. So yeah, this is just for an overview, but yeah, you got to go back to the power plan itself. Got to go back to the power plan itself to find out where the panels are. This is not a nice plan. Where are they? Yeah, it's not. And here's all the rooftop. Where are the panels at? Oh my God, Dutch Brothers, you make good coffee, but not good plans. You would think there must be another sheet with it on it. Okay, yeah, there we go. See, they give you another sheet because they want to. Oh, that's good. They're going to show you how to run the network because this is all conduit for us, right? Camera, right? All of that. So it's kind of good. It's nice. Network cabinet, mud rings, low voltage. Yeah.
Measurements, right? And you're putting them on something. And I've been told both ways, like people.
Uh-huh.
I had everything together. Like if you're doing it pricing it that way, like for pricing, I'll put them together the same out that way. But then other people say, don't do it time schedule or
Huh.
plan or
Well,
sliding schedule.
yeah. Well, you know what? It really depends. And let's go to the next part. Now that let's go to the estimate because this has been a winning combination for me and for my clients like forever. And so the way that we separate everything, once we've done all the measurements, right? So we know like that power, the MC cable, when we made all those measurements are the ones that are daisy chained. So we know how many linear feet of that for the lighting and for all of the signage and for the power. And this is for a city brew, uh, like a little Starbucksy kind of place. But this is what we do. So for number 10 wire, we give it all separate. So all the wire is separate. Number 8, number 10, based on all of the wire runs. And you see number 12, right? You see number 12 is 5,130. Well, why? Right? Because everything is pretty much always number 12, and you multiply by 3. So that's why number 12s are always more. You have a number 12. So this is basically how we do it. The wire, we break it down based on the takeoff, right? Actual measurements. Conduit, based on the takeoff, the actual measurements. And we try to break it down for, the data, phone, speaker, from the power, from the different sizes, da-da-da. And again, these are our home runs, 3/4 inch. And then all of the wiring devices.
Is that what with full string means? Does that mean your home run?
Now, when it comes to with pull string, the only thing that we do, and you see the cost, is that we revise from day one as estimators that to incorporate the cost of the pull string, you double the cost of the conduit. So in this case, the conduit would be half of these prices, but because we do incorporate the cost of the pull string, we double the price of the conduit. Okay? So yes, that is conduit and pull string. So how we read this, and let's go over that quickly. So this is our Excel spreadsheet for the electrician. The quantity, right? How much we measured. And then the cost based on our, supplier. And then this gives us the total material cost. Now here's our labor base rate, standard base rate for an electrician. And then this is the man-hour unit. Okay, now this is the number that I say based on industry standard, blah, 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 blah. Well, the man-hour unit is the amount of time that the construction industry says it takes for you to do anything in construction. And so to install one, because it's per unit, and a unit in this case is 1 linear foot, construction industry says it takes 0.011 of a man-hour to install 1 linear foot of this type of NC cable. And so we know how many man-hours to do the whole job. Okay, so that to me is the key of having a very tight estimate, a very competitive estimate, because a lot of people what do you base your time on? Experience? No. We recommend that you base it on industry standard. That way you're very competitive, right? And that's what you want to be.
Does your program provide us information of the industry standards, or does that come with?
No, that comes with. Hold on one second. So we do things in a 3-step process. First step is the takeoff. The second step is getting and let me put this on the screen. This is what we use for our the industry standard stuff. So let me just put in switch. Okay, switches. Let's do electrical switch. Okay.
That's not price. It's just that. Oh, it does.
Yeah. Okay. So this is Craftsman Cost Book, which gives you we put in a zip code, and here it has a Sacramento zip code. So this is basically telling us what the basic bare bones cost for each of these items is. But most importantly, what we use it for is for the man hour totals. The number after the @ sign, that is the industry standard, and Craftsman Costco's been around forever. And so they give you the industry standard on everything in construction, whether it's a switch, whether it's the conduit, whether it's a wire, and that's the number that we use in the Excel spreadsheet. The number here after the @ sign basically says what portion of a man hour does it take to install one. So the unit is each. So for each switch, so it's saying here now, we're not talking about it says labor includes connecting wire to a switch and securing the switch in the box. Add the cost of the box and the cover plate. Okay, so this is just the switch itself and the time it takes to do just what that said. Okay, so if you're doing an actual switch, you're going to add this, you're going to add the box, and you're going to add the cover plate. In that case, it will give you all three. It'll give you the cost, it'll give you how long it takes. So those three things added up is what we call the assembly price for that switch. The assembly is all those three things added together. Okay, so that's where we get that number from on the Excel spreadsheet. Okay, let's go back to the Excel spreadsheet. So that's where we get this number from. And then if you know how many, right, you're doing, and you know how long it takes to do one, then it's going to tell you how long it takes to do all of them. And so eventually you'll know how long it takes to do your entire job, because we do the same thing for all of the outlets, okay, all the wiring devices, whether it's J boxes, duplex outlets, and see how we broke it down. Some in this project it had 20 amp duplex outlets, it had 30. They had some above the counter. They had 40, 50. They had a duplex outlet in the show window. Duplex outlet connect only, right? Because the ones in the rooftop units are already provided. So the electrician usually just has to connect those. Okay, so
Did you go back up to the full string? Sorry, so I'm trying to figure out, so data and speed. But then down on the you also have some that are labeled the wire speaker.
So
what is
which this is okay, no. As far as the conduit with pull string, that what that means is that's the cost. We include the cost of the conduit and the pull string. This is the time it takes to install the conduit only. Okay, so this is the cost of the conduit and the pull string. This labor is the cost to install conduit only. So by the time you add the cost to install the conduit and then the wire, then you've incorporated the cost of running the power wire. You see? And then two, these are the costs to, just like we read before, to install the duplex outlet. So now you've installed the outlet, connected it to the wire that you've already installed. You see, and we work our way down. All of the wiring devices that we've added for everything. And then now we've got to the switch gear. Okay, so also, depending on the type of panel, right, it's going to take you a different amount of time. And really, the more positions on the panel, the longer it takes to install that panel. So we have the cost and the time it takes for the panel only. And see, we have zeros here for the panels and for the lighting, because we have a lump sum at the bottom to lump sum all the switch gear and the breakers, and then a lump sum for all the lighting and the lighting controls. But here we incorporate the labor only. You see how that's different? So these numbers, right, where we get these numbers by counting from the panel schedule, right? We just went to the panel schedule and counted. And I thought that once I sent the panels to the supplier, right? That they would do all the counting, but my electricians say no, count it separately. They count it too because sometimes they're wrong. So I'm like, oh, okay. So you know, yeah. So we count that because yeah, for each of the breakers, there's an amount of time it takes to install each one into the panel. Okay, and then same thing with the lights, all the lighting, install only, right? And the site lights, you can see those are different. Give them 2.5 hours per light for the site lighting, and then just an hour. And then if it's track lighting, because it's measured by the linear foot, we price it by the linear foot as far as install. It's a different cost. And then all of the lighting controls, ceiling occupancy, wall occupancy switches. Give a generous amount of labor for that. It's probably more than is needed. And then last but not least, right? All of, like you said, the lift. And we just give them a general amount. If they need more than that, they'll adjust it, right? And then this had a drive-through, so the loop, directional signage, menu board, speaker post, all of that is time it takes to install or to connect the power to. Because we already ran the wire, right? We already ran the conduit, so we give them an additional time to actually install it, make sure it works, check it. That's what this stuff is. And then there was a walk-in, like the walk-in freezers or whatever. There's always additional, like, what is that, heat tape and all kind of crazy stuff they have to do when they install coolers and freezers and stuff. So I just gave them, and it's called an allowance. I'll give them allowance because I know they have to spend something on it, but I don't know the exact amount, right? So you give something as opposed to nothing, and let the electrician adjust if it is appropriate. But always account for it. Yeah, right, right. And then here at the bottom, you see where we got the lump sum for the switch gear and for the lights. And the lights always make it crazy. I mean, lighting is just crazy. See, and then I leave it zero for the overhead and the profit and the tax and whatever. But then here at the very bottom, I always give the relevant links, right? So they can have an idea, like, just from, now this one, that's right. This one that I didn't give us the wire configuration for the power, for any of these. And so I was like, okay, I don't know what size wire you need, but I'm just going to give you the links of everything. So that's what that's what I tell my electrician, tell the GC, here are the links for these, totals from the site plan. Right. And basically it said like based on design or something. I guess it was a design build that they hadn't figured out what it needed to be. But me as an estimator, I'm not an electrician, right? That's not my job to try to figure out your wire configuration, right? Because you want me to do it, something probably set on fire. So I can give you the links, as a good estimator should. But then, I told him if you know what your configurations are, just give it back, and then I can update the estimate. You see? Uh huh. Right. It really depends on, you know, there should be, there is a way to determine your actual overhead, right? Overhead's based on a lot of different things, but most people do 10 and 10 or 10 and 15 and what I recommend is, now it really depends on the kind of company that this company is. If it is like a huge company, which sounds like your company is, where you have a lot of employees and there are trucks and there's fringe benefits and vacations and workers comp and stuff like that, usually they will have a higher margin of overhead, of course, right? Because you have all of that fringe benefits, all of the workers comp. So that overhead is usually 20%, 25%, something crazy. and then the profit may be a little lower. I mean, it really depends. But what most of my clients are like mom and pops, right? That do their own work. And what I recommend is, do a reasonable base rate because you're making all the money, right? It's not like you're paying a, a crew. You're taking home that money. So give yourself a decent hourly rate and maybe 10 or 15% combined or 20% combined overhead and profit because you do want to be competitive. So it really depends on the business structure, how you do that. I mean, most with a lot of overhead. Mm-hmm.
About 40, and then I go in and or excuse me, we usually do the over and it's about 40%.
Yeah,
And
because you
then,
do.
yeah, and then we do our over for the profit. We don't charge. I go in and do that individually.
Yeah, yeah, right. Because you want to make something, right? You can't when you have a big firm with a lot of overhead. I mean, that's pretty much eats up your profit, right? So it really depends.
So that's
And what
you would
kind?
just put 4%.
Again, if you guys are using 40% overhead, what are you using for as far as the hourly rate? Are you using a base rate of for your?
It's about $30 an hour.
Okay, yeah, yeah, yeah. Well, then that's right then because your hourly rate's not very high. You go with the
Yeah.
base rate. So yeah, your overhead, and then I would do a profit of like 15%. If you guys are going with $30 an hour for the base rate,
Okay.
yeah,
And then
because you're not. Some people do like, oh, I want a $95 hourly rate. I'm like, okay, well, then you're not charging any overhead or profit then because you incorporated it in your hourly rate. You know. And you guys are doing just the opposite. You're giving a very low, which it should be, base rate. So yeah, you can charge a higher overhead, which it is because you do have overhead. But then you can give I would play with it to see if you lose, why? And maybe it was the overhead the profit was a little higher than it should be. I mean, if you're doing a 30 for the man hour, I would be in 40 for that. Yeah, I would be doing at least. I started at like 10%, try to work my way up to 15 to see how 10 did. And just like you said, you guys play with it. Because
Yeah.
you want to make your money.
And does it change all of the numbers or just the size total?
Say it again.
On some, like when you change like the overhead and the profit percentages, it changes everything within each,
Oh
or
no,
does it just do it?
no. It just changed the bottom line. Like in our case with this one right here, the
Yeah.
78 894 is set. See, you see our overhead profit is zero and zero. So that's that's the last thing you put in, right? Is your overhead and profit
Yeah.
because this is supposed to be your actual cost, right? 78 894.91. That's supposed to be out of pocket, and I really don't add very much markup on the material, so you could even add a markup on the material. I mean, if you did it, you could do it within the Excel spreadsheet actually. To mark up the material, we can make because this is an equation. We can make it. Oh, they did. Okay. No, see, we could say that times 1.1, right? If you do it times 1.1, you've added 10% to your material cost, right? One, you're multiplying it by itself, and then you want to add 10% more, so it's 1.1. That could be an equation, and I'll give you a copy of this one fresh, so you can go in and play with it and use it if you want to use this one on your own.
Awesome.
Yep.
That'd be amazing. Thank you.
Yep, and it'll save you time. But the thing about it, your supplier now, you're going to go and do what your cost is.
Right.
But the man hour totals, if you need assistance with that, just let me know because I can give you access to this craftsman so you can play with it for a little while. And then too, if
Yeah,
you
that
take
was
the class, I will definitely give you access to it for the remainder of the year. So,
okay. Cool.
yep. All right. So, any questions?
I and with the inflation
You cut
and
out. You cutting
oh,
out.
sorry. And I just noticed when I'm submitting my estimates to GCs or whomever, the inflation and the lead time and waiting right now is so crazy that they're not getting back to me within 3 2 weeks, right? I do my standard like follow up after the 14th day, just send them a little email, hey, just following up, yada yada. They're like, well, we're still just waiting to hear back, and then finally they just say, oh, you got the job. Um, we're expected to start next week. And I always try to put a big fidelity date on my estimate, um, but I just don't know what you think is appropriate, or do you ever have a bid fidelity?
You know,
Uh,
you guarantee, like at the bottom of all of our estimates, it says, it's based on plans and specifications and good for 30 days. So at the
okay.
end of 30 days, you have to reevaluate because, like you said, with the inflation and with the price of copper and everything, you have to
Right.
reevaluate your wire costs almost on a weekly basis.
Literally, like for right now, our transformers, like to
Uh-huh.
get any transformers or pads in, is a 3 year wait time.
Oh, see that? I mean, how that's not even sustainable. I mean,
Right? It's not even
it's
possible.
not even
You know where
possible.
people would get them from. They're not even taking new quotes. And so, he's like, you can give them a bid, but you got to let them know that it's definitely going to change by the
Yeah,
time he approves it or wants to
right.
go through with it.
And see, now with the way
So,
things are now, you might have to like systematically come up with a new protocol on how to do this because of that. You know what I mean?
right.
It's
I
like,
just didn't know if you've experienced that
yeah,
too.
with everything, especially with with one of my drywall people, they were saying that mud went from $19 a bucket to like $89 a bucket
Oh
overnight
my
for the
God.
drywall. I'm
Yeah,
like,
but
yeah. I mean, that's scammy and bad all at the same time.
that is
That's
terrible. What about
terrible.
milk right now? Just a damn bottle of milk here in my town is like $8.
Oh
In your
man.
town.
Oh man. Yeah, I mean, it's like I don't know, and it appears that people are still building stuff. I mean, I'm still getting
Yeah.
requests for big estimates. I'm like, okay.
Yeah. I mean, me too. I get more than I can handle every day. I wondered if there was a better way of, right, maybe, like, I just know that that's experiencing, like, instead of this acknowledge, like, should I put due to inflation and lead times, like,
Right. I mean, you have to
that,
give them as much information. You give them the same information as you're getting. Let them know the
right,
lead times and yeah, each estimate is only good if you can. I mean, we've not ever gone more than 30 days when it wasn't bad. So
okay, cool.
yeah, I wouldn't guarantee any estimate more than 30 days. And yeah, you just have to keep them on a continuous loop on following up because that's just the way it is,
Right.
you know?
Well,
So,
my boss, before I started working for him, he would never put damn go to date, and so he was getting screwed on some of these things right when this whole material
hmm
inflation. And I was like, Harry, you
yeah,
gotta put this on good for a couple days.
yeah, right,
Henry, like,
right.
he's an old guy.
Yeah, right. And he's probably not used to this craziness. But even that being said, I would put each estimate out with a 2 week date. These prices are guaranteed for two weeks, and at the end of 1 week, I would just be checking on your supplier because you may have to change it. Nobody's trying to work
Right.
for free. Nobody's trying to work for free. So it's just gonna take you following up because I was one of my clients. I do get a update on the wire prices every 30 days from him.
Oh,
So
nice, nice.
yeah, so at least every 30 days they should expect some kind of change if they haven't gotten back with you, and
Not never
definitely
going to.
definitely on every estimate let them know what all of the lead times are because at least that way they can't tell you they don't know or you know.
Yeah, you didn't tell me. I'm pulling out. Yeah,
Yeah,
bullshit.
yeah, right. Yeah, let them know on every estimate. And And you know what? Right now, you're just gonna have to just triple follow up on them as you know. And doing these estimates take time. You know, so yeah, I'm gonna follow up until you tell me I got it or I didn't. And another
Yeah,
thing I recommend is if you
offers over there.
say it again.
I said, yeah, throw offers.
Right, exactly. And if in the event that you don't win, you know, you don't have to ask them, you know, who won or whatever, because they won't tell you. But just ask them to give you what the winning number was so you can compare it to yours. That's all. If you can do that, yeah. And that'll help you a lot. You can go back and review and see where you could have made it a little more tighter or not at all. Because some people just lowball it and there's nothing you can do. But at least, you know, at least you can feel comfortable that, oh, okay, I only lost by so much. And you know, if somebody's doing it way cheaper, there's something wrong with it. Because you guys are professionals. You've been doing it forever. So,
They do their due diligence, look for shit, or you're gonna get
right. Like one of my clients says, yeah, chuck in a truck, right? Somebody that just show up and lowball it and win and can't complete it though, you know? All right. Anything else?
no man. I just maybe think if we could. I know we've been kind of talking in this email, but my boss Terry is gonna be really happy with this. He'd probably want me to sign up on something with you quite regularly, so
I can help you. Yeah, definitely. I love it. Electrical is my forte.
out in any chance. That'd be awesome.
Yes, definitely. And two, if you can, when we get off the call, please let me know what you thought about the plan. I don't have a form or anything. I just, if you could just email me and tell me what you thought, and you know.
Yes. Yeah, you're literally this that I sent you. I did a couple of they were construction manager, project manager courses at the U of U here in Utah,
Uh huh.
and man, you just out of the water.
Oh,
Bullshit.
oh, that is so cool. Make sure you yeah, tell me that in an email. That's awesome.
Yes, ma'am.
Thank you so much.
Yeah, see over that spreadsheet and
Yes.
some of those man hours, and then totally we'll coordinate on more classes.
Yeah, definitely. You just let me know, and I will. As soon as this tells me it's finished, right? I'm gonna send you because I have it on OSB, so it's still recording, so we can have this. It'll stay forever. So that's good. I'll make it private. That way nobody can see it but you. And it'll be on my YouTube page, but it'll be private. That way nobody can log on except for you.
Whatever.
He said whatever. Okay, well I'm gonna end the class now, and I'm gonna be waiting for your email, and just let me know what other class you'd like to take. Thank you so much.
Thank you too.
All righty, bye bye. Hello, this is Stacey with SF Johnson Consulting and Construction Services. Just wanted to go over quickly the Excel spreadsheet for the electrician. Now, the one that we provide is project specific. So if a particular type of wire is not included in that project, it won't be on the estimate. And so I'm going to try to make this a little bigger. Okay, so the way we break down the estimate is all of the wire and the MC cable. So if there is a different type of wire, different size, you'll have to make sure that you edit this form for the size that's there and then input your size. So for instance, if there was say we had to have number 2-0. So we'd highlight it, go to insert a row, and then we could insert what we need. Or if that's the case, we can just alter what we have here. Okay, so I'm going to go back. So when I send you this one, this is a project specific one. So if your project doesn't have these things, then it won't be, you'll have to edit it. Or one thing one of my clients does, which, it's a lot of work if you want to, but to have one master sheet that has everything on here, all the possible wire configurations, all the possible conduits, all the possible duplex outlets. That way you don't have to go in and edit. You can just put in whatever is specific to your project. Okay, so just know with the ones that you are being sent, it's going to be project specific. It's not going to have everything on it. So you'll have to go through and edit it like I did, changing the quantities, of course, the material costs, depending on what you put in there. But you'll keep the labor rate, and then the man-hour totals you'll get from the sheet that we provide, because we do give you man-hour calculators for all of the different wires, outlets, switches, and so you'll go from our calculator to input what that number should be, because our calculator will give you all of the man-hour units. Okay, so if you have any further questions about this, please don't hesitate to reach out to us or visit us at our website, S as in Sam, F as in Frank, johnsonconsulting.com. And again, remember, the one that you'll receive is project specific, and so you'll have to go through and edit everything out that doesn't apply to your project. You'll probably have to add some things, okay, and that's very important. If you need any further assistance on that, just reach out to us and we'll be able to help you. Thanks a lot, and have a wonderful day, and I'll see you at the next class. Hello, this is Stacey Johnson with SF Johnson Consulting and Construction Services. This week, we will be performing a full takeoff on our Scooters Coffee on our instant online estimator service that we provide for new estimators to help them grow and to show them all the intricacies that they will encounter sheet by sheet, project by project. Every week, we start a new project, so we hope this week, August 25th, 2022, you will join us for a full takeoff on every scope from the Scooters Coffee from the ground up. Thanks a lot, and visit us at our website, which is S as in Sam, F as in Frank, johnsonconsulting.com. Have a wonderful week. Hey guys, I hope everything's going good and you're not going too crazy in this estimating class. You know, the more we do, the better you guys are going to get. But in the class today, brought to my attention a couple of things about the cost book. And so I wanted to go over some tips on, you know, where to find the stuff and how to go over it. So remember, what will interest you in the electrical estimating class is either the regular construction cost book or the electrical cost book. And so what you're going to do is hit the file tab. And the first thing you want to do is you want to make sure you're in the construction cost book to set the cost book properties. So there are a series now. If you've got the main cost book, then there's 11 of them, and you'll rotate between the construction cost book and the electrical cost book. And so if you're in the construction cost book, we're going to set cost book properties right here, third from the bottom. Click on that, and then that is where you put the zip code. Okay, so make sure you put the zip code of where the project is in that location, in that spot, and so it will adjust material, labor, and equipment cost, okay, based on your project location. So that's important for one. And then two, let's get out of that. And two, to go to a different cost book, you go to Control B or Open Cost Book. You'll have a number of them. This computer's new, so I only have last year's and this year's. And so what you'll do is the blue section is where you want to click on. And so if you go to the electrical cost book, you'll be in the electrical cost book. Okay, and if you're in the electrical cost book, you cannot, from this location, from this cost book, you cannot go back to cost book properties. That's what it's going to pop up. And so that's why I said you always have to make sure that you're in the construction cost book. That's where you can make the changes to the zip code. Now, it's not a very good search engine that we have here. And so if, like, well, this first set we're on right now gives us handy boxes. Okay, so you see the prices of them, right? I was getting some questions on, which one should I use, right? So, if you have a simplex, right? Simplex receptacle, you might want to use that. But then again, these are just the boxes. So you would use this not for a switch, right? You would not use this for a switch. So if you needed a junction box, this is where you would get that. So what you'd have to put in there, because this is the first thing you probably, if you weren't already here and didn't already see it, you put in like boxes, box covers, see, and they have all of that, floor boxes. So if we need ones that would go in the floor, round ones, you see, and like we were saying too, the ones that go in the wall, the ones that go in the floor and the ones that go in the ceiling are always more expensive. Okay, so you see that one's 82 to 146 depending on the size. And the hole, right? It depends. The hole correlates to the conduit size. And so we want to always use 3/4 inch unless you know for certain it's a 2-inch for communication or something like that. But for the purpose of the class, it's not that important to make sure that you pull that out like that. Okay, for the purpose of the class, you're going to put what seems more reasonable. Now again, if you have a junction box for the outlet or for the communication or for the whatever, the simplex communication device, and you have like $85 for that one, and it's not in the floor and it's not in the ceiling, then that's probably not right. So I'm not really going to be too much of a stickler on, do I use the $7 one, the $4.50 one? It doesn't really make a difference. But the electrical cost book is a lot more detailed. It probably will give you too many choices. Okay, so that's what you're going to use that for. Over time, you're going to become better and better because you'll be able to look through everything that it gives you and then be able to determine which one is the best. Okay, so that's for that. Let me see what else. Remember for when you're using the cost book, the electrical cost book, and let's put in wire. We put in wire and let's see. Any one of them will do, I think. Okay, yeah. So we put in wire, whatever. But the biggest thing we want to note is the unit, right? In the electrical cost book, it's going to be KLF, which K signifies thousand. So that's the cost per 1,000 linear feet. Okay, so if you're going to use that number, remember but our form says per linear foot. So what does that mean? That means you have to divide by 1,000. So I would recommend using, let's go back to the construction cost book, put in wire, and we go to building wire. Let's see, let's go to copper. Where's my mouse? Copper wire. Okay. All right. So it gives you the choice between solid and stranded, and it gives you the cost per linear foot, and that's what you want. Okay. So you can use these costs in your estimate if you so choose. These are the size wire we use for our power plant. Okay, so which one do I use? The THHN / whatever or the X? Read it and see whatever's comparable. I'm not really, and the price is, I'll know if you've used one or the other. That's not the purpose, because again, when you're putting in the price of your actual material cost, you're going to confirm it with your material supplier to make sure you're using what you actually pay. This is for the purpose of putting out a lot of estimates when you want to, produce quality estimates very fast. This is a great way to do it. But the routine is really, and we talk about it in the class, but I'm going to talk about it here, is that we bid on everything we get. We send out a lot of estimates. When we win, we go back, we review it, we review all the pricing, because usually an estimate is only good for 30 days. So we review all the pricing, everything, to make sure it is in line with the current time. Okay, so, and again, for the purpose of the class, you're not really, she picked. Now, if you, on your estimate, we know it's a number 12 wire, and okay, what's number 12? 24 cent or 30 something cent, 31. If you put $5.50 for a number 12 wire, then I'm like, okay, where'd you get that? Because that's definitely not anywhere near, excuse me, the actual cost for a number 12. So, it's that kind of stuff I'm looking for, okay? And let me think, any other quirks? So, again, with the cost book, you're either going to rotate from the electrical cost book. Most of the time, you don't even really need to if you want to. If there's panels or whatever, there probably will be a more detailed list of panels in the electrical cost book as opposed to the construction cost book, but don't let that, worry you. But I would say use the construction cost book if you need something now. When it comes to switches and stuff like that, you want to put in there the word assembly, okay? Because a switch really is three things when it comes to electrical. A switch is the junction box, the switch that goes inside, and the cover, right? So I want you to be able to, if you, for switches, three-way switches, whatever. It may be it may be good to use the electrical cost book for that. And so I'm going to put in switch assembly, okay? Because we want the whole assembly, not just the switch itself. Okay, so switches in a 1/2 inch deep handy box with handy box cover. That's an assembly. Okay, so 2-pole, 1-pole 15 amp. Okay, so which one do I use of that one? Remember, if you wanted to, the pole, right, goes back to the breaker. So what breaker is that switch connected to? Is that breaker the switch connected to a 20/1? Then most likely it's that $8.33 switch. Okay, or if not, but the cost book will give you a lot of variety. Key switches, dimmer switches, 2-way, 3-way switches. So SW/3, that's a 3-way switch, right? So always use assembly for the outlets. So let's do outlet. Outlet. I don't think you need assembly for that one. So let's see. Single. See, that's just the outlet itself. So let's see if the word, it has a terrible search engine, let me tell you. I don't even think assembly and the word outlet go together. Oh, special outlet. Let's see what that is. Oh, okay. Let's see. Yeah, see, it tells you all about, and it's good to read through this too. See the box. So what is better is to go to the construction cost book for that. Outlet, circuit receptacles. Yeah, that's probably more like it. Yeah. Yeah, that's the whole thing. Connectors and box. So outlet $42. And you see 3 number 12 wires, 4 number 12, 5 number 12. There are some cases, and we'll come across some classes where, yes, we use more than number 3s. Okay, so Romex, that's the MC cable. Okay, so if you ever see that, Romex, that's the equivalent to MC cable. Okay, so these are the totals that I'm getting out of the construction cost book. Okay, so yeah, this is probably better. It's probably better. And it tells you what a circuit is, right? So cost per circuiting includes standard. See, that includes the wire. So we don't want to do all of that. We don't want to include wire. because it'll do 30 feet of wire in a 1/2 inch conduit. See how it just gives you the price for all of that whole assembly? The box, the switch, the wire, all of that. We don't want it like that. That doesn't help us. We just want the switch because we do all the wire individually. We just want the actual switch. So go through your cost book, figure out the cost that's best, or believe mine has a reasonable cost. Just leave those or something near it, okay? So if you have any questions, email me at education@sfjohnsonconsulting.com, and I will be more than happy to answer that question, and I will see you at the next class. Have a good rest of your day. Hey guys, this is Stacey with SF Johnson Consulting and Construction Services, and guess what? This is our new big project, the Friendship Center. So we're going to be working through this one. As you can see, I've already worked through it, know everything about it. But yeah, quite a few panels we got going on here. And the single line diagram is nothing to play with, right? So we've got to go through all of this, make sure we can do what on the power plan, because the single line diagram has nothing to do at all with where the actual boxes are located on the sets of plans. So this just, as all single line diagrams do, just gives us the, let's fix something. There we go. Just gives us the outline of how the power comes into the building and how it's distributed to all the panels. But, right, so we use this, we count all the stuff, existing, whatever. Got to make sure, we know where everything is. So that's the huge single line diagram and all of the panels. And then we have, this is a school that's being renovated and some new stuff added. So it's got a shop floor and lighting's going to be added. But there are some existing things that are there. And the thing about when you have existing conditions and they say, oh, re-lamp every light, but they don't give you anything to count, right? It's just, they've got us here. Yeah, we're fine. But it's telling us to do a bunch of stuff here, and just the sweeping arrows mean the whole area, right? But it's telling us to relamp with no counts. How do we know how many to do on this preliminary estimate? We just don't. And so that's a handicap right there for us. But it is for everybody that has to bid on it. So same thing here, check, relamp, da-da-da-da-da, but you don't give me counts. I don't know how many I have to do. Is it 1? Is it 5? Is it 100? So, all right, communications. We've got some cameras, right? That's going up. We've got a bunch of other stuff that's going up. And we know that as the high voltage electrician, because that's what we're doing, this is what the estimate is for. As the high voltage electrician, we are only providing the junction boxes and conduit for all of the communication devices, all of the cameras, all the fire devices, all of those things. And wow, look at our nice, beautiful lights. For the other rooms, we can assume maybe that all the other, with the sweeping arms, all the other offices, rooms, whatever, have the same amount of light. So, for safety's sake, I would note that based on the set received, there's no way to indicate how many lights that we have to change the lamps for building, da-da-da-da-da. So based on the one we do have, sheet, we've assumed that we have to replace, how many's here? A lot. 100, 125. Okay. So this is the lighting plan. And what do we do for the lighting plan? Just count all the different lights, and then we have to measure all of the MC cable, and then do all of our home runs. And as you can see here, on any lighting plan, this broken line indicates our low voltage wiring. Don't even measure that because we don't even do that. So didn't even concern myself with it. Sometimes I do it just for fun. Okay. But when you have this much, you already have a lot of fun going on. All right. So that's the lighting plan. And then we've got this. I mean, the lighting plan was got more stuff than the power plan. But with the power plan, you can't play, right? You got to make sure. And this, I mean, I'm looking at 27 keynotes just in this view. So hopefully that's all we have in total, 27 keynotes. Okay, so good set of plans when it comes to all of the mechanical equipment, right? Because the mechanical equipment may or may not be number 12 wire. And so I don't want to have to go fish through all of the panels to find out, right? So they're telling me, okay, good. Number 12, number 8, number 10. So what do I have to do? I have to find where the exhaust fans are, where the GF4 is on the power plan, right? Oh, here's exhaust fan, or yeah, and it's probably number 12. Or here's the whatever. Here's all the condensing units. So yeah, I can take that from that location in my imaginary uh, job as the electrician. And remember, when we're doing the wire runs, conduit runs, and we're printing right now, and it's just scared me because I'm not printing. Um, when we're doing all the runs, we're not doing it to be 100% exact. We're doing it in order to provide a very good allowance for all of the conduit and wire runs that would have to be placed to connect to all of our wiring devices. Okay, and so it tells me, yeah, here's all the panels. So you'll see that everything's going to come over here into this area from all of our home runs. Right, so that's the power plan. So this one's pretty good and pretty big based on, I mean, the last one we did, that little scooters, right? That was our number one. This is number two. So it's a lot more that's going to go into it. Probably give you a little more time to do it. But this is part of our electrical class. And so you can become a very good electrical estimator. All right. And then we got to learn the difference to what do we mean by all of this? As opposed to, basically, what does that mean? Why is this different from that? And in terms of calculating all of our wire and conduit totals, or mostly wire totals, why is that one different? What does that mean, and how does that affect us? And really, everything just comes into reading your symbols and what does that mean? There's so many circuits, so much. Because what we've done here is we've connected a lot of different circuits over here through junction boxes. So we kind of bunched them all in the junction boxes, all the different circuits. And now we're home running those three different ones to panel A2 in different positions. So we're going to read and look in more detail in terms of, again, takeoffs and our wire runs. What does that mean as opposed to this, or as opposed to it having nothing? So we'll figure that part out when we do the estimate. All right, so that's that. And then some telecommunication devices, right? We're going to provide all of the junction boxes and conduit to the ceiling for all of these. Right, so we know that this is 2 data, so it's a duplex box we need, as opposed to, I don't know, maybe all of them are duplex. Maybe not. I don't know. They may be. Oh no, wait. Here's one. That one's not duplex. Okay, so this is our next project. Oh, it keeps going. Okay, lots and lots, and it keeps going on and on. So this is our next project. Do your best to begin your accurate takeoff numbers. Here's your panels. That's about the easiest thing you'll do is count all of the breakers in the panel. But if you have any questions, anything over there, about a week and a half, you'll have to do the takeoff. Send me an email at education@sfjohnsonconsulting.com. And I will see you at the next class. Thank you very much, and have a good one. Hey guys, this is Stacey with SF Johnson Consulting and Construction Services. Just wanted to go over quickly our review of the lighting plan or the few lighting plans that are on the Friendship Center. Okay, so this is a renovation, and a renovation requires, sometimes depending on the quality of the plans, they may or may not put a lot of detail. And when there's not a lot of detail in the plans, basically the quality of the plans equate to how much, you want to spend on the plans. Just about like anything else that you buy. The more it costs, usually it's a higher quality item or product. And the same thing applies when we're talking about producing construction documents now. This is a renovation, and the first thing that pointed out to me was keynote number one. So when you're looking at, the keynotes are very, very important. You got to make sure you review those in detail. But this one tells us, now this is for the electrical set, right? We're doing the electrical estimate. So keynote number one says existing lighting in this area is to remain. Existing lighting to be removed from ceiling, cleaned, and relamped prior to reinstalled in ceiling. Store in safe location during reconstruction to prevent damage to fixtures. Okay, so one thing you'll notice, when we do our takeoff, right? What's the point of the takeoff? We're going to accurately count how many light fixtures, how many linear feet of conduit wire, whatever, how many switches. We're going to count. Well, they're asking us to, and then see, this is lazy because it doesn't show us basically where the lights are, how many there are, but they're asking us to do something. And this little sweeping arrow tells us, well, we're going to do it for the whole area. But, it's kind of difficult, right? We don't know how many lights, so we don't know the labor involved in taking the lights down, cleaning up. We don't know how many lamps we need that needs to be installed, all that kind of stuff. So when you're dealing with a renovation, just know you're going to run into stuff like this that's going to be annoying, and you have to figure out a way to price it. Now, if you have a good cost book, you can determine how many square feet of area you have, and I believe you divide by, an electrician told me this once. I'm trying to remember. Yeah, I think it is. You take the square feet and you divide by 35. I don't know what that is. That's some mathematical equation to determine how many light fixtures you need in an area. But if you divide by 35, I do it that way and just multiply that number by 2. That way you're really covered as far as doing that operation. And we have 2 lighting plans. So this is the lighting plan for the HVAC. Okay, so remember, this is a school, so there's a lot of different areas of the school that's going to be remodeled. So this is the auto HVAC shop, so that 35 per square foot probably applies because it's probably 2x4 lights in there. A lot of stuff you got to assume when they do it like that. And then, we have a few. So this is very detailed. So they didn't do it to this one. So this lighting plan is going to be very nice. Looks like we missed some lighting wire right there. No green. So let's go ahead and add to it right now that's why you never, on the electrical, you never rush an electrical estimate. Because chances are you're going to miss something. Okay, so this is our other lighting plan, easy. We can count, right? We can measure. But the first one, I think we thought we had 2 that were like that. This is a big one. Maybe not. So we have a lot. There's a lot. Oh, yeah. Is it this one too? Yeah. And this is the mechanical shop lighting plan. So same situation. Sweeping hands, 1. So I do the same thing. Okay, do the same thing. That's the lighting control panel. So it's showing you where that is. So what do? Usually our light fixtures are connected to the switch bank, and then the switch bank is connected to a lighting control or lighting contactors at some point somewhere in the building. So all of those linear feet we have to determine. But again, This is keynote number 1, the same thing. Existing lighting, clean them, whatever. So that's very difficult to figure out. Okay, so just know, do your best on the lighting, but the big plan, the big plan, there's a lot of stuff there. That's the power plan. We'll do that one next. The big lighting plan. Okay, so there's a lot of stuff there, a lot of stuff to count. Notice the difference in the broken indication as opposed to the solid. And usually on a lighting plan, when it's broken, that is low voltage wiring for the ceiling, occupancy ceiling switches, fixtures, that kind of thing. All right, so if you have any questions, make sure you email me at education@sfjohnsonconsulting.com. But good luck on this one, and we will see you in the next class. See you later. Hey guys, this is Stacey with SF Johnson Consulting and Construction Services, and now we are going to, in our continuation of the review of our community center, the Friendship Courier Center, we want to look at now the power plan and the evaluation as we do the takeoff. And so here, just like the lighting plan, it gives us a general note: existing power devices in this area to remain. Contractor shall verify all existing devices and wiring are proper or in proper working order. Well, again, those sweeping arrows with no indication of how many we need to look at or review or anything like that. So again, I mean, if you want to go by math, you know, outlets will have one every 10 feet. So you can measure 10 feet and say outlet, but we don't know if there's some in the ceiling. And so in cases like that, you'll give it an allowance of hours, man hours to take a look at everything. So I give it 2 or 3 man hours for that. And then estimate how many outlets you have. And I would go by the 10-foot rule. Okay, so measure how many linear feet of the open area. So however many linear feet all of this is. Okay, and then divide by 10, then you'll know how many outlets. And so I would just put that on there as an allowance, and note in the exclusions, or don't do anything at all. That's an option. Don't do anything at all and exclude all of that keynote number 1, and say that you can't properly adjust for the cost of that until you have an actual walkthrough, or you may have had a walkthrough prior to, and then you can fill that in properly. But the whole point is to be able to base your cost that you're given something based on something that's real. Just not having any idea how many outlets you have and what you're looking at is not, for my purpose of producing an estimate where I have to be competitive, it's not going to work. Or exclude the whole thing and say that, we need to have a walkthrough, or do you have an idea based on how many outlets we have? And see, that stuff like this for an estimator should be an issue. It should be something that sticks very badly with you, because your job as an estimator is to be very accurate and only base your estimate on what you see. So if you can't see, then you can't give it a number. It's really that simple. Okay, so remember that. But you also have some items here that are noted. Okay, so they are noted, and what we're going to note too is the special way that they note the power home runs. Okay, so these are 3 circuits, and they're all connected through junction boxes. And so this is 1 circuit junction boxed with the second circuit, because they're all being home run to different positions in the panel with a common ground, maybe. I don't know. I'm not an electrician, you know what I'm saying? But you need to be able to allow for that. And so if we know that it's MC cable, right? Because when we do our power, the electrician is allowed to use MC cable for the branch circuits, but when it comes to the home runs, uh, they have to use the actual number 12 or whatever it in wire. So I would definitely, in which I have in this case, because this is an actual estimate, consult with the actual electrician how you want this in actual linear feet, right? Because we have to determine how as close as possible, right, to how many linear feet of conduit and wire we're going to need for the power. And so, again, this indicates that we have a home run going to 3 circuits. This isn't equivalent to it being a piece of mechanical equipment, right, that has 3 number 8s and 1 number 10 ground. That's not the equivalent to that. This is 3 outlets that they have joined in this way and 3 circuits going to this panel. Okay, so that means that 3 times the home runs are going to that panel, where this is just the home run, right? But this indicates it's 3 times the home run. Okay, so we have to make sure we present it in that way when we're doing the actual measurement. And here's the panel right here. So not very far distance. Okay, so not very far distance. That is the tricky part. So make sure you're looking for that notation. 2 times the home run. 3 times the home run. Okay, very, very tricky. Right, what else do we have? That's the communications, and we'll do a separate video for that. We already looked at all the lighting. And remember, this is a building that has multiple rooms that are being renovated, right? So, and of course, if we were doing this for real, right, we would look at the specifications, make sure we know what's what and where is where. More of the communications plan. Lighting plan, vague, and then power plan. See, these are easy, right? Easy. Communications. And then we have a bigger power plan, so the larger power plan. Okay, so you know the story with the larger one. We do all of our counts. Make sure you're identifying each of the outlets. Are they GFCI? Are they just regular, right? GFCI maybe. Read the keynote. Make sure you know everything about what it's trying to tell you, right? So the home run is going to, this looks like K1 is the kitchen panel, position 8. And you'll note when we're doing kitchens, right? Most of the equipment outlets are going, everything, nothing is daisy chained together, as we discussed, pretty much branch circuited together. Most of all the outlets have its own direct home run to the position of that panel. Okay, unlike this. What is this? This is just connecting this to this and home running it. Okay, so junction box just connects one thing to something else. Like this, whatever one is, this junction box is connecting that piece of equipment to the power source to the panel. Okay, so this is a lot different. We got a lot of different outlets, a lot of junction boxes. Here is that home run we're talking about, going to 3 circuits, branch circuits in between all of the junction boxes. So this is just a bigger project to do a lot more counts. Okay, and because we have different panels, I always recommend your home runs, run them when you're doing the work. Note which set of home runs is going to which panel. So you'll have a total for home run K1, home run A2, or however many panels you have, and we'll go over the single line diagram. Okay, so existing panel A2, existing panel A3. Okay, so when we have existing panels along with new panels, and we'll go over it again with the single line diagram. But when we have existing panels with new panels, we do have to do something to the existing panels, reconfigure the existing panel. And so that's going to take a certain amount of labor. So you always want to include that. We call that balancing the panel, where we have to reconfigure, reconnect something different to it, or even connect it differently to the main distribution panel. You always want to account for that time that's going to take, and I give it, a couple of hours. So, I mean, that's really up to the electrician, but that's something that don't forget. Any of the panels that are existing that have to be reconfigured for the new equipment, the new everything, because now they have to, and just put it this way, when panels are connected, they're connected in a certain way for a certain power, distribution, consumption, all of that. So when you add new panels to that, then you're redistributing all of that. And so in some cases, most cases, the existing panels need to be rewired in some way. So you just don't ever want to forget that. And when we look at the single line diagram, you'll be able to see where that comes into play, and you'll be able to note that and add some man-hour totals for that. Okay, so power plan, pretty big, a lot of branch circuits, some home runs. Make sure you separate all the home runs based on whatever panel that they're going to be running to. That's very important for this exercise, and it helps you to easily determine, if you've covered a home run. Because I know the home run, well, when it does it in Plant Swift, it's going to give it a different color. So I know all the blues were the K1s, and I know the purple was the A2 panel. So it helps me visually make sure I take care of everywhere I see that there's a home run. And two, for the mechanical equipment, you want to make sure that you leave probably that for last. Okay, because for the mechanical equipment, it's not going to be number 12 wires, right? It's going to be 3 number 6 for the rooftop unit, 3 number 6, 1 number 10 ground, and a 1-inch conduit. Okay, it also tells you here the disconnect. Okay, and we know it's a fusible disconnect because it's telling you the size of the fuse. Okay, so for this, you have to incorporate the wire, the conduit, and the disconnect. The disconnect is not the same as the breaker in the panel. Okay, so keep that in mind. So for mechanical equipment, yes, you have to remember to account for the disconnect as well as whatever the panel shows you. And those are breakers. Okay, so in terms of running the home runs, I do all of the panel home runs, right? And then, yes, I go through the task of each of the pieces of a mechanical equipment over here to the left is accounted for with the distance. See, U3, we got at 45 linear feet. And remember to add the extra 10 feet. Yeah, because all of the mechanical equipment's on this roof, right? So you want to bring that conduit down to down through the roof into the panel. Now, as far as what type of conduit specifications, of course, it's going to tell you if it's EMT, and you use different, right? Because if it's underground for any period of time, it's going to be PVC. If it's inside, it's EMT. If it's outside, it's rigid steel. So, or, you really, when it comes to the mechanical equipment, it's really important to make sure you know what type of conduit. But for the purpose of our exercise, and because I don't provide you with the specs for it, use EMT. Price it for EMT. You can price for EMT or rigid, whatever you feel, but not for PVC. Okay, either way it'll work. But rigid is way more expensive, see? And so they'll always try to use the least expensive route when it comes to the conduit. But again, the specifications, that's the whole point of the specifications, to tell you what material you're supposed to use for every piece of the scope of work. Okay, so as far as the power, first thing, count all the devices, right? Count all the duplex outlets, all the specialty outlets, because we have a kitchen, right? We have to make sure we look for the kitchen schedule, because if they're NEMA, right? They're not going to be, they may or may not be noted on the actual plan. And so this is what I do. So if I know I have some NEMAs, right, on here on the schedule, but I don't have them marked on the plan, they may or may not be. And so I'll just go ahead and I know that, well, those are quads, probably don't apply. So I know that an AC, remember, it's above counter, so make sure you know too. Above counter, below counter. Well, if it's above the counter, it'll have AC. Otherwise, it's in the normal position where they show you every outlet's going to be. Okay, so I have to make sure too. I look at all the keynotes, because there's a ton of keynotes on here, and you look on the keynotes for what? If they ask you for a particular type of material or conduit or anything where it applies to the takeoff, right? So you always want to make, because some keynotes just apply to for the electrician to tell them where to put the device, right? Well, that has no bearing on your takeoff, but you do look at the keynotes always, because you want to see, does it have bearing on my takeoff? Okay, wherever that is. Where is it? I don't see anything on here that goes to 24, 26. It must be somewhere else, but yeah, we'll look for it. You look through it, or it may be these item number. So this is going to tell you which piece of equipment. So that's going to be on the piece of equipment. That's how many you have. So you know that you're going to count the outlets, and then subtract from the full list if it's not telling you which ones are the NEMA 5, 15, or whatever. So I'm going to count them all, and then I'm going to go back to my equipment schedule and subtract for each one that I accounted for. Now they should be, if they're in the kitchen, they should be GFCIs, right? And so you just have to figure out the method you use to not double count your outlets, right? So you could just count the outlets, period, and don't be concerned with this. And note in the end that, yeah, the kitchen ones, the ones in the kitchen, and find the kitchen. Where's the kitchen? That's corridor. This is the kitchen. So you're just going to assume that all the ones in the kitchen are GFCI. Okay, this is the kitchen. So these outlets here should reflect the number of outlets on your kitchen schedule. Okay, so that's the tricky part about kitchens. They're going to give you a kitchen schedule with the outlets, or they may have a direct connect. There's no outlet. I think I saw a few that were, oh wait, up here. One's connected by junction box. So that tells me junction box, probably hardwire if it's a junction box. And then direct connection, that kind of tells me that's a hardwire too, so may not necessarily be any kind of outlet, right? You take whatever comes out the back of the equipment, it's going to give you a set of wires. That's a direct connect through the junction box to the panel. So these are the only two things that would not have but then there's a note 26, so yeah, that's probably what they're talking about with the numbers. are, and you see we're not 1, 2, 3, whatever. So they have 2.1. So it's important to match these outlets up with the outlets that you count. But remember, those outlets are strictly just for the kitchen area. Okay, so, and that's, yeah, just for the kitchen area. And read the keynotes, because there's some keynotes that are unfortunately not on the same sheet as the plans, which poor set of plans, let me tell you, because it's not supposed to be that hard to go back and forth. Okay, and so we have 1, 2, 3 circuits. So for the purpose of this, we're going to have 3 times the home run. Okay, so home run times 3. Okay, keep that in mind. Home run times 2. This is just 1 home run. Okay, so this one's just a little more difficult, and more detail involved, because you have to look. Is it 1 home run, 2 home runs, 3 home runs? I might have saw. I may not be this one. I saw one that had 6. Because you have to account for the number 12 wire that accounts for that home run. That's why it's very important to make sure you sign up for your weekly classes and that we meet them. I've had some difficulty because of the holiday, but it's over. And we have to meet, because these are the kind of questions you need to be able to ask me one-on-one to get the full understanding. The power plan, yes, is the most challenging of all the plans. But if you just think about step 1, step 2, step 3, and reading all the keynotes, especially when it comes to the electrical plan, so you can make sure you understand what they're telling you as far as the conduit you're supposed to use, the wire you're supposed to use, the home run, and where are the panels, right? They give you the single line diagram, which we're going to go over later, but that's not giving you any indication where the panels actually are on the plan. And so you have to make sure you know where the panels are, where where they are in terms of the main distribution panel, because what do we have? The power comes into the building, and then it comes into the main distribution panel, and then that conduit, those power feeders, right, are shared or broken off to existing panels, and then existing panels, and then new panels somewhere in here, kitchen panels. Okay, so you got to make sure you know where all of your panels are. Where's another panel? I'll look in more detail. Wherever the wires are jumbled up, it's probably where there's a panel. Yeah, there we go. Kitchen panel KP1 is here. So you're probably going to need to know the distance for the power feeder from whatever KP1 is branched off of. It's branched off of either one of the panels or the main distribution panel. And so you're going to need to, that's another step, getting the lengths of all of the wire and conduit, but then also looking to see where the panels are, if there's a transformer, where that is on the power plant, where all the panels are, transformer, main distribution panel. And then if we have to go to the site plan, if it's from the ground up, which this one isn't, the one before was, where is the utility transformer in terms of the main distribution panel? So those are all of the things that you have to go back and forth and look at between the single line diagram and the power plan. Single line diagram is going to show you in one line how the panels are in relation to each other. And then for visual purposes, it gives you the wire configuration. So you can determine what wire needs to be the feeders between the panels. But it doesn't give you any indication of the actual lengths between the panels or the main distribution panel. That's where you have to go back to the power plan, scale it, and get your actual measurements. So this is a long, drawn-out explanation of that power plan for the renovation for the school, but it's a lot of stuff. And that's the whole purpose of us getting together and going over this, because each one is supposed to get more and more difficult. If you have any questions, email me, and make sure you sign up for your weekly help, which can be more than twice a week if you so choose. So email me at education@sfjohnsonconsulting.com, and otherwise I will see you at the next class. Thanks a lot, guys. Talk to you later. Hey guys, this is Stacey with SF Johnson Consulting and Construction Services, and in this video we're going to briefly go over the single line diagram for our Friendship Educational Center, as well as the panel schedule. Now, as you can see here, there are quite a few panels. This is an existing facility that has a remodel. And so what we have to do is you have to be able to distinguish between what's existing and what's new. And everything existing is going to be a little not as bold as you can see here, where the lighting control panel is a little darker outlined than the existing. But again, it says existing, so you know that they are existing panels. And so what we have to do is look at each of the panels, see what the breakers are, right? We have to add up all of the individual breakers that each of the panels will need. And when you have something like this, it is more, when we talk about the labor, we have to be able to talk one-on-one with the electrician to see if it's an existing circuit, but does it have to be modified in any way? Do we have to change anything? You know, a new spare. So yeah, we're going to have to include that, because they're going to have new spare breakers for the panel. Okay, and existing circuit. So it looks like what we did here was, there's a couple of ways to look at it. We just went through the whole, all of the panels, and added up all of the different breakers just for the electrician's personal knowledge. Okay, and so some are brand new. The lighting control panel is brand new if it has any breakers in it. The kitchen panel for certain is brand new. And we can tell which ones are new, because again, if they're new, it's going to be, it should say new on here somewhere. Or if it's not new, it should say existing. But we know that the kitchen panel is new, so we know that each of these are going to be new panel or new breakers. It's not going to be a rework of the breaker. Here, it's telling us that it's going to be a GFCI breaker. So make sure you distinguish those from the regular breakers. Okay, so that's very important. The ground fault circuit interrupter breaker is different from the regular breaker. So it costs more, it's different, so you got to make sure you pull that out. And so, you know, you will know which panels are going to be modified by looking back at the power plan. And if you see any home runs to any of the positions on the existing panels, then most likely that panel is going to be modified. Okay, we went over the power plan before, so we're not going to go back over the power plan in this one, but we know that there are quite a few new home runs going to the existing panels, or maybe one or two. That's how you're going to determine if you're going to need a new breaker for that existing panel. And I believe all of these panels are new. And so, yeah, we're going to need breakers for everyone. And so we know how the panels are read, right, from alternating sides. And if it is a two-breaker or a two-pole breaker, then it's going to take up two positions. Okay, so you got to just be aware when you look, like this is a 23, so it takes up three positions, and that's the way they kind of show you. And every set of plans is going to do a little different in the way that they show you, but the concept's the same. You have new panels, you're going to need to add the breakers. You got to account for the breakers. And if you have a good cost book, of course, it's going to account for the labor related to installing the breaker, so you don't have to worry about that. Okay, so these are all the panels, and then the single line diagram. Quite a few new panels. And so what you have to do, remember the single line diagram is not to scale. It doesn't show you where the panels are in real life. And so you have to go back to the power plan, find out where the physical position of the main distribution panel is. And usually the main distribution panel, and it'll show you, is pretty much in the same proximity within 10, 15 feet of the CT cabinet, of the main building breaker, of the meter. So usually those things are pretty close to each other. So this is maybe 10 feet, 25 feet, 30 feet, not even that much. Then you have to go on the plan and determine where the kitchen panel, and this is quite a distance from the main distribution panel, if I can remember. And you have to go on the actual power plans to do the how many linear feet, right, of each of the power feeders. Okay, so you have to find the physical location of each of these individual items, and by looking at the power plan and then taking the measurements. And then these numbers, right, just indicate the feeder. There's a schedule that says what 600 is, what 400 is, what 800 is on this same sheet. Okay, so we know that 100 is for number 3 wires and one number 8 wire ground in a 1 1/4 inch conduit. And so again, the single line diagram just shows you the whole system in one single line, but the distances between the panels can only be determined by looking at the power plan. You make sure that you have looked at every one of the panels that's associated with the project, and get to counting all of the breakers, because we're going to need to purchase the breakers, the panels, all that together. So you need to have an accurate count of that. Okay, so that's the single line diagram as relates to the panels. And again, the only other awkward part is the single line's not to scale. So what I typically do is just go from one end to the other and write out a sheet, and where I would say existing panel AS3 to panel ASDP, go to the power plan. Go to the power plan. Oh, that's the lighting plan. Go to the power plan. Find where the main distribution panel is, where the other panels are, existing panel A1, and then do that physical measurement from the power plan. Okay, and then we know that once we do the physical measurement from the power plan, we're right on. Give it 10 feet for up and down the wall, and you're pretty accurate. So if you have any questions, please email me at education@sfjohnsonconsulting.com. Otherwise, I will see you at the next class. Thanks a lot. Hello, everybody. This is Stacey with SF Johnson Consulting and Construction Services. Just wanted to talk briefly about a communications plan that you would have to analyze as the high voltage electrician's estimator and what to look at. Okay, so keep in mind, the high voltage electrician is responsible for bringing in the power into the building, power to all components in the building, including the lights and everything on the power plant. Well, the low voltage electrician is responsible for bringing in power, the wiring, the outlets for TV, computers, the fire system, Muzak systems, things of that nature. So the high voltage electrician's job will be to, it's Monday, provide junction boxes and conduit, usually just to the ceiling in most cases, unless it's specifically stated, like in some cases Sometimes they'll want the fire conduit to run to the IT panel, or some conduit, some part of the conduit to run to a different part of the building. So make sure you account for that and look in the notes. It will be specific on the plan, on the communications plan. And so you just need to make sure that you account for, and all the dots here indicate that we are accounting for junction boxes. And so by definition, and the way I teach my students, is that, yeah, if you're going to account for a junction box, also account for, just say, times however many, and I always multiply it by 10. So I give the electrician 10 feet of conduit to get to the ceiling, unless we know specifically that it's a huge auditorium or something crazy that you need 16 feet to the ceiling. But then we look at section views, and then that'll tell us, right? Section views not in the electrical set. So you have to look, go through the other sets to make sure you know the height of the ceiling. The ceiling plan, right, has the ceiling tag, and that will tell you the height of every ceiling. So in the event you don't know and never guess, you're going to go to at least the reflective ceiling plan to tell you the height of the ceiling. So in two cases, you'll either run the conduit to the ceiling, and it should say that specifically, or you'll have to run the conduit to a particular room in the building, the communications room, the electrical room, whatever, the IT cabinet, whatever. Okay, so always want to make sure you account for a junction box. And what do junction boxes do? They just hide the connection between the actual, maybe power wire for the piece of equipment and what you as the electrician have to connect it to. That just hides it, so nobody can mess with it, and it can be secure. It might need to be a waterproof junction box if we're outside. It may be a tamper-proof one. It may be an explosion-proof one if we're working in a hospital or a gas station. Usually gas stations have to have explosion-proof components, that kind of stuff. So, and one other thing to note in terms of the conduit, here it tells me 2D, so this is a duplex junction box. And so I always assume if we have a duplex junction box, we're always going to have twice the conduit going to the ceiling. And so instead of 10 feet of conduit, we're going to assume that we have 20 feet. And you never assume, but these are the ways we think when we're doing our estimate. You might have a 3D, 4D, it really depends. So you always want to look for that as well. All right, a lot of these are 2D, mean 2 data, right? And black and white usually means, but you got to look at the schedule of the symbols, because some electricians like to get fancy and don't mark it in the universal way it's supposed to be marked. Okay, so universally, it's supposed to be in a particular way, okay? So white is supposed to be data, black is supposed to be phone universally, but usually they don't do it that way. And so, sometimes they don't do it that way, so you have to make sure. But this definitely tells me it's a duplex junction box, meaning I need twice the conduit to go to the ceiling, or, again, wherever they need it running it. You're going to look at the keynotes. There you go. Provide 3/4 minimum to all C devices in open, exposed, and hard ceiling areas. Okay, so, that's easy. For the communications plan, that's typically all you do. All of the devices, you provide junction boxes, and then conduit to the ceiling. So if you have any additional questions, please email me directly at education@sfjohnsonconsulting.com. Otherwise, I will see you in class, dear students, and have a great week. It's Monday where I am, and today, as I'm doing this, make it awesome. Hey guys, this is Stacey. Just wanted to go over a little information you should think about in addition to all of your takeoff information when you have your demolition cost. Do you need temporary enclosures? Do you need temporary structures? Do you need temporary power? Are there going to be an amount of cleanup fees? And definitely with your demolition, you're going to have waste fees, your disposal, your dumpster fees, Recycle fees, those are things to think about. And two, when you think about demolition, in a lot of the cases, the costs are reduced. Your estimate cost would be reduced if if there is value in some of the items that you are going to retain. If you're going to retain a lot of the demoed items and they do have a value, they have a salvage value, then you should, or you probably will, be required to deduct that amount from your estimate cost. So keep that in mind. Anytime, and in the laws of demolition, there's laws associated with this stuff, that unless the owner requires or requests the item returned, then it automatically becomes the ownership, or it comes under the ownership of the demolition contractor. And so if that is the case, you should typically reduce the amount of your estimate. So you want to think about all of these waste fees and all of the salvage value information that you're going to deduct from your estimate. Will you have fencing costs? Do you have to, do things of that nature? So always keep that in mind. And those are costs in addition to the cost to actually physically remove an item. You got to think about the waste fees, disposal fees, the hauling fees, and the cash value of any of the items that you retain. And so, if you have any questions in addition to that, please email me at education@sfjohnsonconsulting.com, and I will see you next time. Hey friends, this is Stacey with SF Johnson Consulting and Construction Services, here to introduce a new segment of our educational program we call For Fill in the Blank Only. And this is for roofing and roofers only. And so what that is a program where we cover basics, estimating, and then safety related to that trade. And so we always start with the estimating or takeoff portion to introduce the trade. And what we have here is a small roof or a Scooter's Coffee. And this is the scope of work. So the keynotes on the roof, basically it is a TPO roof, 60 mil, over a half-inch DINS deck over poly insulation. Okay. And so what we need to do, we need to determine how many square feet of the TPO. We need to check to make sure if we have parapet walls, which we do. What is how many square feet of that do we have? Because chances are we're going to have the roof finish go over the parapet wall, right? And then we have some parapet caps, so we need to be able to, and this is typical for every roof, so it's not really anything, the square footage of the finished material, the cricket sizes, possibly, um, how many linear feet of flashing for a particular purpose. Anywhere where there's wall and roof meet is usually a place to put the flashing. So I always give how many, basically the perimeter of the roof, and then any of the cricket lengths, right? And what's a cricket? It's just additional framing we place over the main framing to give it a slope so the water doesn't gather here, right? So and the arrows indicate the direction the water's going to flow, right? So we want the water to typically flow uh, in this direction towards the valley, right? Kind of early, kind of early. All right. So we want the water to flow towards the valley, and it's usually some roof drains or, gutters, downspouts, and I'm sure number three, that's what that is. Let's see. Yep. A roof sculptor. So what do we have to do? How many square feet in total? We have to measure how many linear feet the perimeter, because chances are the parapet wall is the length of the parapet wall goes the perimeter of the building. We're going to look at the section views. That's a building section view, so we can see the thickness of the insulation, and all the other details, right? Because from the plan view, we can only determine how many square feet of the finish, plus we can determine how many linear feet. And so for the roofer, square feet of the finish, always determine how many square feet of opening we have. And this is an opening for a rooftop unit or condensing unit or something like that. Then we want to know uh, how many square feet. And, it's a circle, so we just square it out because we do want to be able to give to the roofer how many square feet of opening, because they're going to deduct that if they want to. I don't know. It's just waste, right? Deduct that from the total area of the roof. So, area of the roof, perimeter of the roof, because we're going to have to look at a section view to determine the parapet height. So, let's go here. So, we have 4 different building section views. So what this is now this building section view is good for a bunch of people. It's such a small building. So it's good for the framer. We need to know the full height of those, God, I can't even think. The full height of the shear wall. Shear wall height usually goes the full height of the building. So now I know that the shear walls are going to be this height. So I can use this for that, I can use it for the thickness of the insulation. I can use it for finished carpentry. This looks like 2 top plates and another, and it's most probably at the perimeter of the building. And so for my roofer, tells me my roof finish, right? And I can look and see that this is the board insulation as opposed to the batt insulation. And if I'm the insulation professional, I can use this too to determine the height of my insulation. A lot of good things from this view. But because we are the roofer, we have to make sure we go to the next view. Why? Because this is a call out, right? A detailed call out, meaning it's telling us it's going to call out just this portion of the building. And because we're the roofer and our roof is showing right here, so we know that our parapet wall, it looks like it's a different height, right, based on the side of the building. So we have to go back to the roof plan, and the 1/3.1 would be the height for these walls, because that section view goes through both walls. So that indicates that both of these walls are based on that height. Now, once we get here, it's going to change. We're going to look at 4/3.1. So if that parapet wall happens to be a different height, it's going to be at this point forward. We're going to calculate the different height. But for this whole section, till we get here, it's going to be whatever height is shown. And then these also have a different. Then we'll look at 2/3.1 for the height of these parapet walls. Because again, we can see that the parapet walls are a different height. Okay, so that's how we get that. So we go to, because I want to go to more of the detail view, so I'm going to go to 4/3.3. 4. It still gives me another detail call out. So I got to follow every one of them because I'm the roofer and I have to make sure I followed every detail call out until there's no more. So I still know a lot about this. I know that my finish is going to go up the parapet wall. I know I have a 22 gauge metal parapet cap that is this width, and I still got to go to 7/3.4. 7. So you got to have patience. And because you don't want construction defects, right? You're going to make sure you go to every view that you're sent to. And so we see here that there are no more views, no more call outs, no more anything. So this is the final of the views, the final of the detail views. And so as the roofer now, I know that I need to do all of this for my parapet cap. And I know that even the rough carpenter is going to come to this view too. Or have it, yeah. Because they need to do all of this. And then, if you're doing the siding, then yeah, you're going to come here too. It's going to lead you here too. So all of the views are based on whatever you do. If I'm the flooring professional, right, I'm not looking at these views because it's not my scope of work. But if I'm the rough carpenter, the siding professional, the roofer, all of these, it's my scope of work. Okay, so I have to go to every view. And so now I know that in terms of, because I'm looking at the plan, right, for my takeoff. And so I know that even for the rough carpenter, I know I have 2 of these top plates. So 2 times the perimeter of the roof, if I'm doing my takeoff for that, I know I have the sealant, continuous caulking. So I know how many linear feet of caulk I have. So I know from the container how many linear feet of caulking, 8 ounce, 16 ounce, 32, whatever, a bucket, whatever. So that way I can do a proper takeoff to do a proper material determination, material cost determination, right? Rain screen, high performance weather barrier. You don't want to miss out on any of that because if you do, chances are it's going to leak and you're going to have a construction defect. And if whatever trade was your trade, you'll be responsible for all the other trades that got damaged because you failed to do your portion. That's what I did for a living. Construction defect litigation adjuster. That's why you get that insurance. So just in case you don't show them, you don't know how to read set plans, you don't get to the detail call out number 6 or whatever, and you forget to put something in your construction and you blow it and it leaks and somebody gets sued because now the whole building is leaking. Right? Yes. No. So you want to make sure you know how to read your plans. Okay? Come to the construction queen. I think this is the only time I ever referred. Like, what were you thinking when you came up with that name? Oh, probably a shot of tequila. See, I'm perfect for this job. Anyway, roof plan. Okay, so here are our wall curb attachments. So whatever this is, you got to make sure you account for it. It shows you how they want it up the wall, right? Because, well, what's the purpose of the roofer? To make sure that no moisture gets in the building. Okay, so that's why we have the TPO roof on the roof and over the parapet and with a parapet cap with the caulking so water doesn't intrude into the building. Okay, and so what do we do as the roofer? Square feet of the flat roof. Now we know we have to break up the section view, right? Because at some points this parapet wall is 3 feet, some points it's 5 feet. So we have to do 5 feet times however many linear feet. So we're accurately determining the additional TPO for the parapet wall, right? And now we have to measure how many linear feet for the parapet cap and whatever else goes with our scope of work. And we have to make sure we're doing whatever this tells us for the openings, whatever this tells us, number 8, whatever this tells us, number 5, 6. Vent, that's easy. So we got a flash and it's going to show us at 5A. Let's go to 5 over A 3.6. 5 over A 3.6. 5. I never pan in the first time right. Okay, so here's the vent pipe. Because what's the point? We don't want moisture coming into the building. So we have the vent pipe, that's the plumber. And now we have to do all of this. We're the roofer. Okay, and so you need to know how to do it and how to account for it. And so it's a vent pipe, so it's a circle. You could treat it like a square. That's fine. When you're doing actual takeoff numbers for, okay, how many linear feet of TPO to what point, and it tells you, I think, stainless steel clamping ring, sealant. See, what's the point? So no water gets down in there. So you have to be able to follow every section view, detail view. So you're doing the right thing. Okay, roof deck, rigid insulation. And if this is to scale, which it is, then you can just measure what's the thickness of the insulation. That's the whole point of having something to scale. You don't know. It's like, 4 feet, 4 inches, 6 inches, whatever. What is this? This is different from that. So you got to make sure what that is. Okay, so it's fun. It's a lot of fun. All right, so roofer, you are going to make sure you know how many square feet flat, how many additional square feet for your parapet wall, parapet cap, all the goodies that go with that, and know the heights. That's why they give you the section views, because the section view marker is if what? This is, we cut down in two, and now we're opening up, and we're standing in here, and we're looking at the interior construction so you can have a better view. And then that view will take you to a detail view, most likely. Okay, and take you to all of these other places so you'll know how the vent pipes come and are flashed, and how let's see what 7 is. We didn't look at 7. Air condenser, see mechanical drawings. Okay. All right, so if you have any questions on anything that we presented, please email me at education@sfjohnsonconsulting.com. So in addition to this, we'll have stuff like safety for the roofer, what the project manager needs to know from a roofer from that kind of perspective. So join us every day. We have something good for you. And if you like the video, please let me know. And again, email me at education@sfjohnsonconsulting.com, and I will see you next time. Hey guys, this is Stacey with SF Johnson Consulting and Construction Services. And in this video, we are going to go over some structural framing for our class and our special segment on our website for framers only. This is the structural set, and in the structural set, this is the cover sheet. The structural set talks about all of the concrete framing components, posts, anchors, concrete masonry, everything related to the structural set. And so in this set, we're going to talk about the structural framing. And what is structural framing? It's the shear walls, it's the posts and columns and headers and beams, and how they are connected and supported. And so this is a small coffee shop, and the first sheet that it gives us is a configuration of the shear wall. So it's the shear wall plan. So it gives us the shear wall schedule. And what is the shear wall? It's additional framing that you put over the structural framing to give the walls more resistance to shears. In this case, it's showing drift for snow, or for wind shears or earthquakes in California. And so you give the walls some additional structural components to make them stronger, basically. And so what is the shear wall? It's basically just plywood on the exterior portion. Well, because it's right, it's at the for the rough framing. We're not talking about drywall. We're not talking about framing that's on the architectural set, right? So it's just so we have the rough framing, and so we're going to connect the shear walls at the frame of the structural walls and it's nothing but plywood, okay, half-inch plywood, and it tells you how to place it, basically between the posts, right, and how to nail it. Okay, so what is this? 10D at 6 inch off center. So shear wall 1, the hold downs are these. It looks like all the hold downs, no, they're not the same. Hold downs are as listed. Then the anchor bolts are as listed. Okay, so 10D is the size of nail. 6-inch OC is, so we're putting a 10D nail every 6 inches on center. And the hold downs are as such. So we're going to have to look at, if we really want to get a good look at this, we have to look at the structural sections, right, in order to see exactly how everything is placed. And so the anchor bolts, this is the size. And for shear wall 1, they're placed every 2 feet, and we work our way down to every 32 inches. So basically, it shows us here. So wall B, and now we have these are wall B. And so now, this is just the shear wall, and we have to go to the other page in order to find out, well, what is B? What's the configuration of B? What are we talking about when we are talking about B and A? And that's on the other sheet, okay? So this basically just shows us the shear wall configuration, and we have to use this in conjunction with this. And so what's A, what's B, what's 1, what's 2? Here's the actual roof framing plan, and then the foundation plan, which in the foundation plan, they also kind of mix up your, they put everything that's for your framing here. So, it's kind of like, for my liking, I don't want the king studs on the foundation plan, right? Because the foundation plan is concrete, right? For me, it's a one. See, we have a single story building, right? So it's kind of like, okay, do I put it here? Do I put it there? But because it is framing, we should put it on the roof plan. But every architect is going to do something different. So what is my job? Let's go back to what my job is. As the framer, structural framer, I have to be able to do the takeoff for this thing. That's really so I have to do the takeoff for the shear walls, and I have to do the takeoff for all of the king studs. How many? What's the height? I have to do the takeoff for the headers. How many linear feet of each type of header? What is B? So that's why we have to use this sheet in conjunction with the sheet that we already saw. What is B? Well, B is the header. And what's a header? Header is, let's go back. When we put that's what I don't like. It has the header here and the header here. But no, it doesn't have a header here because it doesn't mark it. It only has the king studs here, but the header's over here. Okay, so what's a header? That's header B. Anytime we put a hole in a structural wall, and a hole is a door or window, you have to give the strength back to the hole so we can place the roof joists and they can be secure. So we put headers in doors and windows. So it's a combination of 3 or 4 2x4s, 2x8s, 2x6 with the plywood to fit the gap. So let's go back to see let's go forward to see what header B is. See, I kind of don't like when you got to go back and forth. Everything that you need on one set should be on the set. There's no reason why they couldn't repeat this on the sheet that we actually need it on. So it's like, oh, if you're new to this, I'm like, okay, well, what is this? And yeah, when I was new to this, it drive you crazy. It's like, well, wait, where's A, B? Oh, it's on a different sheet. It's always, it should always be on the same sheet that it's referenced. But in this case, it's not. So we have to keep going back and forth. And so what I would probably do is just print this out. So when I go to the next one, I'm like, okay, what's header B? Okay, I already know because I printed this out. Okay, this is a pain, but it is what it is. You know what I mean? You work with what you got. All right. So what's header A? It's 3 2x10s. We know the buys wood, right? X wood with 2 1/2 inch plywood spacers to fill the gap, basically. B is 3 2x8s with 2 1/2 inch plywood spacers, and header C is 3 2x6s with 2 1/2 inch plywood spacers. So when you're doing the takeoff, you're basically saying 2x10 times 3. So if I measure 25 feet, I'm really going to say 75 feet of a 2x10. That's how we do that. And 1/2 inch plywood spacer, 1/2 inch thick by, 1/2 inch by the width, by 2. Half by, because you need a height for it to be very technical on your takeoff, right? You need a height and a width for that plywood spacer. So you just got to sit there and, do the math. It's easy. Okay, so some stuff is over here now. What's B? Shear wall schedule. See, but this B is nowhere on this, right? Because this B, well, where's 1 and 2? See, 1 and 2 is nowhere on here, so I hate this set of plans. So what we're going to do is we have to measure 1 and 2. That's here. That's all of our 1. Because your shear wall isn't continuous. It's only where it's noted. Okay, so that's confusing too. That's why I decided to get a very confusing set of plans. Okay, because here's the shear wall, here's the symbol. So when we see octagon 1, 2, 3, 4, we need to look for octagon 1, 2, 3, 4. Okay, so that's here. Octagon 3, and it is only where you see these symbols. So it's not everywhere. Okay, so that's a pain. So we'll do those measurements. Okay, and remember this is for framing only. So what do we need to measure? The length of the shear walls, how many linear feet. Then we're going to go to the section views. And see, these section views don't help because they don't go all the way to, they don't tell you the height. Okay, it shows you, see, it breaks it off right here because this is the header. Man, this sucks because your shear wall is going to go the full length of the wall. So this right here is the header. Where's the header? Header's at the top of the window or the door. And so you have to figure out what's the top of the window, and it tells you right here, reference the architectural set. So you see how difficult it can be to navigate when you have a crappy set of plans. And what's our job for framers only? Measure how many linear feet is shear wall, and you got to figure out what the height is because you need square feet for shear wall. You got to determine how many linear feet of the header. See, this is the one with the 3 or 2 or whatever plywood header, and then it tells us to reference the plan. So this is from section view 2 on there. Okay. And so, yeah, it could be a little difficult But this is just the basic overview of the plans, right? We got to get a basic overview. We're the framer. Basic overview is kind of crap because framer, we need our rough framing. 3 king studs and 1 jack stud at rough opening typical. So whatever I see here, so that's why they don't have to mark this one, because they've already marked it here. They gave me the details. Typical means this picture right here, whatever I see that represents this picture right here, which is like what, this one, that one, that one, that one. Oh, see, no. Okay, so corners, typical. So the corners, we know we have 5 at the corners because it told us. Typical is the key. And then at the openings, we have this configuration, typical. And this is an opening. And I just have to know it's an opening because I should know it's an opening. This represents an opening. Okay, so a little confusing, but not really. So again, what am I doing? Measuring how many linear feet of shear wall. This represents the shear wall, octagon 1. It's only this many linear feet. But at the corners, I have this configuration and that. So I have to measure what? 5, 10 king studs times 15, 20, 12. I don't know how many linear feet because it's going to go from the foundation, right, to the roof joist. So I have to get on another set of plans if this section view doesn't show me, which it doesn't. Okay, it only shows me from the header all the way up. Now it's very confusing because I have the shear walls. Let's go back to the shear walls. Well, we know that the wall is, let's go back to the floor plan, right? Floor section view. Here we go. Okay, so now we're in the architectural set. It's not telling us anything about these, right? That's our header that we're looking at on our structural set. It's not giving us info about that. But see, we have to go here to determine the shear wall height because there's nothing that tells me, and shear walls are usually that's the whole point, to attach it to the foundation, to the roof joist, and then above. And so that's the only detail, and I would just, when you do the estimate, you just got to be very detailed on how many linear feet, how many square feet of shear wall are you allowing for the plan. You got to be very detailed, especially when the plans aren't detailed. You got to write out a lot of stuff because you want whoever's reviewing your estimate to know that you've done the best based on these plans that you're given, right, to get the correct numbers. And so over time, we'll have the takeoff completed, the visual completed so you can see it. And you also have the pricing from a cost book. And then with the cost book, we'll be able to tell how long something takes. That's the beauty of this whole thing. Because you want to be able to price it correctly. If you know how long it takes, you'll be able to price it correctly. You'll be able to know how long each job you do is going to take. And so you'll be able to schedule work for the whole year, right? If you have 5 jobs and you know exactly how long they're going to take, you know if you need more work for the year. You can't just work, oh, I think this is going to take 2 or 3 weeks. No, there is a way to determine, once you have your full takeoff completed, how long this job is going to take to do every portion of the scope of work. So let's go back because this is for the framer. Okay, so the framer, what I'm going to do is shear walls. I got to measure how many linear feet of the king studs, right, from foundation to roof joist. I have to determine how many linear feet of the headers over here. How many linear feet of header I have? And now, how do they represent the roof joists? Structural framing is always represented with the arrows, the sweeping arrows. So I know the full roof joist configuration. And if it was some different, if it's something different than 2x12s, it would have another sweeping arrow and give me whatever that is. And so the full roof joist, structural roof framing is structural framing. We know it's all 2x4 at the 16th on center. And then we have to look at, because we have a hole in the roof, right, to hold the condensing unit and the air handling unit and whatever unit. So these structural roof joists have to have their own additional structure to keep the air handling unit from falling through the roof, right? Okay, and so for the structural framing, there's a few totals that we'll come up with. All of the headers, all of the shear wall totals, all of the roof joists. Now you can do the roof joists because you actually buy roof joists based on not square feet, but how individually, right? In all of these individually, and it appears that the majority of them are 17 feet 11 inches. So that's good for this one, because if the building was built another way, then we'd have to tailor our roof joists to fit that length, right? Because these are made specifically for the building. Okay, so again, for framing only, what do we have to do? The structural framing, not architectural plan framing. Structural framing, architectural plan framing, two different things. So this is S plan as in Stacey. So what do we look for again? Shear walls and posts and columns. Basically, these are acting as posts. Pretty much these are acting as posts, because it's single story. You don't need anything to other than that, but that's a lot. These are posts or columns, whatever you want to call it. Call it either one. They have the same purpose. So, again, I repeat myself. Structural framing, what are we measuring? Shear walls. And that's all is represented by this configuration. And on the other sheet, it told us what octagon 1, 2, 3, 4 plus the anchor bolts. So really, we can determine first if we know how many linear feet. And it should tell us more about the nails. It's like, okay, 10D nails at the 6-inch. Is that at the framing? See, we got to look more in detail on the nailing, because it's just, yeah, every 6 inches, but at the corners in each direction. So that's something else you got to look for. Okay. And you can figure out how many anchor bolts you need. If you know how many linear feet, you're placing them every 2 feet. So you figure out how many anchor bolts you need, the hold downs. You can really determine how many nails you needed if you wanted to. Okay, so shear walls. And then we say, well, how many linear feet of shear wall? Octagon 1, 2, 3. Figure that out. Then all of the corner king studs. Figure that out. All of the headers. How many linear feet of whatever configuration it says it is. So, right? Headers. So remember, it's not just one stretch of 2x10. If I have 100 feet, now I've got to get 300 feet each cut that size, right? Because within each opening, I have to put 3 plus 2 1-inch half plywood spacers. So that's what the structural framer does. Got to figure out all those totals. We'll have all of that done shortly in a video reviewing all of that, and then we'll have video 2, which is pricing, and then video 3, which is formatting an Excel spreadsheet so it can look nice and pretty. And so if you have any questions related to any of this, please email me at education@sfjohnsonconsulting.com. Tell me what you think about this. This is very crazy, right? This is not a very easy one. Structural framing, like electrical, a lot of little details. If the plans aren't really good, you got to go back and forth and back and forth. And you can't make mistakes as an estimator. You got to make sure everything is right. So you have to take your time. So you'll see once we work through this little by little. And again, any questions, please email us, or otherwise, I will see you at the next class. Hey guys, thanks for joining me. This is Stacey with SF Johnson Consulting and Construction Services, and we are going to go over the full review of the OT Tennis Academy for our electricians only. And so what we're looking at here is the site plan. Pretty simple. And this is a series of tennis courts, right? So what we're going to have are a bunch of like parking lot light poles, and here they are. We just have to count them, right? And then, of course, all of the conduit is going to be underground, right? And it's going to be PVC. And so just make sure we follow the notes. And in some cases, it's going to give you, right, it's going to tell you the home run. It's not number 12s. Okay, typically when it's that distance and for our lighting, it's going to be number 10. Okay, and so keep that in mind. So what you have to do is make sure you know where the panel is, where the main distribution panel is, with reference to the court. So it will be somewhere. You're going to have to look at the building, right? Look in the building. Oh, it's right here. I didn't want to tell you, but I just told you. Okay. So here, this is where it's at, and, this is pretty simple. So this is the site plan. Everything is pretty well outlined. Make sure you follow all of the keynotes, okay? And allow for transition from PVC to either rigid or EMT, depending on where it's coming in at. Okay, and the power plan and lighting plan, all on for the building, all on one thing. It's a nice, neat little plan, right? It's really simple. You can't really mess up, right? Just do your counts correctly. If you have a good counting tool, you're not going to mess it up. And 2, make sure you distinguish between the emergency fixtures and the ones that are not. Okay, because they cost a different price, they're different, everything's different about them. Okay, so make sure you do that. And pretty simple for our power and communication. Your junction boxes where they're needed, make sure you do all your home runs, and you know that unless it tells us something different, it's all going to be number 12s. Follow all the keynotes. Okay, and last but not least is our all of our panels. Okay, and so just make sure you get all of your breakers correct, and make sure you know how many positions in the panel, because the labors, depending on the number of positions in the panel, pretty simple. And then your single line. And what I normally do, right, when I'm doing my conduit, look at your keynotes. It's going to tell you the assembly for all of the wire. Okay, and so I normally just start here, and all of this stuff is really going to be on our on our Excel spreadsheet for all the switch gear, right? And I usually do this the very last thing. And see, this right here shows me that this is underground and it comes up, but it shows me this too seems to be underground and it comes up. So make sure you account for this portion of your conduit to be PVC, because it's going underground and it's coming back up. Okay? And so that's it. If you have any questions, email me at education@sfjohnsonconsulting.com. I will have my take up off. I won't have my stuff put up there until all of your work is due. And so if you have any questions, email me, and make sure to make your at least two times a week your appointment to work directly one-on-one with me. But thanks a lot, and I will talk to you guys next time. Hey guys, this is Stacey with SF Johnson Consulting and Construction Services, and I am here to talk to you about the project for this week. This would actually be project number 4 for our electrical estimating class, and this is a dentist's office. This is Conroy Family Dentistry, and we're going to do something a little different on this project, where you'll have an additional piece of work to do, where I've also included the specifications in with your documentation, and I need you to review the specifications and tell me what the electrician needs to, what does it tell the electrician to do in detail. Give me detail in an email. What do the specifications state that the electrician needs to do? You know, when we do review a set of construction documents, I kind of been letting you off easy by not reviewing the specifications, but we know in real life we have to do that. And so I will have you, in addition to when your takeoff is due, also give me the additional information that is required from the specifications. And so photometric plan shows you how the light is, parking lot lighting is supposed to hit the full parking lot area. That's, of course, nothing we need. And here is our electrical lighting plan. Pretty simple. Bunch of 2x4s, a bunch of dome lights. It looks like, okay, the typical emergency. Okay, so pretty simple. Probably a lot of different, names. And what I want you to do, that this is that you could say, instead of counting individually, three-way switch, you could say that it is a duplex switch, right? It's a duplex, two gang switch. You can do it that way if you find that there are a lot like that. That's fine. You can do it that way if you find there are a lot like that. Or you can just do them individually. Either way will work. Okay. That's the lighting plan and the power plan. Okay, so dental offices, we're going to have some underground, some floor boxes, right? And that's a quad floor box. And, of course, dotted lines underground, power, and this indicates it comes up, right, up to from the nearest wall into the nearest power, right? So both of these are individual, because you see that they go to individual positions on the panel, right? So it's basically telling you that that's the home run, right? That this one's going to, but it's going underground, coming up individually, right? Because we can run more than one circuit in a piece of conduit, but we're just going to do one for one. And if we see here in the rooms, right, both of these are going to position 16. So what we need to do is do that MC cable trick that they're not showing us here. So you can do it in the most efficient way, right? They're all going to, so it's not showing you MC cable, right? But we know that in our minds, if these are going to the same circuit, it's not like a home run, that we can MC cable them here and wherever, right? Because they are going to the same circuit, as opposed to the floor boxes that we see that they're each going to a different home run, a different single position. Okay, so you want to look through all of your rooms now, because we may have multiple rooms, right? That have, because you can have up to six. Usually, I've seen up to six duplex outlets. Daisy chain pretty much together, and then home run, da to the position. So you need to be aware of that. Okay. So when we do the takeoff, we want to see that 59, 59, 59. Well, zip, right? 72, 72 all together. So that's why sometimes you got to go in there and look, and like it's like 66 and 68, 64. See, it gets a little crazy. But the whole point, right? Going to the same circuit. So you got to keep your eyes open for that. Okay? So that's the power. The power is always more difficult. And then we've had our mezzanine, and then our roof, right? So we've got our disconnects. We got to make sure we count those. And we know, because it's telling us going to 3 different positions in this panel, likelihood it's not all number 12s, right? So we got to make sure we know where that is. We got to look at the panel. There should be some schedule somewhere telling us the rooftop unit or the mechanical plan power. Okay, so make sure we do that. All the disconnects, all the home runs. This is all on the roof, right? So we have to, in our mind, make sure we give everything an additional 10 feet to go down, right? Lighting and power. And then the single line diagram, pretty big, right? We go from outside. Okay, we got everything in black, unless noted, is something we have to account for. So we see we have the conduit going down underground, then coming back up, right? And then staying up. And then the mezzanine part, so make sure you give an additional, to go up to the mezzanine for the power feeder. And remember, single line diagram, it doesn't tell us anything about distance. It's not to scale, right? NTS. So we have to go on our power plan, find out where all the panels are in position to what we see on wherever, right? And do the measurements. Okay, so this one was the first page. This is our HA panel. All of our breakers, so we know, okay, so here we go. So now we see from the panel our rooftop, our mechanical equipment wire. Some are number 12s, they're number 8, 3/4 inch. Okay. And then the next page is all the other panels. Then the lighting control panel, got a whole cabinet for that. Okay, so we have to look in detail to see what we have there and account for it in the material. And we see all number 12, a lot of number 12. So we're going to note, we're going to go back on our power plan and find the X-ray home run and make sure we break that out. X-ray, look, X-ray home run. Okay, and all of the signage, number 10, corridor lights. Got to pull all of that out when we talk about the home runs. Because remember, what we're talking about here is the home run wire. Whatever's home run, right? If we're talking about the wire at the panel, we're really talking about the home run. So we got to make sure that if something says other than 12, washer, dryer, okay, we got to make sure we account for those, and it's not number 12. And look on every panel, copy machine, compressor, vacuum, condensing unit, server room. Okay, so you got to go to the power plan, find where those are, and do the physical measurement from that home run to panel LB or wherever it's going. Details, all of our lighting. so we can see what it is. Sometimes you have to look at the lighting. Nobody's home. Sometimes you have to look at the lighting schedule to sometimes because you'll think it's an individual light and it's a string light, right? It's a string light. So you got to measure a length. I don't know if that's the case in this one because, I do these and I forget about them because there's so many to do. But you have to look because it'll tell you. Okay, so you have to say recess surface and it'll say, what, string or something. You'll know, okay. I need to measure where I see that, or to be noted like something like that on the plan. Okay, also site lighting. Make sure you look at the details of your site lighting, and I got to go back and put a video on that. I don't know the other one we did, because chances are you're going to need a 3/4 inch ground wire, a grounding rod for each of the light fixtures. So make sure where is our site plan? It didn't really give us, those are, okay, so they didn't give us much of a site plan. Did they give the wire? I'm going to have to look. Maybe we're missing something. Yeah, because that's the plumbing plan. They didn't give us a detailed site plan. That might mean they're already there, but it's on the lighting schedule. So, but this is from the ground up, so they're not already there. So I would have to call the GC. Hey, you want me to just guess? Maybe that's a light on. Yeah, we're missing a site lighting, so I would have to get that. But we're going to work with what we got. And we'll show you when we do the takeoff how we work with what we got, because we don't have time to call these people and they should have everything we need. All right, so that's that. That's the lighting plan. A lot of lights, lots of lights. Make sure you designate between the regular and the emergency, as it does make a difference. Let's see, power's a lot of stuff. Underground. Okay, account for two powers coming up from the ground at each one of these dots, right? Because each one of these is a home run, basically. And it shows you whatever 2 is. Lots and lots of notes. Okay. See, underground you have not only the power, but you also have 2 sets of conduit. So make sure you read that 1/4 inch for the communication conduit. That's under there too. So 1 and 1. That's where wherever we have that 2, we have communication and power. That's very, very important. Okay, so if you have any questions, email me at education@sfjohnsonconsulting.com. But this is the one we're going to begin this week, and please subscribe and like and all that good stuff. And every month we have now drawings for $100 Starbucks gift certificate, $1,000 estimating credit for any company that listens, and free OSHA 10 and OSHA 30 certification every month. All that is each month, and you get the certification. Although now OSHA, you can have access to all of our study material for free, but when it comes to the live presentations, you need that to actually be certified, right? So you have to sign up and pay for that, but all the educational stuff, all the videos, all that stuff is free. So make sure you join, tell your friends, and I will see you later. Hey guys, this is Stacey with SF Johnson Consulting and Construction Services, and this is a new one for our estimating class and for estimators, electrical estimators only. And we're going to be reviewing, this is just an introductory review to our Chase Bank that we're going to be preparing. It's a Chase Bank from the ground up. So not a very big bank. So we see the lighting plan, pretty straightforward, pretty clear, nice. Not a lot of keynotes. Well, on a lighting plan, we don't have very many. So we know that there is a panel called PP1. And that's where the home runs for the lighting plan are going to go. And if we're lucky, they'll show it on the lighting plan, but typically they don't show any of the panels on the lighting plan, even though it is for the lights. So, you'll be able to find it, or you may. Hmm, probably not, but it is on the power plan. Here's the site plan. This is kind of weird. Looks like they're going to have it go right over the building, because if it was underground, it would probably be a broken line. So that's kind of odd. Like this one is broken, right? Underground, oh, it's far away. It's quite some ways away from the bank. That's the underground, the secondary. Okay. So we'll have to look at the single line diagram to give us what that is. And then the power plan, roof plan, all the disconnects. Got to make sure we know, again, as always, the wire configuration for the mechanical. We have a switch that can turn on a motor. So we got to make sure we have all the right ones for that. I don't know. It may come with the equipment, so that's something we need to check and find out. We won't have to look at the specifications with this one. I didn't include it, but on the ones coming up, I will give you we have a hotel coming up, and you'll have all the specifications. You got to read through those. Okay, and so here we have a drive-through with some, I'm sure, and we know that it is the break-off, right? So it's underground. That's also going to be underground, but they don't show it as being underground. The home run for see what. Oh, this has a lot of keynotes, 4, 5, and 6, and a lot of just stuff. Okay, so yeah, 1 and 1 inch PVC underground routed to panel PP1. So always make sure you have the transition from underground to above ground. And here are the panels. Panel PP1. And then that's the drive-through. So yeah, we're going to go underground, and then at some point, because this is from the ground up, you may stay all underground and stub up, or I'm not sure. So that's something that we'd have to look in more detail. Most likely, maybe because they show us that this stubs up into the building where this remains underground because of so that's a lot to look into, because you want to make sure you are close to using the right conduit, because if this has to be underground at some portion, I mean, it's going to be because of the distance from the building. So I'll just assume that this all is going to be PVC conduit until it gets to the building. Then we'll bring it up into over there. All right. And then a lot of details. See where our single line, I might have. Okay, so they have it like this, one line they have it vertically instead of horizontal. It's okay. Same thing. Utility transformer outside the building. Right, so we just have to find the distances in real time, pretty much in real life, from the power plant, and include all of that. So that's weird that they have the single line vertical instead of horizontal, which we're normally used to seeing. Okay, of course, we have all the details, so we have to make sure we know, and this will help you with we're using 1/2 inch conduit for this, so that's going to make a big difference. So we normally use 3/4 inch, right? So when we see these keyed on the probably the power plan, we have to make sure we are using the right conduit when we see those marks on the plan. Okay, where the that's good. I rarely see it like this. where the, of course, the power is 3/4 inch, and the data phone TV 2 inch. That's good. Duplex 2 3/4 inch. Whatever this is. Oh, data phone. Then the floor box. Oh, that's good. 1 2 inch, 1 1 inch, and then a 2 inch. What we got? Okay. Yeah, coming out. Nice. All right. So we can't get confused on the. So what I'm saying is, right, when you on the power plan and you see those things, you see, well, here now you know we're going to need a 2 inch conduit to the ceiling for the data phone, and the whatever HB was on those details. Let's find it. Was it on this one? HB. Of course, I can't find it again. Let's see. Let's go back. Where was it? Yeah, here we go. HB. And sometimes it's not perfect, but should be an HB somewhere. There was one on the plan. Maybe it's just HB. Let's see. I don't see a HB. You know, it's always a mistake. Let's see if we see one here. HB, HB, HB. Oh, look. HBH. No. HB. Oh, we're getting close. HB. Nope. Yeah, it's a mistake. We'll find it. We'll assume it's 1 inch. Because it sure said, oh, let's see what 15 is. See the stupid stuff you got to do? But you have to do it. Hold up button. Oh, I like banks. Because you find out where all the hold up buttons are, which is good if you're estimated, but you're not supposed to, share the secrets. You know what I mean? And so, yeah, we'll find the conduit, floor boxes for the desk, different stuff. So, yeah, they keep us safe when we go to the bank. All right. So, if any questions on this one, let me know. This one won't be shared in the public because it is a bank. It's just for my students. And if you have any questions, email me at education@sfjohnsonconsulting.com. And to make sure you have at least 2 days a week, okay? Private sessions to go over this stuff, all right? All right. Let me know if you have any questions, and I'll see you next time. Hello, guys. This is Stacey with SF Johnson Consulting and Construction Services, and I just wanted to go over this project that we have for electrical, only for our electrical estimating class. We rarely, if at all, do any residential estimates. So I just wanted to make sure we at least did one because, a set of plans is a set of plans, but a lot of times in residential, they try to go on the cheap, and the plans aren't really very good when it comes to electrical because, as we know, that needs to be very detailed, and they don't make them detailed. Okay, so what they typically do on a residential set, they put everything together. Okay, so it's all thrown in there together, and you have to make sense out of everything. Okay. And so the lights are on the same plan, as you can see, with power components. And so it's just a little messier. We don't talk about number 12 wire for the home runs. They use what's called Romolex. Let's see if we can. Oh, we don't have the cost book up. We'll do a separate cost book for that, for the residential, because really, everything in residential is more. So you would charge more for the hourly rate. Your fixtures would cost more. Everything would be more. But the main thing about the set of plans is that, the power components and the lighting components all on the same set in most cases. And again, you just have to take your time and go through everything in detail. And in this case, you can just go room by room or just choose to do all the lights like you would if the set was separate. just do all of the lights, count all of the lights, and what you know to be the lighting controls, and then try to make some sense of the wiring. Okay. Now, as you can see, just like in commercial with the lowercase letter, that means that these two lights are controlled together, and here's F here. So basically, dun dun here as far as your wire. Okay. And this one, C, D, C, E. So that kind of makes it easy. You know where your lights, which switch controls your lights, and so you can use that route, like all the O's. You can use that route. We got an O switch somewhere, three-way switch, so it's gonna control three different things. Okay, so that's not too bad. So once we do the takeoff, once you see my takeoff, you'll see. So all lowercase letters all are all together, and in this case, you can, because it looks like here is one of the rooms where you can cut the lights on here or from this entrance. Okay, so that's how, or probably somewhere else too. So yeah, just all mixed together. And this is the only sheet we get, and that's the exterior elevations. Okay, that's what the house looks like. So at least that's the exterior fixtures. Okay, and two, bad thing is okay, where is here's the panel, but they don't give you anything more specific than that. It's like, well, got to think about in a residence, how does the power come to the house? It's usually overhead, right? Comes through overhead and then down a pole or something. So, yeah, we would have, seeing all that is existing, so we probably don't even have to worry about it. How is that? Oh, it's not from the ground up. It's a renovation. Who knows? But it is we don't care. Oh yeah, it's existing, so that's good. We don't have to worry about that. That's a clue that you don't have to worry about that. All that's existing. All of this is existing. That's existing, and the main thing, the reason why you don't have to worry, is the meter is existing. So we're just doing probably just gutting it. It's probably been gutted, and or they just, when they built the tract homes, they just put the basic stuff in, and now you buy the house and you get it all put in or whatever. Who knows? You customize it the way you want it. Maybe. I don't know. But yeah, so just know with residential, it's not all neat, and there's not even a panel schedule. Okay, so with a lot of this, you'll have to guess in terms of, even if you had to think about breakers, well, you would just, you'd have to go backwards, right? Because every outlet, duplex outlet, is probably for a home is 15 amp breaker. The electrician will know, but typically for every outlet you got a breaker. If it's a GFCI outlet, you have a GFCI breaker. If it's the mechanical equipment, you have a 2-pole, 3-pole, where all the other breakers are 1-pole, right? So you have to go backwards, but it's possible. But like I said, when we do this one together, you will see the takeoff. And in a way it's easier, but in a way it's not. So just know you'll have to look at everything on one sheet. There may be a lot of site work, may not be in this case. It is lots already existing. So if you have any questions, please email me at education@sfjohnsonconsulting.com. Otherwise, I will see you at the next class.
All right, here we are again. We are going to discuss now section views and flashing as it pertains to our roofing estimating plans. And so what we're looking at here on our screen, and let me close it out a little bit. Section views are important because it's going to tell us, give us information once we go to the section view. It's going to give us information about what we don't see here, and it'll become vital for our scope of work. And so in this short presentation, this is just an addition to the live class that we have, so you can go over it again. Anytime you have a section view on a roof plan, it's trying to point you to more detail than the flashing, or somewhere where the wall and the roof meet, or something of that nature. So you want to always make sure you go to the section views. In this set, we have two separate section views, 2 over A 4.1 and 1 over A 4.1. This is at the new roof. There's a little overhang past the roof, and so we want to look at both of these to see what the section view is talking about. And so we see the little representation of the section view. The little circle gives us what picture and what page to go to, and then the leg on there tells us what section of wall we're talking about. So we'll look at both of those to see more detail. 401, 4.1. Okay, so this is image number 1. Let's start there. So at that section view for our roofer, it's really important. So we need to be able to, at that section, which was about 14 feet, 13.8 feet, 1 over A 4.1. So we have 13 feet, let's just say 14 feet. So whatever we see at the section view, that is how many feet we're going to have. So we're going to have 14 feet of this coping, 14 feet of that one. And then this length is 14 feet. Okay, so, but we took care of the area from the plan view when we did the area calculation for how many square feet or how many squares. And so we want to look here to see, we want to account for that. So we have 14 feet of that on that side. So that's why we want to look at the section view. So that's section view 1, and it's only going to show us the part that's vital. So it broke off the wall right here. Okay, so we can't use this to determine the height of the wall right there because it's broken off right there, because it's only going to show us what we need for that section view for the roofer. So that's 1 over A 4.1, and this is 2. So with this section view, we need to understand, the slope and then the coping and the flashing and all of that for that. And so for that section, we had 67 linear feet of that. So that means we have 67 linear feet of that coping. Okay, so at the masonry wall and then at some other portion at the exterior. So we always want to look at the section views last when we're doing our calculations, because now it's going to tell us this was 2 over A 4.1. So we had 67 feet of that. And then we had 13 feet of this. And we always want to make sure our plans are to scale. If it has a measurement on here, we want to scale it. So this scale is 1/4 equals 1. So we just want to, even if there's not a measurement on here, you want to try to find something on here where you can make a measurement. Usually a door is about 3.5 feet if you can find an interior door. And this one is pretty bad. But we're going to go with, oh, look. How many feet did we say? 67. And so this said it was 65.8.5. So that's about, we're close. So we can measure that to tell if these plans are to scale. But see, we didn't even use that. So that's beautiful. All right. So any questions regarding this? Again, this is just used in conjunction with our live class to give you a brush up or help you remember some things and to help you use it for any quizzes and tests that we may have. So if you have any additional problems, please sign up on our online office hours. You can sign up there at our homepage at the lower right at S as in Sam, F as in Frank, Johnson, Consulting.com. This is Stacey, and I will see you at the next class. Okay, thank you for joining for our roofing estimating class. And what we're going to discuss in this portion of the class is the roof plan and what we need to discuss in terms of the takeoff and the measurements that we need to obtain in order for us to produce the estimate. So the roof plan, of course, is where our roof finish is applied. And a couple of things you need to make note of is what type of takeoff software are you going to use. If you're going to use a digitized software, then it'll be relatively very easy to do the takeoff and to get very accurate measurements. So really that's the first thing that you need to decide. So when we're producing a roofing estimate, we need to measure how many squares, right? So how many squares of roof finish do we have? And we need to take particular notice of any of the section views that they show us, because chances are the roof finish is going to go up the wall. So we need to determine how many, the vertical height of that wall. And so that's why they give us the section view that we're looking at right now, 1/A425. So we'll look at that. That's the parapet wall, and it will help us determine how many linear feet high, right, that wall is, because we need to add that to the amount of square feet, or the number of squares for the roof finish, right? So that's the one thing we have to do. So all of the components now that are in the roof. So the first thing we need to do is roof finish. So we'll know how many squares depending on, again, what type of takeoff software you have. If you have a digitized software, to be very easy. If you don't, then you're going to have to do a lot of estimating, maybe from the floor plan, to determine how many linear feet across and wide the roof is. So it really depends, again, on the takeoff software that you have. So you're going to determine how many squares. Then you're going to look at the section views to determine the vertical height of the parapet wall, because you're going to add that. And I think in this case it ends up being another 1,800 square feet, or another 18 squares of roof finish to go up the parapet wall and over the wall. And we'll look at the section view. So that's the first thing you do. Second thing, we're going to look at everything that makes a penetration into the roof, because all of that, those holes are going to need to be flashed. And so what we typically do for the estimate is determine how many linear feet, or the perimeter of each of the mechanical units. That's one thing we do. So that's for the flashing, for the roof curb, so that kind of gives us maybe a little more than what we need. But for each of the pieces of mechanical equipment, we're going to measure how many linear feet. Even for the exhaust fans, even though it's circular, we're going to measure the perimeter. One thing we're also going to do is determine the area of the openings for the mechanical equipment, because we're going to deduct that from the total area of the roof finish. Okay, so two things we do with the mechanical equipment: measure the perimeter for the flashing, and then the area, how much area we're going to deduct for the total area for the finish, because that's something we'll need to know. Not that we're going to deduct that or not order that from the supplier, but we'll know how much of that is going to end up being waste. So on this roof, we have 3 rooftop units. We have a number of exhaust fans we'll have to do the measurements for and determine the area for. And then we have these cooler freezer condensers. So we'll do both area and linear feet of flashing that will go around it. Okay, and this is a walk pad. That's something else we'll have to determine for the roof. Okay, so 1, how many squares? 2, all of the mechanical equipment. First thing we do is for flashing, the perimeter, and then determine the area for everything mechanical. And then when we see the venter roofs, or the pipe penetrations, then we just need to know how many, what's the diameter of each kind, because that flashing, you just need to know the diameter and how many. So I'll know that in this case I have 2 3-inch pipe flashings, because that's how they come. And then the roof latch, I'm going to have to flash around that. So everything that makes a penetration into the roof, we're going to flash around it and determine how many square feet of area it takes up. Roof drains, same thing, flashing, area, and if there are any gutters and downspouts. That's pretty much the last thing we're going to determine, gutters and downspouts. But in this case, there are none, because we have the internal roof drain that all of the water goes down internally through the building, so we don't have exterior gutters. But if we did, then we'd have to measure how many linear feet of the gutter and then count the number of downspouts. And then again, we'd have to go to the section views or the building view, building section view, to determine how many, or the length, the height of that downspout. Okay, so this is just an addition to what you'll be learning in the class, just to back up from what we'll be going over directly in class. But to do a roofing takeoff is just as simple as that. How many squares? And then look at each of the section views, which we did in class in detail, which we, if we haven't had the class yet, we will. Look at each of the section views in detail. That way we determine the vertical height of that wall. Then we add that to the number of squares that we have for the flat finish. Then we measure all of the perimeters of all the mechanical equipment, the area that the mechanical equipment takes up. Are there any pipe penetrations? Count those up, roof latch penetrations, and then that's our takeoff. So we'll be able to use those numbers now, go to the cost book, determine price, put all of that on our Excel spreadsheet to produce our professional roofing estimate. So if you have any questions, remember online office hours, sign up on our homepage, S as in Sam, F as in Frank, johnsonconsulting.com. Lower right, you can sign up for additional time, but this is, again, in addition to our live class. So hopefully you got a little bit more out of it, but please make sure to contact us directly if you have any additional problems with any of the classes. But thanks for joining, and we will see you at the next class. All right, here we are again, another roofing estimating little snippet. And in this one, we're going to review how we format the Excel spreadsheet. Having a professional estimate and a professionally formatted estimate kind of reflects the type of professional that you are. So on all of our estimating, we design specialized spreadsheets. So the contractor can clearly see each line item, how much. We combine it with the material cost, labor cost. We can determine man hours for the project, and it looks very nice. So it really depends on your estimate and how we break it down. We try to reflect everything on the single in a single line that's reflected on the estimate. And so in one of our estimates or one of our sets of plans, I'm going to try to make this a little bigger. Let's see if we can make it bigger. Zooming in a little bit and moving it over. Okay. So let's move it over a little bit. And so what we try to do is, depending on the plan, this is a TPO roofing, gives how many square feet, and then we break it down into how many squares, the cost, and then we break down every line item. So it had 8-inch gutters, 5-inch K gutters, how many linear feet, everything specifically. So for the downspouts, they had 2 different kinds. And so we determined each of the length of the building is 13 feet. We had 6 locations for one of the types. So we calculated, did the math for that and did the math for the other. And then all of the flashing. So it can be very detailed. And this too is for the contractor as well as for the general contractor. Now in this sheet, you can incorporate a material cost markup in your cost portion, because that is an equation. In the material cost portion, that is an equation. So you could say that we have D times F, and we can say times 15% or 25%. That way you can kind of hide your material markup in the equation. But this is how you want to have your estimate look. All of the line items, it's always going to give our location, address, based on plans dated, whatever the date is. Okay, so again, it really depends on the type of plans you have, how detailed you're going to do your estimate. So we have all the flashing, we had 6-inch pipe, 4-inch pipe, the metal coping for the parapet walls. And then something you want to always add is a cost for roof loading. which means an individual cost, to get the material off the ground up to the roof, so cranes and the labor and the cost is so much per square. And so for this roof, all the material that had to go on the roof was 61 squares. And so the cost per square, basically, it determines a cost based on a cost book. Okay, so everything we get from here, minus the labor rate, we try to use the base rate for that trade. Okay, but the cost comes from a very good cost book as far as the material cost. But the most important thing we feel to make a very bare bones tight estimate that's based on something is that your cost unit is taken from a cost book. Cost book, like when you go to the mechanic, they tell you it's an hour for an alternator or whatever. Same thing for construction. They know how long everything takes to install for everything in construction. So you want to always use that cost unit, or what portion of a man hour it takes to perform that scope of work. Okay, so for this estimate, let's just scroll over a little bit. So for the TPO roof, it's saying that it takes 1.05 man hours per square, okay, because it's always per unit. And so the total man hours based on industry standards, not you've been in business 20 years or it's the price you've always charged, whatever. A lot of people are undercutting themselves or charging too much because they're not going by industry standard. So industry says it should take you 1.05 man hours to install 1 square of the TPO roof. And so our professionally formatted Excel spreadsheet is going to tell us or do the calculations for the total man hours, 64.05, which took V times I and calculated the man hours. So this row right here is the total man hours for everything. So then you'll know how long a job is going to take, which is excellent, and you do need to know that. Okay, so professional Excel spreadsheet all the way across. It's going to now help us calculate the total labor, the labor cost, because it'll take our labor rate and take our man hours, how long it's going to take, multiply that together, and it's going to tell us how long or how much labor just for this each line item. So we go all the way down at the end of that. We didn't add any overhead and profit because we're estimators, right? So we let our client determine what they want their overhead and profit. We didn't even add tax. So this is also formatted so it'll only take tax on material cost. Okay, so an Excel spreadsheet, professionally formatted, whether it's roofing, painting, electrical, whatever the trade is, it lets the general contractor know that one thing, everything that's in your scope of work is reflected on here, so they'll probably choose you as opposed to someone with a lump sum. Now, if your problem or your issue is hiding your cost, well, you shouldn't hide your cost. And if you do need to mark it up, as I suggested, you can alter the equation for the total material and add 15, 25% or whatever, and they won't know you've marked it up by 25%. You could do the same thing with your labor, really, if you wanted to. But the whole point is, if you're a professional, you want a professional looking estimate to go to your potential client, right? And let's just see if we can go back. Okay. All right. Trying to get as much of it in there as possible in the recording. Okay, so that's the full thing. Each line item reflected, how much, the unit, so square, linear feet, square feet each, the cost taken from a qualified cost book, a good one, or from your material supplier. But if you bid a lot, it's really makes a lot of sense to have a good updated cost book you can go to at your computer at any time. Total material, and then your labor rate. Always we use the base rate, and then there's a philosophy behind, what labor rate to use, depending on the organization, the type of organization you are. If you're a mom and pop where you do the work yourself, you're going to typically leave that labor rate as is. But if you are a corporation with trucks and folks and fringe benefits and insurance and workers' comp and all of that, then you want that number to reflect all the additional cost. And your overhead or your profit would be probably a whole lot less. And it'd be a mix of your overhead. So it's really a philosophy. And competitive bidding is trial and error. So you kind of mix all that up and you bid a lot. That's why you try to get a estimator that's good and detailed, like we are, that will do a lot of estimates for one price so you can get trial and error. The more you bid, the more you're going to win. So if you bid one, and I mean, there have been times we helped our clients bid one and they won it. I mean, because we're good. But everybody's not like that. So especially if you're learning to do estimating, you're not going to just, unless you're really good, but it's going to take you some time. So having a format you already have set up. Some people set this kind of format up with every type of roof finish, which I think is kind of tacky. If it's not, metal, don't leave it in the form because you just confuse people as if you don't know what you're doing. Some companies make this and leave everything in it and just leave everything zeros that don't apply to the project, but that's lazy. Don't do that. That's tacky and lazy. Just delete the rows. So your estimate will reflect only what's in the scope of work, only what's in the plans. And rule of thumb, please also review the project manual as well as the specifications for things that may not be reflected on the plan. So any questions about formatting any of the scopes of work, we will give you access to any trade professionally formatted this way. Just give us an email, let us know. And if you have any additional work that needs to be done, set up online office hours by filling out the form on the lower right of our homepage. S is in Sam, F is in Frank, johnsonconsulting.com. But thanks for joining, and I will see you at the next class. Hello, this is Stacey Johnson, the owner and operator of SF Johnson Consulting and Construction Services. And in this video discussion, we will be going over the RFIs, or the request for information, the best practices for contractors, and what you should be looking for and how to organize them and navigate through them. So what is a request for information? Well, by definition, the request for information, this refers to a solicitation of details or additional information about an aspect of the project. Usually it's sent by one party when they need critical information to proceed or to make a decision. And the goals of the request for information, actually, what are the common reasons why we send the request for information? Sometimes when we're missing or have incomplete information, of course, and just from personal experience, most of the times the plans are not to detail or they have many, many mistakes. And anytime that you recognize that there is a mistake, definitely send through a request for information. So if there's any missing information or any of the information appears incorrect, I would request, additional information. Common reasons also, the plans of the details may be changed because of a design flaw. And again, this one that you probably would find yourself. They could be changed for material availability or for cost or for some other reason. So there's a variety of reasons for the request for information. Also, updates may be made to the plans based on new or previously unavailable information, and change requested by owners, designers, or contractors. So those are some of the common reasons for requests for information. But from the day-to-day process, it's because something is not clear on the plans. And I also always recommend that if something in the smallest, slightest event seems unclear, request more information. Next, some of the goals for the request for information. Well, the goal for the request is to, or the ideal of it is to formalize the request for information for changes to the plans. So the request actually again formalizes the information so we can change the plans. Documents concerned about the materials or cost estimates. So that's what the goal of the request for information. It documents concerns about materials or cost estimates. It shares information and highlights changes to all key players in the project. And all of this helps the project progress smoothly and limits legal and financial liability for groups that stick to the process using formal requests for information. So it's always, everything definitely needs to be in writing. So that is really the goal. Again, to formalize the request for the information so all the parties receive it. It documents the concerns and it helps to move the project along. And if there are any changes as a result of the request for information, that has to be documented as well. So let's go over some general best practices for the request for information. So anytime you're seeking information, always ask for one thing at a time. So don't make it a multiple request unless they say it's okay to, then that's fine. Use a specialized form or a standardized form and note the time frame in the contract, and that's important. Every contract should have a time frame as to when or how long it will take to get the answers back for the request for information, so make sure you review the contract. Store all requests for information in a centralized database so you'll have them available. Keep a record of delivery of all requests for information. And note the construction schedule or budget may be changed based on the response from the request for information. So again, note that the construction schedule or budget may be changed as a response to the request for information. And create a permanent request for information audit trail so you'll know the days you receive them, the day that you receive back the information, and it keeps everything clear. Read all contract documents because the contract will give you all the guidelines for the handling of all requests for information. And in some cases, you have to consider the cost for the RFIs to all parties involved. Each may cost up to $1,000 to administer. So they try to keep those questions to, or those requests to a minimum. But if it's needed for clarification, you do need to request. Next, how to write a request for information. The best practices for that. And without the guidelines for creating and submitting a new request for information, contractors may be confused on exactly how to create an effective one. So use clean and simple formatting, follow a consistent format, and naming convention, the way you're going to name things. Make sure all abbreviations are used by the same parties, meaning the same thing. Ask one question or request very specific information. Provide complete and accurate context of the situation or question. And provide any documentation, images, video, whenever necessary. Okay, so what happens after the request for information is answered? Typically, if the response answers the question that was answered, then there's a record and there may be a change. So in most cases, it's a delay in the response, and the delay in the response typically is about 25% of the request for information don't get a response. So always make sure you keep up with that and apply or comply with the timelines for the request for information. Tips with dealing with RFIs. Thoroughly read the contract, and the contract will have accurate guidelines on how you deal with them in terms of how much time it's going to take to get a response back and how to properly submit them. Address any request for information as early as possible. Depending on the delivery method for the project, it may be more difficult. Anytime you have a design build type of project, those are the most difficult to deal with requests for information because You receive plans at the time that the project is designed, which means, and a lot of times there's a lot of questions to be answered. So that delivery method, in that case, you usually have a lot of requests for information because a lot of things are missing and a lot of things don't make sense. And so address the request as soon as you think it's necessary or as soon as you are asked information, make sure you answer. In any of the other integrated delivery methods, meaning integrated labor delivery, a lot of times the contractors themselves are directly involved, and so they have more insight on the project. So you have fewer requests for information. And then last but not least, use some kind of document tracking, so you can know when you received it. It's all documented. Everybody has a copy of when everybody received everything and when everything was sent. And last but not least, there's a sample request for information in this presentation, and all of the video discussions go hand in hand with all of the live classes. So this is an addition to the live class for you to review. So review the sample request for information. The first part of any of the request for information is record keeping. Record keeping information for internal needs and uses. And so it's always an automated number. Make sure you know what company you're specifically sending it to, the dates that you send it, and the name of the project and number of the project. And the rest of the document is a detail about the information that you request. So again, this video discussion presentation goes with the live class that you should have attended. And if you have any additional questions, please make sure you sign up for online office hours on our homepage. Again, this is Stacey Johnson, owner and operator of SF Johnson Consulting and Construction Services, and I will see you in the next class.
Hey guys, this is Stacey with SF Johnson Consulting and Construction Services, and this is an episode of For Plumbers Only. And we are going to be reviewing a set of construction documents for the plumbing plan and for the plumber. And we're going to review, this is a project from the ground up. So we're going to review first the utility plan, and that is the plumbing that would take place outside the building. And then once the plumbing gets into the building, then of course we're going to look at the individual plumbing plan. And so this is a very small, same little project, this coffee house that is going to be built from the ground up. And so what we're going to look at really is everything that's related to the plumber's scope of work. So WL, that's the water line. And so what we typically do, right, is we tap into the utility line wherever the public utility water line is running along the street, which they do, right? We tap into it and then we bring it into our new building. And then underground utilities are always, well, it really depends on the state, but we're going to assume PVC and for the underground utilities until it comes into the building. So what we always do first is look for the scale. It's the same scale for 1 inch. It is 10 feet. We've already scaled it. That should be 5 feet, which is correct. And so for the plumber, what we're going to do is just look for all of the plumbing scopes of work, everything related to the plumber. And so we have the water line, and the water line is going to tell us, we're going to look somewhere, it's going to tell us the width of the water line. Okay, 1.5 inch. That's the water line. And that's why I like looking at these when I do the recording. So I don't whip through them, right? I have to take my time. So we have the water line, and then we also have an irrigation line, which is, probably the same PVC. And so what we'll do here is WL, our water line. You know what? Let me go back because it's hard to see when it's not caps. So our water line, and we know we're going to go back and And so you see all the angles, right? We know that we're going to have 45s and 45s, right? Until he gets into the building, water line. Yeah. Let's see, where else? Sanitary sewer, SS. Okay, and it's going to tell us somewhere what the size of that is too. So, oh, it's a 6-inch. So we don't care right now. Well, we always have to go back and check. So we'll see the SS. And it's going to come here. Proposed sanitary sewer. Yep. All the way here. This is some kind of manhole test system or something. It should be noted, though, if it's something that we need to really look at. Like this one. E, that's electrical. So now our utility plan has the electrical, right? But our electrical plan's always going to have its own site electrical. So just in case the site electrical is missing something, we don't really need to look at this one for the electrical. And then I'm going to take this all the way to here. And now this is a 6x4 reducer. Okay, so I have to account for that because that's part of my plumbing scope. Alright, that's that. Now, what is all this is what we want to talk about. So that's that. So basically what it's telling us is a 6x4 reducer. And this is giving them the elevation of the 4 and the 6. Okay, just a little off by what? A tenth of a m, whatever this is. It's based on GPS coordinates. And so that's what all of that is. 6x4y. This is the GPS coordinates. So when they set it, they know exactly. So it'll fit to where we're setting the pipe. Because the pipe is run. Then we have to set it into the component. Right? And sample, proposed sample well. That's our plumbing scope of work. It's 4-inch. Okay, and then we have a grease trap. It's the grease trap. That's also a plumbing scope of work. And it looks like this is a 4-inch, right? Because this is the grease trap. Okay, it has 2, 1 in, 1 out, in and out. And there it's telling me it's 4-inch. So I'm just going to go ahead and I'm going to say the grease trap. So GT 4-inch. So I know this was what was going in and out of the grease trap. And you know all this is underground, right? So I'm just going to go through for waste purposes. Right, so this is a 6x4, so this has got to be the 4. And the other end is the 6. Okay, so plumber, site, work. Let's see, that we always take our time. And then, yeah, we have to count for meters. And, yeah, the size makes a difference. So the irrigation meter is 1 inch, and then the domestic water, domestic, I'm sure, domestic, I don't know. I'm not thinking. I've done a million of these today. So that's, yeah, for the water, and that's for the irrigation. And the irrigation plan is also, I have to look on the landscape plan. It should also show our irrigation on the landscape plan. It may not because it's showing it here and they're trying to get more bang for their buck. So it may not. So as far as the plumbing, okay, grease lines, 4-inch sewer connection, 1.5-inch water line, yeah. So that's once it comes into the building. So now we look at the plumbing plan, right? Because that's once it comes into the building, we transfer to the plumbing plan. So that's the plumbing specs, plumbing notes. So what are we going to be installing? So we know we have the sanitary waste, water, condensate pipe for our HVAC equipment, indirect drains, okay, and then the kitchen equipment, right? Anything related to the plumbing scope of work. So the ice maker, coffee maker, espresso, da 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 da. And of course, we also always need to know the size of the pipe that's coming in and out, and the vent pipe if it applies to all of the equipment, whether it's the kitchen equipment or the plumbing equipment, the lav, which is the term for the sink only in a bathroom. So when we see lav, we know we're talking about the bathroom sink, and the cold water, hot water, waste, vent. Plumber needs to know the sizes of all of that. So we look through, make sure we know the typical symbols. Da 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 da. Da 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 da. Okay, we got the recirculation pump, mixing valves for probably the bathrooms, right? So we just instantaneous water, instantaneous heat. That's what those are for. So we don't have to worry about water heaters for the bathrooms, sinks. The expansion tanks, always got that. So always have to make sure that you are noting all of your plumbing equipment and the sizes of the pipes for water, hot water, cold water, vent, waste. Hold on 1 second. We're going to have a frosty drink for 1 second here. All right. So you have to know all of your equipment because of your rough ends, right? So you're going to have a rough end for every piece of equipment. So if you have 10 labs, you got to have 10 rough ends. Okay, so you got to make sure. Now we go to the plumbing details. We see our circulation, recirc pumps, our backflow preventers. So it's like, oh, I used to take my walks all the time, and then I would see those. I'm like, oh, now I know what those are. You always see those on the outside of buildings, right? These big things, maybe. If it's a place where it's cold weather, they'll have the little green insulation jackets over everything. Construction makes you smart, let me tell you. All right, so that's so the plumber can see what the elevation views pretty much of their plumbing scope of work is supposed to look like. Typical, right? That's a typical reduced pressure black backflow preventer. So meaning they always use the same kind. All right, so let's get to the plans. So we know the difference between the riser on the left and the plan on the right. The riser will give us all of the horizontal measures. So all we got to do is get to it. All right, we have two plans for the plumbing. So we have the sanitary, and then we have the sanitary and the vent plan. Then we have the hot water, cold water plan, and gas, if there is gas in the building. Okay, so this is just the sewer plan and the sanitary riser. What does the riser show us? The vertical measure of the pipe. And so, yeah, we always need the riser. It's always a great set of plans that gives you a good riser, because you can determine because we have to determine our material costs, right? Our material quantities. So yeah, we need to know for plumbing what's the vertical measures as well as the horizontal measure. The plan is giving us all horizontal measures, right? This is all horizontal measures of pipe. But the pipe go up and down, and that's the purpose of the riser. And so every time I see this is a vent, right? Symbol for a vent is the broken line, right? We have broken lines in a lot of cases, so you got to make sure you know the difference. On a plumbing plan, broken line means vent. On a demo plan, broken line means demo. Take it out. Underground on a grading plan, broken line means probably underground utility, and it's grade broken line, underground existing. So you got to know based on your plan what that symbol means. But for plumbing, broken line always means your vent. So this is a 2-inch vent line. And what you'll see on the plan view is the horizontal measure. The riser gives you the vertical measure. That way you can measure up and down and you don't mess up on your material quantities. Every time I see up and down, I say 10 feet, period. Rule of thumb for me, right? Because a building is between floor to floor is pretty much 10 feet. And this is a single story building, so you can give it a vent to roof, right? Vent to roof, you see the vent to roof. That's going to be out the roof, up out of the building. So I give that one an extra 2 or 3 feet. Okay, 3 inch vent to roof plus the little vent to roof thingy. Okay, what else? All right, for what the riser diagram is very good for is to count your uh, equipment. Sometimes it's difficult to count your equipment from your plan. Sometimes it's okay, sometimes it's not. It really depends. So, but you got to recognize that there are some items that are on your sanitary riser that's not on your uh, cold water, hot water riser. The clean water. I call one the dirty water plan, which is this one, sanitary, right? It's all the waste, vent. That's the dirty water. That's the sanitary plan. Okay, you say nothing mentions hot water, cold water going to any of these components, any of this equipment. This is all the sanitary plan. The next plan is the water supply plan. And if there's gas running in the building and it's not a lot of gas, unlike a dental office where you may have a separate plan just for the gas lines and all the different gas that a dentist has, or anybody having a lot of different gas lines, they would probably have a third set of plans for just all of the gas pipe. So this is the second plan, which is the water plan. So all of the pipes go to the same components, different size pipe, 2 dot, 1 dot. 1 dot is cold water, 2 dots hot water. You got to look on the schematic. You got to look on the symbols to make sure. And then here too, we have a riser diagram, which means the up and down vertical measure of the water. Same thing applies. It's going to show you the size, and these are the controls. So everything you see here you have to count for it. Okay, and so every time you see it go up, well, I have 10 feet of 1/2 inch, and water pipe is typically the copper pipe, unless it says otherwise. And sanitary pipe is usually PVC, unless it says otherwise. Sometimes it's cast iron, depending on the state, and if it freezes. I know New York, for some reason, I keep thinking New York, everything has to be cast iron, unless it's some other, like hotels. Once it enters the hotel room that has courtesy sinks and wet bars and stuff like that, then you can use a different kind of plastic for those types of situations. But, okay, so plumbing, that's why plumbers can't mess around and have somebody that does not know how to do a takeoff. Because imagine if you don't consider the vertical measures. My goodness, you're screwed. And the rough-in cost. Rough-in cost, again, is the additional cost for the piping systems that apply to the dirty water plan and clean water plan for the first time that you install that piece of equipment. So when you have new construction, not renovations pretty much, because with a renovation, unless you're installing like an addition that has a brand new plumbing system where a brand new toilet is now introduced into the home or whatever, not just where you took an old one out and put a new one in. There's no rough-in cost associated with that. But when you have a project from the ground up, it's very important that you include the rough-in cost, which is the additional piping systems for both plans the very first time you install that piece of plumbing. So it could be anywhere from, depending, it could be $1,000 for a shower, rough-in cost. So you never want to exclude that, and again, especially for new construction like this is. Okay, so what we would do on this one, we just got to get a good takeoff tool. What's the scale? 3/8 = 1. And we just, you just got to take your time. and like 1/2 inch. Now, I normally don't differentiate cold water, hot water, because I don't have a lot of time in my life for that, because both are the same. But I mean, you might want to go back and do it later, right? So now these little symbols, that indicates that the pipe is going up or down. Okay, uh, if you can see like the white, it typically means the pipe is going up. If it's darkened, that typically means the pipe is going down. But that's why you have good riser diagrams. And then let's see what 3 and 4 is telling us. Shut off valves. Let me see. I didn't look at the symbol. The symbol makes a difference. Oh, and I don't know where I was. Okay, no. Octagons. I gotta look for the octagons. Where's the octagon? Okay, right. 3 and 4. Yeah. Yeah, that's just shut off valves. Has nothing to do with whether it's going up and down. Because you have the awesome riser diagram. So the riser diagram tells us it's going up. And so you can account for that way. All right. And so I guess that's it. I mean, if you're doing this, take off. This is a good project. Civil plan, underground utilities. Once it comes into the building, you switch to the plumbing plan. And the main thing is to understand, don't forget every time you see a pipe going up, make sure you know the size of it. 10 feet, 10 feet of 1 inch, 10 feet of 3/4 inch, 10 feet, right here, 10 feet, 10 feet, 10 feet. Now remember, the horizontal measures are what's on the plan. So you're only looking at the riser diagram for the riser, right? The up and down, the vertical measure. These measures are the horizontal measures that in one way or another are reflected on the plan, in the plan view, right? So if you have any questions for this, please let me know. Please sign up for our class for plumbers only. It's $9.99 a month, and we add new content every week. If you have questions, you can sign on and have a office hour where I will answer any of your questions. If you like the video, please let us know. And we are running some specials. One, October 15th, a $100 Starbucks for all of our nice listeners. And then also free training, a contest for free training as a Thanksgiving present. And for Christmas, we're also giving away every month some free estimating if you have a company that requires estimating. So you can't lose one way or another. But if you have any questions at all, please email me at education@sfjohnsonconsulting.com, and I will talk to you soon. Hello, and thank you for joining me. This is Stacey Johnson, the owner and operator of SF Johnson Consulting and Construction Services. And in today's small class, what we're going to do in a series of small videos, we're going to break down our understanding of project management, and in particular, scope management. What that means, the steps that we take to understand that, the parts of a scope management plan, what those are, how to define those, how to work with those, and steps to make your scope management successful. So in this small recording, we are going to just talk about what our class is all about. Now, in the full class, we go over the definition of project scope management. We go over what the project charter is, because project scope management definitely begins with a project charter. So we define what that is, and it's broken down into its individual pieces. We go over what the statement of work is. We go over the difference between the statement of work and the scope of work, which is much different. We go over scope creep. And there are 6 steps in making a scope management plan. We go into those in detail and break down with a very good breakdown of it. The thing about the scope management, or whether it's scope management, schedule management, integration management, it's just a series of steps that you take in order to make sure that all of the processes, first, all the processes you need are there. And then once you've determined what processes you need to complete a full project, then you go over certain steps in making sure you plan those processes, you control the processes, and then at the end you're able to close it out and evaluate the process. And so when we talk about scope management, that's the bigger picture for the whole project. So when we talk about a project, it's a thing. And so the scope is, what does it take to make the thing successful? From the planning stage all the way through to closing. See, so as contractors, they always think of scope in terms of scope of work. But when we talk about scope management, that's such a broader concept, okay? And that's the first thing you have to think about. It's a much broader concept, okay? When we talk about scope management, we are talking about the planning stages. We're talking about planning. There's 3 processes: planning, controlling, and closing. And so in the planning stage, and let's move it a little forward. Okay, so project scope management. Okay, project scope management includes 3 processes. Planning, which is defining the project. Okay, so defining the project is a lot of things. Okay, the project is defined and the work or the process is needed, okay, to deliver the project is determined. Okay, so that's what we mean by planning. We have to say, what do we need? What processes do we need in order to get this project going? Second is the controlling aspect of it. Okay, this involves we must track everything. We manage it, we track it, we monitor it. Okay, the activities involved in the project. So this would include things like, change orders, right? That's a form of tracking to make sure that anything that is changed, we got a way to review it, approve it, and, change what we need to do. Because anytime there's a change order, right, it's either going to subtract time to the full project that we've already determined ahead of time, or it's going to add time to it. So when we start changing stuff, then that's what causes our creep, right? Because everything starts to change, we start to slow down. Okay, so that's the controlling part of the management plan. And then last but not least, the third aspect is the closing it out. Okay, so this is the last part of the project. And this would include, we're going to audit deliverables, right? To make sure that what we planned in the beginning is what we ended up with. Okay, so, again, we're going to cover all of these things. What we're talking about in this small video, and all of the videos are going to be posted on the website, so that way you don't have to review the whole thing in order to review each individual part, because you're tested on everything. Okay, so right now we're just talking about what is scope management. And keep in mind, again, when we're contractors, we always think about scope of work. That is a tiny portion of what we're talking about. Okay, scope management is the planning, controlling, and closing process of the full thing, from, again, very first stages, the planning stage, all the way to closing out the project, and all of the processes that are needed to make that happen. Okay, so again, we're going to be talking about the full project, excuse me, in full, and this is just maybe part 1 of 6. But again, this is Stacey Johnson, and if you are a part of the class, please make sure to review every video as well as all the documentation on the study sheet. And thank you for joining, and we will meet you at the next class, where we will talk about the project charter, which is the very first step in creating a scope management plan. Thanks a lot, and I'll see you in the next class. Hey guys, thanks for joining me. This is Stacey with SF Johnson Consulting and Construction Services, and this is a episode for finishers only. And what we're going to be talking about in this video are the finishes, FRP. We're going to be determining some wall base lengths, cold base, and then it looks like we're going to seal concrete, chip XPL system, probably some kind of coating as well. And remember, I always look at these for the first time in detail when I record them, so I don't rush through them. You know, when you're so familiar with something, you're going to rush through it, but that's not the purpose of the video. So we're not rushing. And so we're going to paint some stuff too. And the good thing about this, if like I will be doing, if I'm doing the takeoff for the finishes, then I'm also doing the takeoff really for construction cleaning, which is good because I have a client where I need the construction cleaning takeoff totals because, you know, for the finishes, they put them in, everything's still dusty and everything. So the final or construction cleaning has to go through and clean basically the same surfaces, the same linear feet, you know, and that's how that's priced too. It's like how many square feet of flooring are you mopping, or mirrors are you cleaning, or storefront glass glazing are you cleaning? You know, you multiply that by 2, you know. So when you do the takeoff for the finishes, it kind of helps you out because you're doing the takeoff for the final cleaning too. And so this is the plan view for the floor finish plan. And you know, what we'll need is the plan view for, you know, to get our linear measurements, right? But we need to know how many square feet of FRP, right? We need the height of the walls. And so we'll typically look at the interior elevations, or if the heights are all 9 feet or whatever, we'll look at that. Or worst case scenario, we can look at the reflective ceiling plan, because let's go to that real quick. Because the reflecting ceiling plan is the purpose is to give us the ceiling height. And so, you know, worst case scenario, we can assume that the height of the finish on the wall is 6 inches above the ceiling height. Worst case scenario, if you don't have interior elevations, because you do want to get as close measurements for your wall paint. You know, there may be a portion of the wall, like in bathrooms, where it's tile 7 feet and then painting the remaining 2.5 feet or whatever. So you always want to have interior elevations, and this one does. So here's the interior elevations. And so, yeah, it's a 10-foot height, so we guessed that pretty well. And so what's this? And what is that? I don't know what that is. And so sometimes the interior elevations aren't the best. It says open beyond. Open beyond. I don't know what this is. But, okay. And so we can take our FRP totals, really, and we just do the whole wall, and we have to paint the doors. And so we know the door square footage is this times 2, and then we also have to paint the frames, and so you have to measure the frames times 2. So, and then the wall base one here, and I don't know what 3 is. Let's see what 3 is. Floor sinks. Okay, we don't have to worry about that. So that's in the floor. They're trying to show that. That's okay. That's not cute. All right, and then 8 conduit. Okay. So for our FRP, everything has to be to scale, and I know all my plans are to scale, so I'm not really worrying about checking it. But you are supposed to check if you have because this is 10 feet, right? So let's get our dimension tool, like our ruler, from hash mark right in the center to hash mark in the center. Yep, 10 feet. So I know my plans are to scale. And so now I can just use the interior elevations. FRP, FRP. But we won't include the door, which we actually could, but we're not. And see now, this is the wall base. I like to be accurate, so I'm not going to include that. And we won't include the door. We'll give it a little extra for that. And so that wall is 146 square feet. So we do that for the whole thing. And then, of course, we have our cost book. Let's see how much FRP is. All right. That's ugly. Let's take my name off of there. That's ugly. Take the name off? Okay. Where is our search? Where did it go? Let's bring that up here. FRP paneling. So, here we go. Here we go. So, that's the typical almond or white $1.13 a square foot. Let's get that off of there. FRP wall and ceiling paneling, fiberglass reinforced plastic, textured 0.09 of an inch thick, class C, flame spread. Oh, that's the flame spread is the class C. So we'd have to look if that is what they want for our project. It may be class A. If it's kitchen, it may be a higher rating. Who knows? But this is what the cost book is telling us the price is for this one. Spread 24-inch by 48 panels, includes fasteners, adhesives, and a 5% waste. So for that is what's included in the $1.13. So, and that's the man hour total, meaning that's how much of a man hour it takes to install one unit. One unit's 1 square foot. So we do all. If we have 1,000, then we say it takes what 1, 2, 3 zeros, right? So we move 3 zeros to the right, it would take 32 hours, right? 32 man hours. So what, you would have a couple folks doing it, so it would take you a day. You knock it out in less than a day, right? Okay, so let's go back. Excuse me. I always got to cough. It's like, why can't you cough before you start recording, ding dong? I can't, because I'm always recording. All right, so we do that for that. And then, these are windows, right? That represents windows. And so we might have to paint the window frame. So we want to designate window frames from door frames. Okay, and then the wall base, I'm going to go back to the floor finish plan for the wall base, right? And then the doors, I just know how many doors. And then the wall base, let me make sure this is to scale. And again, when we do this for the finishes, we're basically doing it for the final cleaning too, because we have to wipe down, clean down all this stuff. So now we know all of the FRP is 10 feet. So I can measure, let's just do it this way. FRP. It's all FRP. But we're not, we can go through the door and then we can delete however many square feet the door is, right? Because we know it's all FRP. And then if the wall bases are different, no, we'll do that separately because the wall base doesn't go through here, right? Wall base doesn't go through the door. But see, you got to make sure, too, that you measure both sides, right? Measure both sides of that door for the FRP. And then it's all FRP. FRP. Da, 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 da. And we're just going to do this, probably corner guards that go over there, but that's okay. We want to make sure. So let's go from here and back all the way up, and then we'll look at the section view if we wanted to. It's typical, whatever, the 2 over A 5.2. Let's go look at that. 2 over A 5.2, because you always want to look at your stuff. 5.2, what page are we on? 5.2. 5.2. All right. So It's just telling us about, I don't know which one I looked at. Okay. Conduit, floor base, FRP. And we got this here. And then we have a sealant. So we know how our, at our floor, what it's supposed to look like. And then at the ceiling, of course, yeah, we typically go 6 inches above. All right. So yeah, that's good for that. And floor finish plan. So I need to do, I mean, they even have FRP in the bathroom. So altogether we have 146 linear feet. So times 10, because we know it's pretty much all 10 feet. 1,460 square feet of FRP. And then basically, let's see, wall base 1. Is it all wall base 1? Because we could really subtract this length. Is it all wall base 1? Yeah. So we know wall base 1 is the same length minus, oops, look, boop, boop. Da-da-da. Almost forgot that. Let's add this. And then we really know that wall base 1 is the same length as the FRP minus 2 times the door, right? And that door. So let's just call this deduct WB1. And then we good. We saved us some time. So we'll go from like here to here, do actual lengths from here to here, and then here to here. And everything else is wall base 1. Probably just do also at windows. We'll just give it the benefit of the doubt. Just say on the estimate we've included wall base 1 at the windows. All right, so we deduct basically 9.5 feet. So 10 feet we'll deduct. And then we know wall base 1. And then the doors are painted. We know we have 1, 2, and we just look at the door schedule really. And we know the amount of that caulking in between is the same length as the wall base. Pretty simple. Oh, and then the sealed concrete, because the whole floor is sealed concrete. Let's see. SC1. I think that's everything. Right? SC1. Oh, yeah. SC1. SC1. So that'll be real easy. Yeah, everything's SC1. So we just say concrete area or floor. I say floor because we do a lot of takeoffs. It's like concrete. What is this? The foundation? What are you talking about? Cover. That way we really know we're not talking about the foundation. But what I will do is I'm just going to include all the wall. Well, no, I won't. Because it's always fun to do this. We won't include the walls, right? Ooh, let's see if it'll not mess me up. Watch. Here we go. Sometimes it does its own thing. Let's go back. Tighten it up a little bit. Watch my perfect wall. Bam. New section, and let's take care of that old bathroom. Or is the bathroom's concrete too? They're not really spending a lot here. There we go, bam. All right, so we know our area, which is our area of the ceiling. If it's all acoustical. Let's look at our reflective ceiling, because that's a finish too, right? That's a finish. We need to know our reflective ceiling plan from our, if we have any gypsum board, which we don't, so our 2x4 ACT, is the same as our floor, pretty much. Our concrete floor, which is 604 square feet. So that's the same square footage. You might give or take for the lights and for the supply grills and the return grills. We don't care about that because they still have to adjust it. So anytime it's less than 2,500 square feet, they charge a little more anyway because of all of these that have to be adjusted for the size of the building. So, same thing. All right, so let me see. I think we got everything for our four finishes only. Our paint, right? Let's go to where are we? Let's go to the interior elevation. Ta-da. All right, so we call this door area, and then times 2, right? Because we have to do both sides of the door. So, I mean, we could just, because we have 2 doors, we don't have to do it, but I like to show the kids. All right. New section. Where's that other door at? Here it is. Here's my friend, the door. All right. All right. And they say I shouldn't go longer than 10 minutes on these things because you guys get bored. But this is, you can't get bored when you're learning. All right, kids? All right. So let me stop that. And then our door frame. So we're just going to say times 4, right? Because 1 on the other side is 2. This one, 3, 4. So, I mean, we already know it's the height times 2 plus like 3 feet, whatever the width of the door. But let's just measure it. And we'll call it door frame times 4. Remember that. But then if we have like a zillion, then we'll have a different procedure to do this. We only have 2. Okay, that's close enough. So that's what? 17 feet usually. All right, 16.9 feet. So 17 times 4, because you price when you paint, right? The labor to paint something that's per linear foot, because that's how you paint that. It's a different labor rate than when we're painting something that's obviously a larger area. It takes more precision, so the labor rate on painting anything that's linear like that is more. So we always want to separate when we paint the wall paint, if we were painting the walls, we're not, from the ceiling paint, because ceilings you have to go up higher, so of course the labor is going to be more for that. And for linear, that's a higher labor rate. So I think we got everything covered for this one. So if you have any questions at all, please email me at education@sfjohnsonconsulting.com. Please give me your comments below and subscribe to enter. I like giving away stuff. I also have a nonprofit, so giving's in my bones. We every month starting the 15th of October, we're going to give away a $100 gift certificate for Starbucks. I'm going to be giving away some free construction training of your choice to all of our subscribers by entering, and if you so choose, or somebody you know, and for companies that listen, we will be giving away $1,000 in free estimating credits for any of the trades that you see us teaching about. So thanks a lot for joining, and I will see you next time. Hey guys, this is Stacey with SF Johnson Consulting and Construction Services, and I wanted to invite you to our SF Johnson Consulting Live presentation that we will have hopefully on our YouTube page, but definitely free and live on our website, sfjohnsonconsulting.com. And this week, this will be for Mondays. This is all of the free presentations are on Mondays. And this Monday, between the hours of 10 a.m. and 11:30 a.m. Pacific time, and again at 2 to 3 p.m. Pacific time, we will be reviewing and going over the full takeoff and some estimating tips for our new project, which is actually uh, the shell for a Chipotle. So this is the shell, ground up shell. We're not, completely doing all of the interior finishes, but it is just the basic shell where we'll be going over some site work, utility plan, site demo. We have the striping plan, a grading plan, an erosion plan, the utility plan. We're also going to go over the basic floor plan because it is a shell, right? We're only going to do the exterior walls, the doors, the roof, and the basics for the shell. We're going to go over the roof plan and looking at the exterior elevations. We will also actually do the takeoff for the final cleaning because we're actually going to be bidding on quite a few of the scopes of work. And if you are interested in bidding with us, please sign up at our website. Again, sfjohnsonconsulting.com. We do all your estimates for you. And we are at this point trying to build a winning traveling team for 2023. And we would love for you to join us. So we have to review all the section views, the building section views. So we will be able to determine the heights of the walls and the studs for the takeoff. We're going to do a full, complete evaluation of the foundation. Where is the foundation? The foundation, a complete review of that, shear walls, and last but not least, we're going to do the MEPs because this is the shell, right? All we're going to be doing is all of the electrical, mechanical, and plumbing that's coming into the building. And again, there'll be another set of plans, right, for the interior finishes and all of that. But at this point, sometimes they ask you to bid for just the shell. So it's just the foundation, all of the MEPs that come into the building, the foundation. I already said that. All of the load-bearing walls and all of that stuff. So, and a little bit of electrical, not much electrical, right? Because we're just, again, it's the building shell, which would be all the emergency lights and all the panel and all of the parking lot lights, it looks like, or just the stub ups, not even installing the lights. Okay, so join us again on Monday. That would be October tomorrow, which is October the 3rd. Yes, October the 3rd. And again, our live performances are from 10 a.m. to 11:30 a.m. Pacific time. And then what we don't finish, then we will finish from 2 to 3 Pacific time. So again, join us, please. And if you have any questions at all about anything we present, please email me at education@sfjohnsonconsulting.com. Otherwise, I will see you on Monday. All right. So we are going to first complete the floor plan because we are going to complete a cleaning estimate for a client. And also, we are bidding on this ourselves, so we are always looking for all of the trades, framing, painting, drywall, in this case, concrete, because this is from the ground up, and we'll also be reviewing the foundation. And so let me make sure we have everything set before we start. And the first thing we always want to look at is the scale and make sure we have the scale correct. And so what we're going to do right now, before we do the foundation, actually, because this is pretty much easier to do, we're going to look at all of the call-outs, detailed call-outs for how it's going to probably, who knows what it's going to show us, because I don't try to look at it too much in advance before we do the estimates. And so we're going to first see, we have wall here, but a lot of the building is a storefront. And so what I'm going to do is I'm going to separate the storefront walls from the main walls. I know that I'm not going to deduct an opening because if this is the storefront walls, which we will look at the exterior elevations to see how that's built and everything, I'm going to separate these walls, the exterior walls, load-bearing walls, from our storefront window walls because the wall portion is going to be totally different than if there are no openings, or if it's not the storefront. And so we've already, so I'm going to call it storefront. As soon as it catches up, I think it's doing too much. Oh, come on, computer. What are you doing? There we go. Storefront. Storefront walls. Because those, in terms of construction now, it's going to be a lot different than the other walls. And then I am going to go through the door there. Because too, we're going to do this for final cleaning, and the final cleaning is going to really have to clean both sides of the windows. And so that's good for that too. Looks like these are also some kind of window. It's a drive-through most likely. All right, so let's just finish the exterior walls. Am I spelling right? I really don't care half the time if I'm spelling right. Because I know what I'm doing. All right, so we're going to go through that door. We're going to go through all the doors because in terms of the wall framing, it's waste, and usually if it's less than 16 feet, we go through it anyway. And so we'll go there. So those are our walls. Now, what we're going to do first, let's see how our walls are built. So 4 over A 4.1 is what we're going to look at. Image number 4, page A 401. 401. Image number 1. So that's image number 2. Are we on page 401? Yeah. Okay. So all of the walls are pretty much this height to the roof joist, and this is the exterior. And we'll look at what the keynotes tell us. 2, 5, and 7. 2. Frame wall with that insulation typical, so all the way around. 5. EFIS system typical, and 7. Pre-finished metal coping at, so that's for our roofer. We've got that there. Parapet. So we have exterior walls that are, let's scale that, 1/4. This is very easy because it's a shell, so it's not really much that we need to do. And so the walls to the roof joist, that's what I want to know. Wall to roof, because our framer needs to know how many square feet. 14.9. So we're going to have to say 15. We'll just give it 15 feet for the exterior walls because they are different at different heights because it kind of goes up. So let's just do that one too. I'm going to use a dimension tool for that one. So just to the roof joist. 15 feet. Okay, so, and then the parapet wall is an additional, because we'll need that for 6.5 feet. Okay, so that's pretty easy. That's easy. All right, so go pretty easy. That's easy. All right, so going back here, we know that we have exterior walls of 145 feet times our 15 feet, we say. So that's how many square foot of framing, and we will have a professional estimate created from this takeoff. Okay, and so the framer is going to do that, and let's see. I mean, we need some, let's see. We got to have some more details as far as the walls. So that's the storefront area, all of that window. And so final cleaning, we know we're going to clean both sides of that. So that's easy. And then there's some other drive-through window. And so if I'm going to do windows real quick, which I probably will do real quick, let's do the scale, 1/4. Because we need to tell our windows, our final cleaner, how many square feet of window they're going to be cleaning. So this appears to be window. And if it's not, it's okay. We'll deduct it. And you know what? We're going to go through all of that is going to be window. Because we got to clean it off anyway. And this is our exterior elevations. And so, that appears to be window. We got to clean the door anyway. And all of this is times 2. And then we get this little window. Because we got to clean both sides. And so we'll make sure we have 4, like 2 that's 3 elevations. Make sure we have all the exterior elevations. So we can make sure we have all as many square feet of window. And you know what? We're going to include that whole thing because we have to wipe all that off when we do our final cleaning. Okay, so let's see if we have any other. One more page that has just the, no, that's the building sections. So that's okay. So, okay. And so we have that. We have the framing, roof plan. We're going, parapet cap. So now we're the roofer, and we need to know, we need a couple of things for the roofer. First, we got to scale it, and we have to tell the roofer how many total square feet of, I think it's TPO roofing, because we are going to bid this. So if you would like to bid this with us, we would love to have you join us. And we do all your estimates too. When you work with us, we do all your estimates. And we always win. Why? Because we are the best. And then what we do too. So we have the total square feet. But what we want to also do, remember this is a share. And so we're going to deduct roof openings because, our roofer asked that we always deduct the openings from our square foot total of roofing material. And so we're going to make sure we do this. Isn't this exciting? Isn't it so fun? All right. These people in our country, they need to just do estimates and be happy. Oh, let's go over some more. All right, so the purpose of that is, we're a little off, but that's okay. And so roofer, and so we just finished what the framer needs real quick, right? And hood below, this is a big one. And what we also need is, because we'll have to flash the same openings, we really need to know how many linear feet, but because my tool I did point by point for each of these squares. See how that square is 28 linear feet? That square is, same thing, should be, right? Same 28 linear feet, so I don't have to do the linear feet. I could just do that. 7, I'll round that up to 8 linear feet. 9, 8.5 linear feet. 12 linear feet. 43, so that's the flashing. See how great that is? And then let's see what number 9 is. Solar ready. All right, so I'm just going to do this area just in case they need it for something special. Just in case I'm asked to price a solar panel or solar something. Solar is weird how they price it, so I'm just going to do that just for the heck of it. So I'll know. Just in case they need it. Oh, look. Forgot that. Look at that. Openings. Deduct. So let's go here. Oh, wait. I got to remember I didn't go all the way to the top. So linear is going to be off. Or look. Bam. Yep. Let's start over. I don't know if I did that on the other one, but you see the point. Okay. Oh, I did that again. Okay, so we know what Stacey should have done. All right, and another thing we need to get. We know we've got roof drains. So we're going to need the roof drain. We're going to need the flashing for the roof drain. roof drain and overflow drain. And then we're going to need the perimeter for the parapet cap and flashing. Anywhere that window or wall meets roof, we need to consider we need some flashing. So if I would have done my roof like I did my openings, I would know how many linear feet this is, and I would not have to do this, but I'm doing it anyway. All right. So what we don't know really yet is about our walls. We did the measurements, but we got building sections. Okay, so we're going to go here, right? Because 3 over A 413 is probably going to tell me the makeup of my wall. 3, 4, 13. 3. Yeah, see, here are all of our walls. So for our framer, what are we doing here? Okay, that's the foundation. So we'll do all of that from foundation. Of carpentry, that's a 6-inch bottom plate, or 2 of them. Well, you can always measure and make sure. That might be a little. Oh, that's about the same. Is that the same? We'll look on the foundation, but we know that storefront, height, 2 wood stud walls with that insulation, vapor barrier on inside face of wall. Refer to structural for stud spacing. Structural for stud spacing? Okay. EFA system over waterproofing over exterior sheathing. Alright, so we got that. We have all the measurements to do all of that. And then all of the window, we have to measure maybe the length of the windows for our bottom plates, for our window top plates, for our wall, whatever you want to call it. And then this is on our structural, any headers, everything above the window is the structural member, it's the header. Below the window is from the framing, kind of rule of thumb, but kind of not. And we know that the insulation is going to go only to the top of the building. We don't need to insulate the parapet wall unless it was a second floor, right? We only insulate where the humans are. Alright, so, and it's interesting right here. Whatever that is, that's a lot of little things. So we could look at, right? Call out 5 over A 421. Let's do that, because when we do the actual takeoff, we need all of this and be able to determine how many linear feet. So how do we go from the takeoff, right? This is just a section view, but when we're at the floor plan, oh my God, I'm so glad. I almost thought I didn't turn the mic off. Thank you. All right, so when we're at the floor plan, right? So we have to measure if we have a detail call out, say for instance, like this one. Well, this is referencing because we know where the section view is. We know it's only in reference to this opening in the door. We know that this is only referencing this because it is within the call out. And so if whatever I see at 2 over a 413 to do the takeoff, well, I'm going to measure how many linear feet from here to here. Let's say 6.5 feet. And so I'm going to go to 2 over 413. Next one, 2 over 413. So if I go to 2 over, where is it? Right here. And so I know that that was 6.5 feet. That section view was 6.5 feet. And so I know that I need 6.5 feet of this, 6.5 feet of whatever that is, 6.5 feet of this one, this one, this one, this one, and whatever this is. 6.5 feet times the length of that is what I need, because every section view, right, is broken down. And so when we look at the exterior walls are all 4 over A 401. So whatever I see at 4 over a 401. I mean, pretty much all of the exterior walls are this construction. So I go to 4 over a 401. I go to 4 over a 401. 401. 4, right? Where is it? It's up here. Okay, I go to 4 over a 401, but then again, I'm the framer. This doesn't tell me anything about my framing. So I'm like, da, 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 da. Oh, okay, here we go. Because I'm the framer, it's got to tell me more specifically about my framing. I can use this like I did before to determine how many linear feet. This doesn't tell me the wall framing, the drywall, the insulation. But if I go to the call out, if I go to 1 over a 413, now I get more specifics. 1. Now I know how my wall is built because there's going to be some arrows hopefully pointing to my wall. And I know all my exterior walls are the same. So if my arrow's not pointing here, then my arrow's going to be pointing somewhere else, and I'll know it's the same wall. What's the da-da-da-da-da? And it says, oh yeah, look at the structural for the type. All right, so we go to the structural. That's the roof framing. Okay, roof framing is structural because the roof is a structural member. So the roof framing, not the roof finish, is structural. And so we'll look at this. Oh, we'll see what this is when we get there. It might be this afternoon's presentation. Girder truss. Let's see what we got. Oh, prefabricated truss by others is this. Now that's what I like. Is when I have a set of plans that show these things. Okay, so it only applies to structural framing. And so when you have these little things, that circle and that arrow, that tells the framer that only within here, only this part is whatever this is. So now we have it again, right? From this all the way to here, and then again to here. It looks like it's continued because it's not giving us any description. Yeah, so it's all the way through. So it goes from here to here, and then it connects here, all the way through here, and then again, just like that end, it tells you a different type of truss. And so what that means is from here to here, where one arrow begins and the other arrow ends, you got to look and find where they're trying to tell you about the trusses. And that would be, maybe they're breaking it up. No, yeah, they're breaking it up. We got arrows. There we do. Okay, so here we go. Let's start again. Because like I said, never look at this until I look at this with you. All right, so from arrow to arrow, we have this type of truss. 1 or 2 ply prefab trusses by others at the 32s. Okay? And then we go from, we have a new arrow, this arrow, to this arrow, and we look for the description. There we go. 1 or 2 ply prefab. Then we got another set of arrows from here to here, and we look for the description. So when it comes to trusses, if they're putting them every 32 inches, then if you want to know how many you need, then you have to go 32 inch, or wait, feet? No, heck no. What's wrong with me? 32 inch, 1. 32 inch, another one. 32 inch, another one. All the way through. Okay? So if you want to know how many, because you can't, I mean, I guess you can. I guess you can. You could do it just like you do. Oh, you could do it the same way. How many linear feet? Turn it into inches, divide by Either way, the first way is so much more nerdy and special. All right. So we always gonna look for our headers, right? So this is a metal header, H hollow structural steel, and the dimensions. Okay, and usually with fabricated metals, the last digit on like W 84 by 115. The 115 tells you how many pounds per linear foot that can hold. And so if you know how many linear feet of that type of truss, then you know you can determine how many pounds, and they're determined price by the pound. So I rarely get those these days. All right, so yeah, we were looking here to see what kind of framing we got there. All right, here we go. Trusses, hold down, number twos, wall, number six. Oh, look at that. Tells you how many linear feet. That's nice. All right, so let's see. Our walls are, we already know they're 6-inch walls. And we know that they're wood framing, so it's not really difficult to determine what we got here. All right, so our posts, right, and our columns are hollow structural steel. Then we look at 9 over S200 to see the makeup, and that's prefabricated, I'm sure. No, we got a couple of wood posts. That's nice. Okay, and so we do our framing takeoff for the structural framing. Our posts, what, are 15, 16 foot? So we just assume they're 16-foot posts with all this extra stuff to hold them down, embed them within the concrete. Slab on grade, we'll do that. That's easy. 6-inch concrete foundation wall with number 4s at the 16ths vertical and horizontal. That's nice. So number 4 goes this way and that way, so you do it the same way. The number 4s are what, at the 16? Yeah, every 16 inches. So how many linear feet multiplied by inches, right? So you change that into locations, multiple times however many locations, and then the length. That's for the ones that go in that direction. And then you do the same thing for the ones that go in that direction. For the how many linear feet of how many linear feet of number 4. All right. What else? Because our whole purpose is to do this for the final cleaner. So they have to clean, wash down the walls. They're going to have to probably polish the slab on grade, or wipe it down, or buff it, or whatever. So we're going to measure how many square feet for our concrete person too of slab on grade. And we'll look at the foundation section views for the footer, the stem wall, all that stuff. All right, but for now, we're going to say slab on grade. And we know it's 4 inches. So it's the whole kit and caboodle. How old are you? Old enough to know all my construction principles. All right. And see, now I'm going to go all the way to the top, so I'll know my footer minus that piece because I didn't go up in there. I have 211 linear feet all the way around, plus what is this linear feet? How do we read this, boys and girls? From hash mark, there is one, not one. From here to there, the number in between is an extra 9 feet, 4.5 inches. So that's our foundation. Almost 23, right? 100 square feet. All right, so let's get rid of that real quick. Cut off the light bulb. All right, so if I'm doing, so my final cleaner's got to buff out 2,300 square feet of her concrete. And let's go look at some foundation section views. That's our main wall there, structural, external wall there, and we know any walls that are connected to the footer, the concrete footer is going to be a structural wall. So that is a structural wall if we have framing connected to it and bolted into it. And then we could look at section view 10 over S201 for the configuration of all of that. So you got a lot of section views here and a lot of call outs. So the concrete person knows basically how to form the concrete and more importantly, how to place the reinforcing steel. Okay, so let's look at 7 and 6 over S200. S200, 7 and 6. Oh, look at the beautiful stem wall there. You've got. So per plan, I think our plan told us. I don't know. Per plan. It told us. Okay, so we've got from here. Oh, it's a 6-inch, I think. So this would be a foot stem wall. So I know my stem wall is a foot by 412. Right? So I know how many square feet of concrete, but then concrete is in cubic yards, right? So how do I do that? Well, I always turn cubic feet into cubic yards by dividing by 27. Remember, with concrete, you have 3 dimensions. You have the length of the wall, which was 411 feet. You have the width of whatever it is, 1 foot, 2, 6 inches, whatever. And then you have the height, which is 6 inches. So that's 3. Multiply those 3 together, then you shall have cubic feet. And then divide that by 27. That gives you cubic yards. So now, if I know my my plate, I got a single bottom plate, stud wall, and sheathing per plan. We've got some shear walls, right? We got, when they talk about that, we've got also the waterproofing, okay, exterior footing, all the different section views for all the different concrete configurations. That's a stem wall at stud wall with 12-inch foundation wall. That's nice. Reinforcement per plan. I don't know what plan they're talking about because this is the plan. So, I don't know. We don't want to spend a lot on our stuff here. We just do that and let the pros figure it out. All right, shear walls. Here we've got our steel. I can't even think. I just said it. Our structural steel headers, posts, beams, plans. So we don't have a construction defect. Okay, so this is typical base plate, concrete wall connection, HSS column. Okay, so 2 times with hex nuts, just 2. It don't say per side. Okay. All right, so we don't mess up and the thing don't fall, right? It don't fall. There we go. Isn't that pretty? All right, so you know what you're doing when you can look at your detail views. You got to be able to get down to your detail views and do the math. Okay? Very, very important. Stem wall, or continuous footer, stem wall. Then we got the hooks here, and then we also have individuals running the whole perimeter, right? This is a section view, so we cut it, and then we broke it apart, and this is what the interior construction. So this is what we use for our detailed material quantities. You got to be able to look at the detail views and determine your material quantity. So I've done that. So my foundation, I want to do my foundation. See, those are my 2x6s. And then, see, I have different continuous footers, see. So when you do your takeoff, let's just do that. Did we already? Yeah, we did, because we did. See, when you do your continuous footer, you want to make sure you break up your sections, because you want to go back and look at each of these, because what? The continuous footer is going to be different. The stem wall is going to be different, thicker, smaller, whatever. And then what we got here? Look at that. So we have a 4-inch slab on grade outside the building with da-da-da-da-da-da-da-da. Okay. And here too. So that's the additional concrete work. And then okay, so let's look at that. 9 over S 201. 201. 9. All right. Okay, so yeah, that's slab on grade. So what do we do in this case? So you have this is almost like, this is kind of different because it's not like this. It's not as clear when you want to determine how many square foot, when you want to do actual, like how much. So with me, here's real clear. This is about, 6 inches. This goes from 6 inches to 12 inches. I'm going with 12 inches. Sorry, I'm just going with 12 inches stem wall, because I'd rather have more than not enough, right? So to do the takeoff for this, you have this stem wall, this continuous footer, this stem wall, and then the flat portion slab on grade. And then, yeah, you're going to do dowels to match the slab reinforcement at the 24s. I mean, 24s, that's 2 feet. This thing isn't even 2 feet long, so it's probably at both ends of it. This one right here at the 24. And this is a continuous, right? So it goes all the way through the slab. And these two go all the way through the slab. And so however long the slab is, right? Let's go back. Where were we? I don't know. So yeah, so however long the slab is, that's how long that continuous is, which is this. I like that. So when you can go from plan view to section view, and the section view will take you to detail view. You'll make sure you have a good thing. All right, so we're going to take a break and see what else we got. Remember, this is a shell, so we don't have any. This is all the MP we got. Mechanical plumbing plan. We just have stuff when it's a shell. We only have things that are coming into the building. So even the electrical plan, right? Just coming into the building. No lights, no nothing. Just the panel even. I don't even see that we have the panel. I don't even see the panel. So I just put the lights in. There's no panel. Let's see. The junction box, lights. Yeah, we just putting everything in. So when there is, unless we have to provide temporary power, of course we will, to make sure this works, because it's just like junction boxes for the drive-through. What's one? Yeah, civil set. Yeah, we were looking at that. Civil set, site demo, civil set, utility plan. So that would be our power coming through. Water. Where's power? Water. Let's just look on the list. We're looking for transformer. I'm not really looking. Now I'm gonna look. Sewer, grease, trash, existing, cap. This, that, and something else. No? Do we have a electrical site plan? Other than, Okay, no. So we're just, oh, panel A. It's just right there in the middle of nowhere. That's beautiful. Okay. So yeah, we'd have to get more details. Oh, there we go. Yeah, so yeah, shell, of course. We just had it floating out in the middle of nowhere, but it's gonna be somewhere, and we have to look on the. I'm sure it's shown on the utility plan. We'll find it before the lunchtime presentation. See, so shells are nice. And again, let's go back. There's a whole bunch of stuff. This is a shell for a Chipotle. See, it doesn't even say, but yeah. This is a shell for a Chipotle. That's going right there. Next to it, I think that's a hotel. That's coming up later. So yeah, we've got everything the civil said. Yep, 23. Right? That's what in the pickup window. And then we're going to do site demo this afternoon. We've got some site demo. We knock out some trees. And that's always nice. And we're going to stripe the parking lot. Yeah, it's going to be beautiful. And we've got some concrete, site concrete now, other than the foundation, right? So the site concrete is going to be on the civil set. Grading plan, I'm not messing with a grading plan unless it has the section view of the earth, and it does not. So when they send me that and ask me to do the grading estimate, nope, unless it has properly been section viewed so you can see what the existing elevation is in comparison to the one they want, and that's the only way I can do it. Now, they'll sell you a $1 zillion program that'll take all of this and claim they're doing it, but no, I'm good. Erosion plan, what's that? All of those fences, all that stuff. That's not really fun. But what is fun is the utility plan. So we'll do all of that later this afternoon, but right now, we are going to make sure we have everything for our framer and our final cleaner. Oh, you know what? For our final cleaner, I'm sure they're going to have to. I don't think they'll have to wipe down the exterior. Other than, oh, look, we left out windows. That's why you don't. Come on. That's why you don't do the estimate in one day, boys and girls. Because it's not due till Wednesday. All right. And so the framer has what they need, and all of this. This is that parapet wall. I'm assuming that I did get the roofer. Let's see. Fix what the roofer needs. Let's get the roofer valley flashing. That's always fun. And we don't care about spelling. And we want, and then sometimes we have to have this insulation like doubled and tripled over. The right valleys are lead us to water flows from the valley. Might be some parapet walls. I mean, some crickets in here, but it doesn't really say specifically. And that is another opening for our roof latch, roof thingy, so we can get on the roof. And that's where our ladder is on the other side. All right, so the roof is good. And what's 8? Let's see what 8 is. Canopy. Okay, we don't care about that. We're not going to install that. They have a vendor. All right, so we have our floor plan. And let's go to, because we've got our walls. Let's see. We got the roofing membrane. So not only do we have it that the 23 square feet, we've got to have the roofing membrane up the parapet wall too. So that's an extra. Let's scale that. 3/4 equals 1. Sometimes this stuff be off, but we'll try it. So the parapet wall needs to be in it. Oh, we did say it was Well, no, not the parapet. Well, not the. No, no. Let's see. And if you had questions, you couldn't ask me because I'm not paying attention. But next time we'll make sure we do. Let's see. Dimension. Because we want the additional, and we'll add that too. Because it's got to, they say go up and over, right? And that's the insulation. So it's going on top of the insulation. So we can stop right there, extra 5 feet. So extra 5 feet times 400 and what, 11? So that's a lot of extra TPO that you don't want to mess up or forget about. All right. I think we got it. I think everything. Insulation, we're going to go up the, let's just do this. Insulation. 14 feet, say 14 and a half feet times 411, right? That's the perimeter of the building. So we got pretty much everybody's takeoff. Just have to do more in terms of the foundation, or let's go, where are those shear walls? That was annoying the way that they did this. That was annoying. Let's see. Where's the foundation? Where is it at? Okay, no. Another thing, framer needs to know all of our doors, so we only have 3. And then the storefront, that frame really questionable. The aluminum storefronts, usually the framer doesn't provide anything but the hollow metal one, so that's another question. But if it's only the hollow metal, then it is one that is 3 feet 6 inches high, wide by 7 feet high, easy hollow metal, and only has to install that. And the storefront person most likely would install the storefront. All right, so we're gonna take a quick break until 11 a.m. to let it all sink in. We'll be right back. Okie dokie. We're going to get started again. We had to take a little longer break there. All right, so this is a shell for a Chipotle located here in lovely California. And we are looking for contractors to bid with us. And as you can see, we'll do your estimates for you. This is actually a shell of the building. It's not a complete interior fit out, build out, whatever they call it there. So it's just the site and the shell building. Makes it real easy. And so now, this afternoon when we present at 2 o'clock, we're going to do more of the pricings because we pretty much know how many square feet or whatever. We're going to do all from assembly pricing. So we won't break down the individual pieces of, say, like the foundation until we're ready to win and do the work and get an actual pricing. Foundation assembly prices should not be much different than individual pricing of the concrete, the rebar, and the formwork, and all together. The assembly price should not be much different. So, all right. So here's the demo plan. So it has it's in the middle of somewhere, and we have to get rid of some things first. And so let's see what 5 and 6 is. Protect. Let's see what we're removing. All right, so 1 and 2. Okay, so removing a tree, it's important to know the size of the tree. And we go by the diameter of the stump or the base of the tree. That diameter of that tree, that's how they base, either putting it in or taking it out. Okay, so that's important to know, and if you don't know, it's important to find out. So can you just pull it up, right, with very little effort, or you got to cut it down? Those kind of things makes a huge difference in the world of construction. All right, so 1 and 2. Where's 1 and 2? Do we have a lot of 1 and 2? Not really. Okay. And so if this is dirt, then we don't need to saw cut anything. I don't know if it is. This may not be. On this side, this is probably. So we'll saw cut that. Include the price for our demo for saw cutting this, because this is really attached to something, just like maybe this is. I don't know. But what's the scale? On these plans, scales in a funny place. Here we go. 1 inch. Oops. Cancel that. We don't want that one. 1 inch equals 20. There we go. We agree. And so we're going to demo. We're going to 1 and 2 first. So we're going to demo curve. And in this case, we don't care if it's curved or straight. And in an afternoon session, we will be going over actual pricing. Okay, so now we want to saw cut because we don't know. We can delete that if it's no need once we win. So we think that's connected to something, but that doesn't appear to be. And so now we're going to demo. Let's just say remove concrete. We'll assume that it is reinforced, because that's how we price it. It's priced different if it's reinforced. So we're going to go like this. There we go. Come on, don't fail me. One and two, one and two. Yeah. Okay, so there's a lot of protect. So we just going with what we see remove and see that's a big tree. Those are two big trees. Huge trees. So we have to get more details. But remove tree. Big. We'll assume that it's the biggest that the cost book gives us. I think that's 24 inches around. Alright. I think those are the only two trees. And what else is remove? Remove is property line per lot adjustment. Remove property line. I don't know that applies to us. That's property line is just set. Yeah, we'll ignore that one. Let's see. So you give some time for field verify. Violate and sewer main exists. That's your property. Okay. So we give an hour for that. Field verify location. Hour. Field verify. Hour.